Well, that goes to show just how far this market goes, right? It spans the entire globe. And that collaboration is going to be key to making it successful, right? So some quick housekeeping. Again, to reiterate, 20-minute presentations. We'll have 5 minutes for Q&A. At the 2-minute mark, I'm going to stand up there and give you a little warning. And if you need a little extra time, we have some buffer. But the key point is questions, talking, communications, interactions. So hopefully, if you want to follow up, get time afterwards, go network. Again, cell phones, please turn them off. You need to take a call, step out into the hallway. If you want to go network during talks, that's fine. Take it out to the hallway where you can do it and not disturb the speakers here. We'll ask the speakers to come up on this here stage right and exchange spaces there. Then we can pass off the microphones and the clickers as needed. Also, the bathrooms are in between here and the restaurant. All right, so a quick intro about myself. So I'm a classically trained chemist turned entrepreneur about a decade ago. And I spent years taking new technologies, building them up and commercializing them in a variety of markets. So, and that's what really this market needs is innovations to make it grow. And like I said, collaboration is key, not just the technology, but the regulations, private public partnerships. And all that is how it's going to be successful. And we've seen a lot of change, over the past year alone in this industry, from battery chemistries, vehicle types, refining, manufacturing, et cetera. A lot of ups, a lot of downs. We've seen failures like Northvolt go bankrupt, huge issues with manufacturing. We've seen recyclers come online just to go out. So my take is a lot of this is happening because they're not getting that collaboration. Everybody's trying to keep their cards too close to their hands and be the only one doing it. We need to have information transfer. That way we can all win. Build the market together, we can all be successful. So please network today. Go talk to your colleagues, talk to your peers, exchange information, exchange cards. So if you don't know someone at your table, say hi right now. Meet them, exchange cards. What you're going to learn and what can come out of it. So please take the time, network, learn from each other. Great. All right, so with that, I would like to invite our first speaker up, Lucas. He's the COO of Battery Electrical Company with many, many years of recycling and metal recovery in general. And today is going to be talking about recovery, circularity strategies. I'll let you take it from here. Okay, you choose microphone you want. Walk around. Stay on the stage. They're recording it. Only post on the stage. Thank you very much.
So, thank you very much for the great introduction. I'm glad to be here and happy to tell you today how we see the circularity of batteries and which kind of strategies we developed during the last years, and how we can offer solutions to the market by approaching the battery with different ideas and not just the material recycling. That one. That one. Okay. Both. Okay. Everything fine right now? Yeah. Great. So how we approach upcoming challenges and come up with solutions there. My name is Lukas Brandl. I'm part of the management team of the BLC. The BLC Battery Lifecycle Company is a joint venture between two companies coming from different industrial fields. On one side, we do have the Rhenus Automotive, which is a service provider to the automotive industry. I mean, automotive tells you already, they are active in that field. And what they are doing is that they offer solutions in the field of logistics, but also taking over assembly steps for the car. So for example, they do the assembly of the full Corvette car in the US. They produce or assemble the X5 Exiles of the BMW in China, but are also active in Germany by running parts of the plant of the factory 56 of Daimler in Sindelfingen. On the other side, we do have the TSR, which is a big metal recycling company in Europe. They do have around 170 facilities in Central Europe from France to Slovakia. Their goal is it to produce high valuable recycled material, which can be directly fed back into the material loop to produce green materials out of it. And in between, and when we look on the battery, we saw 2 years ago that there was a big gap. And that's why we created the BLC as a company offering solutions along the life cycle of the battery from the moment when the battery comes from the production plant as production waste, for example, till the moment when it comes from the consumer as waste, or as a used or defect product, to offer solutions there and not just look on the recycling itself. We set our goal in creating new solutions there by offering repair, second life solutions, and so on. But first, let's go to the battery demand. I mean, we're here on a conference talking about electric mobility, electric vehicles, and batteries. So you may know all that the battery demand is growing in the next years, and that we have different sectors which will grow in the next years, and that the mobility, so cars, vehicles, will be the biggest stake and part of the cake in the growing industry in the next years. On the other side, that means that we will have a high demand of resources in the future, and that we need to set up as quick as possible good and resilient supply chains to supply batteries to our customers and to the industry itself, and in the end, of course, to us as the users who will use the batteries. So we see a growth of around 6 times from 2020 to 2030. The statistics differ a little bit, but I think the biggest part of it and the most important part of it is that there will be a big growth, and that means that we all need to work in that field. On the other side, we see that the legislation is growing and looking in the field of batteries as well. And we see here a time frame for the next years and for the upcoming topics which come from the legislation in Europe to all the participants of the supply chain. I want to stress out 3 points. First one is that the battery passport will come up in the next years, which means that we have, for the, I would say, first time, a digital passport for product, which offers all participants of the supply chain necessary information to work with the product and offer different solutions, which means you can look deeper in the topic of repair. You know what happened to the product during the lifetime, and it will increase the growth in the field. But also with that, some more challenges are upcoming. So the question, how can we implement the battery passport on the battery, and how can we implement the systems to the company systems in the future? Second part will be the declaration of the recycled content. So we are all forced in the future, if we want to produce batteries, or if you want to produce batteries, to show how high the recycled content is inside of your battery. And with the third part, we all need to fulfill recycling quotas in the EU from 2031. Sounds like it's far away in the future, but it isn't. It is almost tomorrow. And that means that we all need to work on that together, see the full supply chain as a circle, not as a linear process, to fulfill the requirements from the legislation and close the necessary gaps which we see there at the moment. Due to that, I picked a screenshot from the battery news, which are a good source to see, okay, how is the development in different fields of the batteries in the EU at the moment, or I think they increase their portfolio by offering solutions and maps like that for the whole world. And we saw during the last years that there were a lot of announcements coming up by announcing that companies decided to go in the field of battery recycling, go in the field of battery production. You already mentioned that some of the projects didn't work, like the Northvolt project, which has some issues at the moment. But also we see in the field of batteries recycling that many companies are increasing their volumes, and that many shredding facilities are starting to work right now. So the portfolio and the offer of different volumes is increasing at the moment. But here we see mainly the field of material recycling. And so circularity is not just material recycling, it is a bigger approach, and it offers us more solutions and possibilities than just closing the loop on the material side. I want to stress out the topic of reuse, which means that we take the product, that we take the battery, look on it, test it, and then may bring it back into the product loop, so back to the owner, or repurpose it by bringing it in second life solutions. And also, I want to stress out the topic of repair. At the moment, less of the batteries which come from the market are going through a repair process. So if a part of a battery breaks, the people decide, okay, I will bring the full battery pack to the recycling. And they do it if just a small fuse is broken or just some cells are broken. And from our perspective and our opinion is that we need to focus on the design for circularity, the design for repair, to have more possibilities in the future by the opportunity to repair a battery, because with that we can cut down the after sales cost or the total cost of ownership for the owner in the future, and offer new solutions. So how do we see the product life cycle? I mean, in the middle you see the linear economy, which comes from the raw material, which is then produced to material which can be used in the production of a product. And in the end, it goes to the user, and after it goes as a defect or end of life product back into the recycling market. We as a BLC said, okay, we want to step at the last point of the life cycle of the battery by offering the second life solutions and the so-called pre-treatment solutions. What does it mean? Pre-treatment is for us taking a battery in, doing a dismantling service on it, so taking out the modules, taking away the copper, taking away the aluminum and steel, and then test the modules themselves to decide which ones are good to bring them into a second life solution, or which ones of them are bad and not usable anymore to bring them in the final recycling. For that, we do a deep discharging. That means we're taking all the energy which is stored inside of the module and bring it back into the grid. And afterwards, we have a safe, totally discharged module, which then has a lower risk of causing a fire or causing damage to people touching both poles. And we bring it then to the shredding facility who will do the next part of the treatment. Or the second possibility is when we did the testing and decided, okay, the module is still good, then we bring it into the second life market to create battery storage systems out of it, which can be used for renewable energies or as backup storages for industrial companies. But we want to increase the cycle as well by offering solutions like repair and spare parts. As I told you, the repair business at the moment is pretty small because the industry is more looking to find a solution for the recycling circularity, but we see that it becomes more and more interesting for the automotive industry to have repair solutions in place. The topic of spare parts is already running by offering parts of the battery back to the producer, like the battery management systems, like connectors or other parts, which were not available due to the problems with the supply chains during the last years. So the war in the Ukraine, we had some ships stuck in channels, and because of that, some of the parts and components were not available during the last years. And last but not least, and that is for me part of the, let's say, Champions League for the future, we see a possibility to do some remanufacturing, which means that batteries coming from the market, batteries coming from the production, declared as a production scrap, declared as defect, can be recreated and requalified to bring them back into the production and then afterwards back into a new car. That is a dream and that is a vision we're working on, but I'm convinced that it will be possible in the future. But I don't want to talk just about solutions today. I want to talk about challenges in the field where we are active right now. And we see 4 very big challenges upcoming in the next years or which are already there. First one is a pickup of batteries from the market. At the moment, it's pretty easy because most of the batteries come as production scrap. So you have production facilities where you store the batteries at your waste yard. And at one point, you have enough material to put it on a full truckload. In the future, it will be a very broad pickup by having many suppliers who supply you with waste batteries or defect batteries from the market, by having a garage, by having a car dismantling company, by having a dealer. And that means that you need to find efficient solutions to pick up one battery at one point. So you need to find solutions to cut down the logistical costs. Second one are regulations. So that is a very big jungle and everybody is discussing about it, which regulations are upcoming in the next years, which regulations are now active already for us. And that follows that many participants are very unsecure at the moment how to act there. And that they have a big lack of information and knowledge in that field at the moment. Plus, when we talk about waste, we have very strict waste regulations here in Europe. For example, by transporting a battery from one country to another one to a recycling facility, you need a notification. So that lasts more than 3 to 4 months to get the permit to transport batteries via countries. Third one is a very big variance. So every OEM is producing not one standardized battery. Every OEM is producing many different kinds of and types of batteries by using them for their applications and for their use cases. And that follows that the recycling industry and everybody who's active on the after sales market needs to be very flexible to adopt to the different kinds of systems coming up from the customers. It is easier again when it comes from one production facility because there you're expecting one type of battery coming. But in the future, when you have the different kinds of pickup and stations of pickup, you will have a lot of batteries coming from there and all of them look different. So you're talking about a batch size of 1 when you're unlucky and you need to adopt it and you need to adopt your processes to it. And last one is a classification of the battery condition. When we go back into the old times of ICE vehicles and combustion engines, that was pretty easy for the people to say, okay, I can hear that the vehicle will last the next 10,000 kilometers, the next 20,000 kilometers. With the battery, it's a little bit different. People are unsecure and don't know how to analyze the condition of a battery and say, okay, that battery or the car in front of me will last 20,000 kilometers more or 50,000 kilometers more. So that has a big impact on the used car market at the moment. And we see that leasing rates are increasing rapidly because no one is sure how to sell the car after 2 or 3 years to the next one. Coming back from the challenges to solutions, because we have some solutions in mind for it to solve it. And our idea is to say, okay, at the moment, as I told you, it's pretty easy to collect the material because you have one-to-one relations by taking and picking up full truckloads. In the future, we will have disseminated pickups by having more than one pickup point. So we need an efficient logistics in the future. And the idea, I mean, it sounds simple, means you need to be as close as possible to your customer to cut down the distance the truck will drive and the time it will last to pick up a battery at the customer site. And for Germany, we said, okay, if you look on the German map and you can copy it to other European countries, we talk about a distance of around 250 kilometers, because with that you can easily pick up the battery within 24 hours. It's more or less a day ride for a driver to pick up one battery or to do a milk run and pick up more than one battery on one drive and be efficient there. Plus, with having hubs where we collect the batteries as products and as waste. We have the possibility to decide there what to do with the battery and decide should it go into the material recycling, so to the right side, or should it go back into the market as a repaired product, as a remanufactured product, or as a second life battery which can be reused in other purposes. On the material stream side, and I know that looks a little bit complicated, we're talking about efficiency as well. Because I can do a lot of analysis and testing on a battery, but every step I do on a battery costs everybody of us money who is participant of the supply chain. So we said it's necessary that we have an easy diagnostic system, which gives us with easy steps the solution and the answer in which condition is a battery. We always start with a diagnosis level 0, which means, okay, from a visual perspective, is the battery in a good condition or not? Did it see any fire or heat? So do we see the results of some issues harmed the battery in the past? And we do some easy measurements like insulation, like voltage, to decide if the battery can go directly into the recycling loop, which is here, or should it go into the next decision point, where we do deeper testing to figure out if it can go into the reuse, or if it's still good enough to bring it into the recycling, into the repair loop. And then step by step, the colleagues are doing the diagnostics, and afterwards we have clear streams where the battery can go to, and what is the purpose or the next purpose of the battery in the future. And I showed you some nice PowerPoint slides, and I have just 1 minute, 56 seconds left. I prepared a small video to you that we're not just a company showing you slides and pitching topics like that. We already have active business. We do have 2 locations in Germany, one in Reda Wiedenbrück, which is close to Dortmund, where we have a capacity of around 2,500 tons of batteries per year. And then since last year, we have a new facility in Magdeburg with a capacity of 15,000 tons per year, where we do the pre-treatment and the selection for the second life business. The repair business is still some kind of a PowerPoint bingo, but I really want to stress that topic out because I see there a big potential for everybody, for us in the future. So the difference between both sites is that the smaller facility in Reda Wiedenbrück was some kind of our pilot hub where we started learning how does a battery look like, how can we implement processes in the future, and how can we optimize and automate the process itself, because it's mainly manual. And with that machine, we have one of the first automated discharging lines in the world, which will do the discharging by itself, controlled by temperature, current, and voltage, to increase the security of our process and to stabilize the throughput and output material flow for the process itself. So a very short video, but I've just 15 seconds left, so it almost fits. But one last conclusion in the end. I think we all are convinced that circular economy is very important for all of us in the future, and that we shouldn't just think about the material recycling, we should think about other strategies and ideas, how to interact with the after sales market. And what we see on the right side is that the supply chains need to be supported with the recycling and need to be reported with circular strategies by keeping products longer in the loop, which means in the end that the primary resource demand in the future will be a little bit less, and that the curve between the demand of lithium here, for example, and the existing supply isn't that big, and the gap isn't that big. Thank you.
Any questions, please raise your hand and Maria will bring you a microphone.
One
questions here.
Good morning. Thank you. That was very interesting. Julianne Adams, I'm the Secretary General of the European Battery Recycling Association. I was just wondering if you'd considered the impacts of the proposed changes to the list of wastes that will make lithium batteries hazardous as well as being dangerous under ADR, because that would impact where you might be storing them and obviously where you're sending them.
Yes, of course, it will.
Because you'll need a different permit.
You need a different permit. Our idea regarding that was that we started with looking on the battery as hazardous good or hazardous waste. So we already did our permits in the field of hazardous storing and treating. But it will be a big challenge for everybody who did his permit in the past by looking on the battery as a non-hazardous good and non-hazardous waste. And that means that there will be a lack of time where the people and companies need to invest time and money in getting the necessary permits to treat the batteries in the future. Yeah.
Minor, please state your name and your company. Next question, that'd be great. Here.
Hi, thanks. So my name is Sujiva. I'm from Mobility Alliance Sri Lanka. Do you think that the battery manufacturers and designers are paying enough attention for the recyclability other than the range and the density, energy density or whatever? So I don't see any data. They are paying enough attention, and if they do so, what percentage of R&D goes into the recyclability?
Clear answer, no. They didn't in the past. What we see is some kind of a development, and that it becomes more interesting for the manufacturers and designers to think about new strategies like design for repair, design for recycling. All the upcoming regulations push them in that kind of direction, that they start talking to the recyclers. How can you recycle my battery, and how can you increase the recycling efficiency of your process? And what can I change there? At the moment, we see that the new battery generations with a cell-to-pack design and glued design are more moving away from the strategies. But I hope that that is just a phase and that we will move into a better design phase in the future. But the actual design is not very good for all the steps we want to do.
I got time for one more quick question.
G'day, Sean Joseph from Altilium. All these challenges, does this move you towards more of a country by country solution for battery recycling rather than having 3 to 4 month windows of getting permitting across borders and having a domestic focused, say in Germany and then other regional countries?
I would say it's a combination of both. So you need to look into your regional permits and your regional laws and legislations, but you need to also think about bigger regions. For example, the final treatment by shredding batteries makes less sense to place facilities all over Europe in every country. So placing a shredder in Luxembourg makes less sense. So you need to think, how can we solve that kind of logistic challenge in the future and move the material in a smart and clever way to the correct production. But the pickup itself and the, let's say, pre-treatment is a country-related topic for me.
Great, thanks. Well, thank you, Lucas. If you have any further questions, you can meet up during the networking break.
Thank you.
So next up, we have Anya, the owner of AK Consulting. Really, she's expert in everything end-of-life vehicles, sustainability, circularity, regulation, taxes, environmental impacts. Probably easier to explain things you don't do. But today is going to really bring it all together, focus on the vehicle side versus the battery side. I'll let her take it from here. Thank you.
That makes it sound really fantastic. Hello, good morning, everyone. I'm here today actually for The Elves, which is an Irish company focusing on or being founded in order to take up the manufacturer's obligations regarding end of life. At the time when it was founded, I was still working with Opel GM, and I was part of the founding process. And in the end, after I'd left Opel, I stayed on the board of Elves as an independent director. So yeah, we are the compliance scheme for ELVs and have been operating under ministerial approval since 2017. Founded, the company was probably in around about 2015. It takes quite some time before you actually get approval. So producer obligations under the regulations, as you know, are still quite different in each country. So this is a specific Irish solution. That's the network that was needed in order to comply with the regulations. So you have ATFs contracted in basically every part of Ireland. Northern Ireland is not covered here because that belongs to the UK. So it's not only to collect vehicles and in the end treat them, but also to promote the right way of recycling within the country. And of course, do everything that is necessary in order to keep ATFs on track. So Electric Elves is a voluntary initiative of the Elves because we found that there's electric vehicle batteries coming back and the ATFs don't really know anything about it. And I think the best I saw was a battery taken out of a vehicle on a forklift and it actually fell down. And we thought, okay, we need to do something. We need to inform, we need to raise awareness, we need to do training for the ATFs. Otherwise, this is going to end up in a real disaster. Out of that, there was a need to, we felt the need to assess what is happening with the value in electric vehicles, and also how can we determine where the actual value in an electric vehicle is in order to help ATFs find the right way to treat those materials and also to take them out of the car without breaking all of it. That kind of helps with the value. Now, as you can see, electric vehicles are increasing also in Ireland, even though it's a very small market, but yes, they are increasing. There's a little drop in 2024, but I think that was in basically every country. So no big worries about that. There's a huge knowledge gap at the ATFs. They know how to treat traditional vehicles, but they are still very unsure about the values in electric vehicles. In order to find out a bit more about that, Elves applied to the EPA's Green Enterprise Fund for this Electric Loops project that was granted at the end of 22. So the project itself happened in 23 and early 24. Results are, the report is almost available now. So this secured the funding of the project itself. The idea was to find or develop a data matrix in order to understand the reuse, remanufacturing, recycling data. This report was basically ready in April last year and is usable now to get the information out to the ATFs and the metal recyclers overall. Now, it was also done to create a data set to help the policymakers and in making the future, meeting the future requirements and understand how all this is put together and works. This report is basically complete, and the discussions with the department are ongoing. So here you can see the form that we used. We started with the depollution of the vehicle. There's still some depollution work to be done, even on EVs, and dismantled the EV specific parts. So there was a lot of consultation with the ATFs who took part in it, the vehicle manufacturers who helped with information, the metals and electronics recyclers and the remanufacturers. Parts needed to be identified, the metrics needed to be set up, data collected, and also it needed to make sense in the end. So what happened is we organized eBay listings with parts taken out of the vehicles in order to check where the demand is and which parts are still available after a certain amount of time. So that's the eBay analysis that had to be done. There's a report, oops, sorry. There's a report available on the website of the ELVS for you also to check later on. Of course, everything starts with the battery removal. That's, I think that goes without saying. But the importance of training, equipment, and information had to be reiterated several times to make sure that everything is done in a safe way. You, at least if you're dealing with Europe, you're probably familiar with IDIS, which is the information dismantling system that is provided by the VMs. Now, every manufacturer has its own language, so to speak. There is the attempt to create something that is as similar as possible, but in the end, it's within the responsibility of each OEM. So the language used can be a bit different from one to the other. Just as an example, some manufacturers still use engine oil in the electric vehicles, and it actually should be gearbox oil, something like that. It's small things that can make life fairly difficult for ATFs. One of the results also was that the removal of coolant out of the car can take longer than on a regular or traditional vehicle. So other best practices, we found out that there are a fair few different names for similar parts. Some parts are combined in some OEMs. They are in different locations than what ATFs were used to be. And the differences can vary between marks and models. Also, the connections were a lot more brittle than what we had expected. So in the end, the accessibility is an issue. I think we were already talking about design for recycling, and a passport for mandatory parts would be nice to have. So yeah, highlights in terms of sales, that's results of the project. You can see where the parts are going and what is the most valuable within the vehicle. The battery remains the most single valuable part, and there are still enough other bits and pieces that makes sense to be sold. So we had 2 vehicles in this test. Doesn't sound like a lot, but then there's simply not so many vehicles coming in. And this is a bit of an overview of what was sold and for how much in the end. What we also found is that some separation activities resulted in breaking the part. So there's still a lot more experience necessary. So this is this simply shows the potential demand that we either found or estimated in some areas. I think that is quite self-explanatory. In terms of remanufacturing, currently batteries are remanufactured, we all know that, and the compressor for the, no, oh my God, air conditioning is remanufactured. In the future, there's a lot more that has potential for remanufacturing, but volumes are still too low to go into that in sort of mass production areas. So for recycling itself, recyclers were provided with the basic data of parts where possible, and those parts, usual ATF activities, I would say, those parts that are not usable for resale were broken down and in the end given for material recycling to use the material setup. So this might be probably not really a surprise that main part of the battery is copper-coated aluminium, and all the other bits and pieces in there. It was not a surprise, but interesting enough to see it in reality from an ATF point of view. So where's the value? In the cables, the modules, the electric motors, inverters, and heaters. That's basically the main finding, which again is probably not really the biggest surprise of all. Another table, key parts. You can see that the percentage of parts that were no longer listed after 3 months on eBay varies, and the green ones are those that are selling fast. The red bits are not really selling very well. And again, our estimation of remanufacturing likely in the future, yes or no. So I'm a bit ahead of time. I hope that doesn't matter too much. This is for you for checking the website, downloading the information from the website. This is obviously in the presentation that you get afterwards. So
Thank you, Anna.
that was it.
Still have time for questions. Reminder, please state your name and the company you're with. Question over there.
Yes, thank you. I'm Julianne Adams again from the European Battery Recycling Association. I'm interested to know how you are going to work with your ATFs, or you comply with the reporting requirements of the first battery recycler, because they have to report on all of the upstream removal of all of the parts, the plastics, the components and everything else. And I'm really interested how you think you might be able to do that. And also selling on eBay, which I think is what your slide said. in terms of ADR. So how do you manage the ADR requirements for the movement of batteries and storage? Yes.
Yeah, this was a project, so that was a start of everything. Regarding reporting requirements, we are working on that, and we are currently looking at a second part of the company that is only dealing with batteries, but all that is currently in process and hasn't been completed yet. So the details will come step by step, I must admit. It's we are currently not obligated party, and we want to set it up to be the obligated party in order to get ministerial approval and deal with that part of the business.
And sorry, and so the ADR in terms of the movement of lithium batteries?
That is done through contracted partners. We are not doing it ourselves. We are just sort of the organizational company on top of it.
Via eBay? How are you assuring, if you're advising the ATFs?
We're not advising to sell via eBay. This was just
Okay.
a test to see what happens. If you have something, what can you do with it? Where's the value?
Okay. You might want to rethink just because the legislation would be so complex. And if you're taking on that responsibility and liability, then that's a massive issue. And also it's very difficult to move lithium batteries from the Republic of Ireland outside of the Republic of Ireland.
Yep.
Those ships won't allow them on the border.
We are aware of the problem. We don't have a solution yet.
Any other questions? Well, I have some. Do you have any education for the ATFs? Like, how do they know what to do? Do you reach out to them? Do they know to call you? Do they just Google and find somebody else to deal with it? Or
No, both actually. We are in pretty good contact with our ATF network, and so they are continuously informed of the possibility to do some high voltage training through us. We are working actually with a UK company that is still out of times when the UK was still part of the EU. Now, in order to have certified people, you need somebody from an EU body to certify the training. But anyway, people can go for this training. We can't force them to, of course, usual problem, but if they want to deal with it, yes, they should have proper training, and also we are supporting them in finding the right equipment.
got a question over here.
Arndt Böhler, Daimler Truck. Do you think the situation in Ireland is representative for the other European markets?
I wouldn't have a clue. No, seriously, I don't know. And I wouldn't want to give any wrong information. This was a project specifically for Ireland, 2 vehicles. So that in itself is probably not very representative, but it's a start. But as the Irish market is different from most other European markets, I would assume that it's not quite representative, but I don't know.
Do you have a scrap policy by the government, and the government giving a rebate to these car owners when they hand it to your project as such? A payment for the car owners to compensate?
No, it was only 2 vehicles, and they were given to us through ATFs that we worked with, and the funding of the project was supported by the EPA, the Environmental Protection Agency of Ireland.
What happened to the original value of those cars? Have you compensated? There should be some value in this car.
Yes, well, the value went back to the ATF it came from.
The government has no scrap policy, I mean, handing the vehicle to.
Currently, no.
Okay.
Any other questions? Okay, we got one more for you. Logistically, right, you got the value of the car itself, value of the components, the battery. Who owns what part of it? 'Cause I know the EU's looking at OEMs, the battery owns the battery throughout the life cycle. How does all that take place on the island, and does it cause any challenges with recovering value from these vehicles?
The challenge with recovering value of vehicles on an island is always the water around it. And that is basically the same for internal combustion engines or electric vehicles. Ireland has the additional challenge of not really creating large volumes. So it's, in the end, a lot of the material is going to the UK still out of old connections, of course, and getting the information back then from those shredders and all the material is not that easy. But yeah, this is nothing specific to the batteries problem.
Great, thank you. Let's thank Anya again. Now we can bring up our next speaker, Dr. Xiaohan Wu. We have what, decade plus experience working in the battery industry, from R&D of new battery chemistries, and recently focusing on business models. How can you elevate the business models in manufacturing to the next level? The floor is yours. This one works as well. Red light is working. Stay with the stage. We're being recorded up there.
All right. Fine. Good morning, everyone. Pleasure to be here, joining this round of experts on EV aftermarket and recycling. I would intentionally stay with my presentation on a rather high level because I think there's so many experts in this one who will deep dive throughout these next 2 days on various topics of battery aftermarket and EV recycling. So my topic of today is the business opportunity in the entire battery aftermarket. And this image is going to be the third time today you're going to see the depiction of various modes of EV battery revival. This is our Porsche Consulting target picture of the battery aftermarket, and I will go through all the details along the presentation. Maybe a few words about Porsche Consulting. I'm sure everybody knows about Porsche as a brand. Porsche Consulting is a 100% subsidiary of the Porsche AG. However, we are an independent management consultancy working throughout the entire supply chain of the battery industry. As part of Porsche AG and also strongly associated with the Volkswagen Group, we are working closely with our brands, so all the vehicle brands as well as commercial vehicle brands, but also have direct access to our battery investments as well as so to say, external investments. In our projects, we work in the battery industry throughout the value chain, from the OEMs to system manufacturers, to material suppliers, to the mining companies, but as well more and more into the aftermarket with the tier 1 suppliers, but also with equipment manufacturers and startups alike. Now, we've heard a lot about EV ramp up, and of course, we have our own perspective. Unfortunately, I saw some number from McKinsey. Here is just our forecast towards 2035. We will expect somewhere around 60 million vehicles on the road, majority coming from the automotive, but also with growing numbers of the commercial vehicle sector with significantly bigger battery sizes. However, the EV production volume going to ramp up. We are going also to see a strong ramp up in return volumes. So on the right side of the chart, you will see a rough number to take home. So we expect by 2040, the accumulated battery return volume to be amount of 45 million tons of batteries. Just to give you a feeling how this would look like if you would pack all these batteries into containers and pack them into a train, this would be a circumference half of the globe, which yeah, it's 2.1 million containers roundabout. When we talk about battery aftermarket and so to say end of life scenarios of batteries or EVs in general, we like to separate the discussion between the vehicle itself and the battery due to the complexity and also the value of the high voltage battery system. So on this chart, you see on the top part a typical lifetime of a vehicle. This is let's say in a general case in Europe, somewhere around 15 years of the first life. And in comparison, already today, batteries live longer than the vehicle. A little bit longer for the typical NMC batteries, which is today still the majority on the road, but for sure much longer for the lithium iron phosphate battery, which will outlive the vehicle by far. So what does that mean for the aftermarket of the battery? Well, for the NMC battery, if we would directly recycle them, we're probably gonna get a lot of value from the metals, lose a little bit of the service time. But for the LFP batteries, which has a much longer time, we would practically destroy a significant portion of the functional value and do not utilize, so to say, the battery lifetime as it's given by the chemistry. So therefore, our main thesis in this presentation is we need a holistic aftermarket approach to fully recover the battery value after vehicle life. I think this sentence has been dropped by the gentleman from BSC already. Recycling is not the only solution in the battery market. We distinguish between 4 R's in the battery market. That is repair. I think that is clear to everyone. Refurb, that is basically bringing in a new product into the same application, meaning if I recover a battery from the vehicle, I would re-put those batteries after certain treatment into the vehicle. Repurpose, that is product into a new application, so vehicle batteries into stationary storage or into two-wheeler applications, and recycling, I think this is clear to everyone. Throughout my presentation and the coming slides, I would address 3 questions. Number 1, which are the business opportunities in the battery aftermarket? What are the challenges for players entering the battery market? And last but not least, which actions need to be taken by the value chain players? Coming to the first question. We do see today and also by 2035, the recycling market is going to be the biggest one among the 4 aftermarket segments with 18 billion euro value pool by 2035. Today, recycling is mainly driven by the scrap market, so to say cell scrap, also pack production scrap, and also to a certain extent, cathode material scrap. But by 2035, this ratio between scrap and end of life battery will switch, and we will see significant portion of on-the-road batteries coming back towards recycling. But value pool is not the only number we should care about when entering the market. We need to look at the competitive landscape as well as process complexity. And by taking into account all 3 factors, we do see a significant market attractiveness for new entrants into the refurb market as well into the repurpose market. Why is that so? Because recycling, even though it's a big market, is dominated by large chemical companies with specific know-how and very asset heavy, whereas refurb and repurpose are closer to the traditional mechanical manufacturing and has a slightly lower entry barrier for traditional manufacturers. Still, there are some challenges towards market entry. And we identify 6 key challenges for players to enter the battery aftermarket. Number 1, we heard about this briefly in this morning. It's the battery access. Today, everybody is happy if we can get rid of our batteries. So recycler take their batteries, recover the value, everybody's happy. In the future, we expect strong competition for the ownership of used batteries. The OEMs have intrinsic interest to recover the value as this is a significant portion of the vehicle value, but also the recycler will try to keep the materials once it's in their hand. Number two, that is diagnostic and sorting. This is all about the precise determination of the state of health and also the chemistry of the battery to make the right decision in which aftermarket segment should we send those scrap batteries. Number three, technology variety. We heard about this also from the gentleman from BLC. We see a growing options, not only in battery chemistry, but also in format, in system design, and all of that have a strong impact on which revival method should be applied on to the batteries. Regulatory compliance, I think is self-speaking. We have in Europe at least a very good recycling regulation in place. However, for the repurpose and refurb markets, I think there's still work need to be done. Last but not least, two other things I think is for every market entry strategy applicable, that is ramping up the right competence once the market segment is identified, and also watching out for the competition when we enter the market. For now, I would like to deep dive on the topic of battery access, as well as the diagnostic and sorting topic. As I mentioned before, by 2035, the battery aftermarket will not be only production scrap, but will be a very well-balanced volume between the different, so to say, battery return scenarios as you see on the chart. We will have significant portions still on production scrap as the gigafactory are still ramping up and new gigafactories coming online. A big portion of the volume from the feedstock will come from accident and technical failure vehicles with various service life. We will have vehicle end of life, meaning batteries which are still good enough for use, but the vehicle itself has reached its end of life. Then we will have battery end of life, which means those batteries for some reasons didn't last as long as the vehicle, and basically the vehicle need a battery change. And a very small portion will still come from the pre-series batteries. This is today a big topic because we are developing a lot of new vehicles and a lot of batteries being tested and scrapped during the development phase. And for all those battery return scenarios, the access point is different. Just take a look at the OEM. We as OEM have a privilege to access the technical failure accident vehicle at least within the warranty time through the dealer network, and have a very good control over the pre-series vehicles. However, once the vehicles are on the road, we are and out of the warranty period, we are very much dependent on the independent aftermarket and the relationship to the junkyards to recover vehicles over the lifetime. The recycler on the other side could have very good access on the end of life business if they are operating also the junkyards and collection points. And if you take a look at the cell and pack suppliers and component suppliers, even though they have probably the highest competence, they will have a hard time to directly access batteries once they have been produced. So the call for action here to the entire value chain is looking for a strong partnership along the value chain to safeguard feedstock access, to maintain as much, to safeguard as much volume as you can. On the diagnostic part, the key question is SOH determination. I will get to this in a minute. Beside the SOH determination, there's a couple of factors to be considered when it comes to decision-making, which aftermarket scenario to be applied on the battery. So on the technical feasibility side, we look at system design, we look at the mechanical condition, we look also at bonding methods, whether or not the battery can be disassembled. Just to give an example on the system design, for sure for recycling, it doesn't matter. We take a high voltage battery and then we basically put them into the shredder. Doesn't matter how it looks like. But when we want to refurb or repurpose the battery, we are forced to do some extent of disassembly. That is easy to do for today's modular system. We can, take them apart, module by module. But as we look at highly integrated systems, cell to pack, cell to vehicle designs, this will become harder and harder to do when we want to take the battery apart. Now coming to the state of health topic, for sure, the higher the state of health of the return battery, the more attractive it is to do refurbishment and repurpose of this battery, and the lower the state of health, the more people tends to do recycling. However, the precise determination of state of health is today still a challenge. We do not have a very efficient way to tell what is the state of health of the battery. Typically, the methods are still time consuming, and the entire battery is highly specific, dependent on the chemistry, on the manufacturer, on the cell design, and the pack design. Today, we do not have any standardization, but there is a silver lining, and that is the EU battery passport. With the passport, we expect to have higher transparency on the battery information, and also a quicker SOA check as the battery basically fully digitalized. I want to conclude my talk with the following call for action to the entire value chain. So to access the different aftermarket, each of the value chain player has specific interests. For us as OEM, for sure, the main interest is in the repair and refurb business to guarantee the after-sales opportunities. To some extent, we of course look at recycling for sustainability motivation, but also regulatory compliance. Our homework here, for sure, is the design to revival, as we said. So believe me, everybody is looking at how to not only bring down the battery costs and bring up the energy efficiency and energy density, we are also looking at the repairability of the battery pack. For the recycler, of course, the focus is on recycling. And here, I think the key is to fully master the chemical know-how and have a, so to say, efficient plant at scale. For repair shops, the battery access is key. For the cell and pack suppliers, they should utilize or enable the entire value chain with their battery know-how in terms of refurbishment, repurpose, and recycle. And also for the tier 1 suppliers, the component suppliers, their existing after-sales distribution network will be a USP when it comes to activating the refurb and repurpose opportunities. With that, I would like to conclude my talk and answer the 3 questions I posed at the beginning of the talk. The aftermarket value pool will reach 30 billion euros in 2035 globally. Refurb and repurpose could offer an untapped potential for newcomers. In terms of challenges, we have identified 6 strategic and technical key challenges, out of which battery access and SOH estimation is crucial for business success. In terms of actions need to be taken, aftermarket players will first need to define their aftermarket focus and ramp up competence accordingly, and partnering strategy and data harvest for SOH determination will be crucial for business success. With that, I thank you for your attention and happy to receive questions.
Thank you, Dr. Wu. Do you have any questions for Dr.
Wu? Yeah. Thanks for the presentation, Mr. Wu, and I think it's very insightful and structural. This is Jared from Shanghai Metals Market, SMM. And actually, I'm from China, so related to what's happening of recycling in China, so I come up with 2 questions. The first question would be like, you have mentioned the idea of repurposing, and I see your assessment of the attractiveness that you actually raise it's most attractive of the repurposing. But as far as I know, currently in China, people still have doubts about the repurposing regarding its business model, where it can be used, and also the safety issues because it's repurposing. For example, in the energy storage sector, it could be risky, that's called fire, and also about the cost efficiency because, you know, for example, the energy storage, the LFP price, battery price currently in China is low enough. So there is no competitiveness of the repurposing or the second use battery. So I would wondering could you elaborate a little bit more on why you say it's very attractive when it comes to the repurposing in Europe? So is my first question. My second question would be, it's true that for the recyclers, the chemical know-how is very important for key to success in the future. But I talked with Umicore, BASF, these kind of chemical companies, but they still regard the environmental protection issue is very a headache to them, especially when you come to the extraction of metals from that, of the hydrometallurgy, how to treat the water issues. So how do you see these kind of challenges, especially for the recyclers when they are going to acquire the chemical know-how? And especially we also see many Chinese players coming to the European market, and how you see the Chinese commerce will help. Yeah, thank you.
All right, two very good questions. On the first one, repurpose, for sure, the biggest market is going to be energy storage. We agree that energy storage will be challenging. There will be small segments of energy storage which will be suitable for repurpose, such as home storage. If the batteries are safe enough, you need to look for segments where the cycle life requirements is not that high anymore. And these are very limited. So UPS and home storage, basically. But then there is a growing market, especially if you look at developing countries in terms of two-wheelers and three-wheelers. These are the segments where we see the majority of the volumes going in. However, the numbers you have seen in terms of value pool is basically I want to say demand modeling. So it's not to say this volume will be fully consumed by the market. So it's only what's technically in terms of return volume and SOH, etc. It's feasible in terms of application. But it's not 100% guaranteed. Those value pool you see, it's actually real, because there's maybe a missing market for this. So that's number one. Number two, on the recycling, yes, we have quite challenging conditions in Europe with regard to environmental permitting and also other regulations. But in the end, all of these factors boils down to CapEx, right? It boils down to the business case. And actually for NMC, yes, the profitability is a bit lower, but we are still making money with that. I think the bigger question is what to do if we also going to see larger shares of LFP on the road. And this is a question probably somewhere will become relevant by 2035, 2040, when those LFP batteries coming back, how do we want to deal with them in a profitable way?
I'm sorry, it's important just for everyone. It's very important to raise up your hand because we have virtual participants and we also record everything and we want to have the recording perfect.
Sorry, Sean Joseph from Altilium. We're a battery recycler in the UK. One of the things that LFP is certainly a big one for us in terms of the profitability side of how you actually make money. And anode recycling is one that we've been working on quite strongly over the last couple of years in terms of, 40% of the battery is actually a graphite product, which we've been working with Talga in Australia. So that is a real issue in terms of how do you recycle LFP profitably.
And I think this is also more than profitability. It's also strategically important, as most of the graphite is actually from China.
Exactly.
We can decouple.
And it's 40% of a payable out of a battery. So it's a big amount as well. It's not just sort of a small, it's megatons.
Yeah.
All right, let's thank Dr. Wu. If you have more questions, please follow up during the networking time.
Thank you.
Yeah, we have to keep moving on. We'll have time in the networking break. Please follow up then. All right, so next up, we're going to have Dr. Andreas, and he's going to be talking about some direct recycling. And if you have over, decade plus experience around the energy sector, material sector, experienced at Fraunhofer, and now you're the founder and CEO of Cell Circle. So directly recycling is an upcoming, very interesting topic. So really excited to learn more. Thank you.
So, hello everybody. My name is Andreas Bittner. I'm the CEO of Cell Circle, a spin-off of Fraunhofer. And today I will give you a short introduction into our innovative direct recycling solution and its benefits for a sustainable battery value chain. Seems that the presenter doesn't work. It's a pity. Do we have another one? Is it this? Ah, great. Many thanks. So on this slide, you see the standard way how batteries are currently recycled in red, called metallurgical recycling. Batteries are put into a furnace where half of the materials are burned to create alloys that are further treated with chemicals. That's called pyrometallurgy. Or batteries are put into a shredder and then into a bath of acids, where also the battery materials are destroyed, called hydrometallurgy. And both process routes have in common that they do not result in ready-to-use functional battery materials. They end with base materials, the precursors of new battery materials. And these end products then have to be further treated, further processed to the precursors and to the final battery active materials. And this very often doesn't happen in Europe because whole Europe has less than 1% of the global battery active material production. And in green, you see our disruptive way to recycle batteries called direct recycling. Batteries are separated into clean materials fractions. These materials fractions are regenerated and can be directly reused for the production of new battery cells. A very simple closed materials loop that can be established within Europe and which has a lot of benefits. It reduces the energy consumption. It reduces the critical chemical waste. It improves the carbon footprint. It improves the resilience of European industry, the independency from non-European material supply. So a very big chance for a sustainable European battery value chain. And in this slide, I want to show you a game-changing technology to bring this disruptive recycling approach into an industrial application. You can see the functional principle of electrohydraulic fragmentation. You put battery components into a reactor that is filled, for example, with water. In this reactor, light sparks are generated with high frequency. These light sparks create shock waves, which hit the battery components in a very homogeneous way and destroy them directly at their weak points, which are the phase boundaries, which are the materials boundaries. I've developed this process within the last 10 years at 2 Fraunhofer institutes in close cooperation with the respective plant manufacturer. And based on this experience, we have now further developed it for direct recycling and have significantly improved the selectivity and the energy efficiency. And as a result, you do not have small sandwich particles where different materials are still fixed on each other, as it is achieved via standard shredding approach. In our case, the materials are really detached from each other to create high recovery rates and to create high purities, which is the basis for a successful direct recycling. The plant technology is already available for continuous operation. It can be scaled via the number of electrodes. It's easy to operate, and for our current scaling activities, we have established a very close cooperation with a plant manufacturer. And the result of this process is shown on this slide. On the left hand, you see industrial calendared electrodes. And on the right hand, you see the result of our fragmentation process, delaminated aluminum current collectors with big fragment sizes, which facilitates the sorting, which ensures high recovery rates, and which ensures highest purities of the recovered electrode coating materials. And these coating materials are shown on this slide. You can see they are already disaggregated into fine powders and have a very high purity. And what we are even able to do, we can even further separate these battery electrode coating materials into the different materials types, the active materials on the left hand and the carbon black on the right hand. We achieved this via semi-continuous centrifugation process that separates the materials via particle sizes, via densities, have achieved these results together with Fraunhofer, and we are currently increasing our cooperations in this field. And most important is the quality, the performance of the batteries, of the battery materials in new battery cells. And this is shown here. You see in black the performance of a fresh, of a pristine battery active material in a pouch cell, and in green the performance of the cell circle recycling materials. And what you can identify is that the electrochemical performance is very similar. You have a similar storage capacity, similar rate capability, which means cycling performance at different charging speeds. And we also have a similar cycle life of these battery materials. So the proof of concept is made. Very good first results. And this leads to a lot of benefits. For example, it leads to ecological benefits. On this slide, I've summarized the life cycle assessment results of Argonne National Laboratory for the production of the standard material NMC via the primary route, via the two metallurgical recycling routes, and via direct recycling. And you can see regarding all core LCA categories, the direct recycling brings a lot of benefits regarding energy demand, regarding water usage, regarding greenhouse gas emissions, and regarding SOx emissions. And not only compared to the primary production, also compared to the metallurgical recycling, an improvement by approximately a factor of 2. And furthermore, we also have economic benefits. In red, you can see the revenues that you can generate via metallurgical recycling. And in green, you can see the revenues that you can generate via direct recycling. For the example of an NMC active material, of an LMO or an LFP active material. In red, you see the revenues that are generated via the value of the elements, the raw materials. And in green, you see the value of the functional materials, including the production value of the final battery materials. And this is higher. So even for the standard material NMC, we have a higher revenue potential. But this improvement becomes much bigger for more sustainable and more cost-efficient materials like lithium iron phosphate. Here we can increase the value of the recycling products by a factor of 3. And this is very important because the market for lithium iron phosphate batteries is rapidly growing. From 2020 to 2030, we have forecasted an increase of approximately 60%, 60-fold increase of the LFP battery market. And this also has a strong influence on the LFP battery recycling market. And also within the whole lithium-ion battery market, the LFP market will have a very big share. That's the reason why we are part of the reuse project that is focused on the direct recycling of this lithium iron phosphate batteries. The objectives are to develop automated sorting technologies to separate the LFP batteries from other battery types. Also the development of automated battery disassembly technologies with focus on battery cell disassembly, and the development of new separation, purification, regeneration processes to achieve the functional materials in very high purity. For example, active materials, carbon black, binders, electrolyte. And all of these activities are flanked with comprehensive life cycle assessment, life cycle costing, and social life cycle assessment activities. We have a consortium with 13 partners from 8 countries. We have started a project last year, and it will end in 2026. And here you can see in general the process steps from the electrode production scrap or the disassembled electrodes to ready-to-use functional materials, first with a very gentle delamination to separate the aluminum and copper current collector, then a debindering to separate the PVDF, then a separation into carbon black and active materials, a regeneration of these materials, and a validation in new battery cells. And since for all of us, the reliable life cycle assessment to prevent greenwashing is of highest importance, we are also part of another European project, the project HiQ-LCA, High Quality Life Cycle Assessment for Battery Industry. And together with 12 partners from 7 countries, we are developing a comprehensive, validated, and transparent database for the life cycle assessment along the whole battery value chain. And based on this better data, we are developing new tools, new services, and new trainings for the LCA. And in general, we want to achieve decarbonization and an improved resource efficiency for the battery industry. And you are all cordially invited to participate in this project. You can, for example, scan this QR code to pre-register for our project advisory board or project network. And you can also contact me after this conference. So, for example, you get support in collecting LCA data according to current industry and regulatory requirements. But there are much more opportunities to cooperate, in particular regarding our current scaling activities. So, in the last years, we have validated our new process, for example, within a validation contract with the Federal Agency for Disruptive Innovation, SPRINT, or with industry projects with several partners. And now we are further scaling the process, increasing our team, and have the goal to build up a first small industrial pilot process in 2026. Then we want to further upscale and achieve a big market expansion. And I'm very happy that as a perfect start for our current scaling activities, we have won the first prize at a big international startup competition, the Energy Startup Bavaria. We are very happy about this honor and very thankful about the many supporters that we have won based on this award. Now I look forward to a fruitful discussion with all of you. Many thanks, colleagues.
Thank you, Andreas. Do we have any questions from the audience? Got one right here. Please state your name and your company.
Hello, Rémi Cornubert from Strat Anticipation. Thank you very much. Very interesting. I have one question regarding materials, because when you recycle used batteries, the active materials, they are not pure anymore, because during the use of a battery, you will generate impurities. And how do you get rid of these impurities with your process? Thank you.
It's a good question. So for the electrode production residues, which is by far the biggest amount of battery waste in a moment in the next years, it's much easier because the materials are not aged. But we are also working with end-of-life batteries, which is the second step in our go-to-market strategy. And here, it's a little bit more challenging. You have a solid electrode interface, a reaction layer between electrolyte and electrode materials. You have maybe a crystal structure that has to be healed. You have a lithium loss during the cycling, and we can heal this. We are short thermal process together with a lithium source, lithium hydroxide, lithium carbonate, can refill the material, can burn away the SEI, and can heal the crystal structure. So that's currently in development. This is feasible in principle.
I could just expand on that real quick. You need the clean electrode film itself. Most battery packs that we've seen are not designed for recycling. It's near impossible to get to that clean electrode. So think of NLI, if you're just shredding the entire battery pack, is this process still feasible? And if so, how do you overcome all the other crap that's in that black mass?
Yeah, so that's a very good question. So the battery disassembly is really a challenge and the current bottleneck. So with some traction batteries, the battery cells are glued with each other, and it's very difficult to separate them. But there are solutions. No? For example, you can take out the jelly rolls without separating the casings. No? The casings are still part of the pack, but you open them and take out the jelly rolls. So that's one option. Then there are chemical ways to separate the battery cells. Then there are designed for disassembly ways. No? For example, my Fraunhofer Institute, my former Fraunhofer Institute, worked on inductive heating particles that can be put into the glue, that you can separate this boundary. And I hope that the battery passport will also enable improvements, because I hope that in the future, a disassembly concept has to be included. And so we are all hoping for design for disassembly, for design for recycling. Yeah, but that's a challenge. You are right.
Did I start a question, Dr. Wu? Good. We got one here and then one over there.
Hi, nice presentation. I am the Engin Karabudak from CEO of Battery Materials. So we synthesize NMC from normal sulfates. And recycling of the NMC 811 is different than 622 and 531, and 811 is effective by oxygen. So if you recycle it even directly, you will lose some composition or so what kind of NMC you recycled?
So we have started activities with NMCs with lower nickel content, 111, 622. We are currently transferring the work to 811. Here, we really have the challenge that it's not so stable in water, much more challenging, but feasible. So we are changing the reactor media and intend to have similar results with this material.
And the second question is the price of this. This can work very great for the scraps, but the price of reassembling the batteries is really expensive in comparison to shredding. So you need to use the scrap, or you need to recycle it again, resynthesize again in the used batteries. So it can be this puts extra cost on that. I think the ideal for scrap this process in terms of price.
Business case is the very best for production scrap.
Yes.
Particularly electro production scrap. But we think we can recycle the batteries also in an economic way for whole aged battery systems, battery packs, based on the higher revenues that we are generating with our final products.
And what is the waste at the end? So it waste water. So is it dangerous after the process?
We are putting it into a circle. So also regarding the water consumption.
Okay.
We are better as the standard process. If you have this hydrometallurgical process, you have a lot of wastewater.
Yeah, okay. Thanks a lot. Thanks.
Thank you
Very
too.
nice process.
Good morning, Johan van Peperzeel, Chairman of the European Battery Recycling Association, and also working for partly for Van Peperzeel and other companies. Dr. Bittner, I have one serious question because your presentation is very promising relating to production scrap. So if somebody's producing batteries and he would have an installation like you are presenting, then he could directly after the recycling put the virgin material, because it's virgin, back into the process. But what we see is that in the recycling and in the use of batteries, especially Tesla Model S from 2012, they're still driving around. And the chemistry of the waste batteries has changed tremendously compared to the new batteries that are produced today. So my question is, if we go in other NMC's chemistries, is it still so valuable what you are producing, or do you have to produce a blend as well?
So there's an option for an upcycling. So in addition to a lithium source, you can also integrate a nickel source and can adjust the ratio of the different elements in the active material. So we can upcycle an old cobalt-rich NMC to a newer nickel-rich NMC, but this is currently on a lower TL level, but we're already working on this.
We have time for a few more questions. Throw another one in there. How does battery chemistry come into play? Looking at NMC, all the variations there, nickel content, but LFP, or even the next gen battery chemistries, lithium metal, sodium, potassium ion type batteries.
So the development go into the right direction. So the goal is to have less resource critical and less expensive battery active material. For example, lithium iron phosphate without cobalt and nickel, or sodium ion battery materials that do not even have the lithium in it. And since the metallurgical recycling processes are focused on the recovery of the elements, of the value of the elements, their economy is not so good. It's not so good for these future battery materials. And since we are recovering also the production value of this material that is still high, maybe even higher, we can enable also an economic recycling of these materials of the future. So I'm happy about these developments.
Got time for one more question? No more questions. Let's thank Dr. Andreas again.
Many thanks.
Thank you. We're going to have a little bit of a schedule change. Mr. Kim is going to give his presentation virtually after the networking break. And now we're going to ask Dr. Jacqueline Edge to come on up, where she has quite the interesting path to get to the battery space. Start out with degrees in zoology and computer science, went into the banking industry, and then from there decided to reset and go into clean energy and hydrogen storage. And now she is the Faraday Institute. Is she ready? Like she just stepped out. She here? No?
1, 2, 3. Okay, so I suggest to cut for the break.
Go ahead, have the break.
Networking break. And yes, and just a quick reminder before we wrap up. I'm glad that the first quarter of the first day is done, and some people were coming up during the first quarter. So I remind to everyone once again, please find in your folders the evaluation form and fill it. You can already do this about the speakers, regarding the speakers that already gave the presentation, and continue as we move forward. So the networking break will last 30 minutes, and then we will come back. Thank you.
So we will start about 10:45 after the break. Thank you.
You're right. I may
So next up is going to be Dr. Jacqueline Edge, who, as I was saying earlier, has quite the interesting career path from zoology to computer science to banking to clean energy to hydrogen. Exciting stuff. I guess student of knowledge, right? Now she's at the Faraday Institute, and today is me talking a lot about automation modeling within the battery circularity. Dr. Jack.
Right, so I don't need to introduce myself, but yeah, so I work at Imperial College and my work is on battery sustainability aspects, so sort of assessment, whole systems, techno-economics, and life cycle assessment. Right, so it's this one, right? Yes. Okay, so we've all seen these projections. We all know that we're going to be scaling up battery production quite dramatically in the next 5 to 10 years to meet the net zero targets mainly. And this means, okay, I went backwards. Right. And this means you need lots of different minerals. And that's because batteries are more complex than technologies we have already. And they require a lot of different, quite critical materials. And to extract those minerals means we need to go and mine for more of those minerals. Unfortunately, a lot of those mining areas overlap with biodiversity areas. And so that does mean a lot of impacts on ecosystems. So recycling is really important so that we can offset those impacts. But there's another really good reason why we absolutely have to recycle batteries. And that is because they are effectively self-ignition devices. So basically you put a bunch of complex chemicals into a device and then you pump a bunch of voltage through it. It's subjected to higher extreme temperatures and surprise, surprise, it has lots of chemical reactions, some that you want and mostly that you don't want. And so batteries change their structure over time and they degrade. And that self-ignition risk, though it's very small, particularly when a battery is well manufactured, it does continue for the rest of its existence. So as long as that battery is in its functional form, it can ignite. And so that's even if you don't use them. They're very sensitive creatures. So you put them on a shelf, even if you never use them, that battery will degrade and will potentially ignite. So we're seeing a lot of problems with battery fires, and that's obviously a safety issue. And of course, if those batteries end up in landfills, maybe not in the EU, but other parts of the world, that will possibly ignite landfill fires, which will be incredibly polluting. Many of the stuff that comes out of battery fires, we don't really know yet, and a lot of it is highly toxic materials. So we need to recycle. And we know that recycling is going to scale up. It's got a sort of 5 to 10-year delay post-production, but we're facing a mountain of battery materials that we need to recycle. So there are essentially 3 ways in which you can recycle a battery. You can use pyrometallurgy, where you basically melt the whole battery down and you extract just a few minerals. You can use hydrometallurgy, where you use a sequence of chemical processes to leach out the minerals and materials that you want. And then there's direct recycling, which we had a very nice talk about, where you actually try to access the materials and separate them into purer streams and then recover them in those purer forms. Now, the problem with pyrometallurgy is that it's labor intensive. It's actually very expensive. It has to operate at very high temperatures. There's a lot of emissions from that. And you actually only recover a few of the minerals. Most of the other products are basically burnt off. So the aluminium and the lithium are all burnt off. And those cause emissions. Then hydrometallurgy, you have to use a lot of chemicals. You can recover more of the materials, but you still lose quite a lot. And you have to use fairly nasty chemicals to do so. Whereas direct recycling has the potential to be very low impact, low cost as well, and to recover high value materials and a much broader set of those materials as well. So there are many waste streams along the entire battery life cycle that we need to address. And first of all, at extraction, there's a lot of mining waste. So I'm not going to focus on that in this talk, but that is an area, quite an active area of research of how we reprocess those mining wastes. We need to look at the production scrap coming out of gigafactories and address that. And we've already talked about that with direct recycling. There's the potential for landfill, as I said, maybe not in European countries, but certainly other areas of the world where they don't have such strict regulations. There is quite a high risk of landfill. And then we have a lot of, as I said, materials that aren't recovered through the current recycling processes, which is largely pyrometallurgy. So direct recycling has the potential to help us address production scrap. It's really very well suited to production scrap because much of that scrap is already mostly separated. It can also help us recover many of the materials that are generally lost in traditional recycling methods, and then hopefully also offset the landfill and make sure we don't landfill batteries, particularly because it's very useful for low value chemistries. So we did a paper on techno-economics of battery recycling, comparing pyro, hydro, and direct. For direct, we were looking at manual disassembly in the UK and in China. And we found that direct recycling is pretty much the only way you might possibly make a profit from the low value materials such as LFP. You can't use pyrometallurgy, it's just too expensive, uses way too much energy. But one of the biggest barriers is the ability to access materials. So that's the disassembly of the battery packs. So we know that there are many benefits to direct recycling, so it can be profitable even for low value materials. There's a lot less mixing. So if you put the effort into not mixing the materials in the first place, so i.e. not shredding, and try and recover those things before you mix them up, which is what Andreas talked about, you can actually have much more efficiency overall of recycling and recover purer streams of materials. The processes are generally quite eco-friendly. They're low energy. They tend to avoid harsh chemicals. They can be water-based as well. The direct recycling is much more resource efficient. It has potential to recover much higher rates of those materials and also recover them in their functional form, so that you don't have to then, having extracted the elemental form of the mineral, then reprocess it into, say, a cathode active material. You're actually recovering it as a cathode active material in the chemical structure. And so that is a much higher value. But there are certain barriers to direct recycling, as we spoke. And so the biggest problem at the moment is that we would have to do disassembly in a manual way. And so that's very slow and very expensive. So one of the ways we might be able to fix this is with automation. I'm not going to discuss that today, but I do, some of the work I've been doing looks at the techno-economics of automation as well. But the biggest barrier to that is the fact that there's so many different pack designs. And so it's really difficult for a robot to then have to learn all the different pack designs. We have, as I said, that large variation. So we could possibly tackle that with standardization, but that then stifles innovation, which is quite an important part of this industry. So we need to make sure that the pack designs are less complex. And so we'll be talking about that later on. And we also need to consider, well, if we simplify the pack designs, there is a trade-off against whether they're still safe and high-performing. So we have to make sure they're always going to be safe. We need to try and develop different ways of putting packs together so that we can do it in a reversible way. Many of the fasteners that we use at the moment are irreversible, such as welding or glues. And then we need to, we're going to have very diverse materials. This is a big problem for recycling in general, particularly as batteries have very long lifetimes. That means, and it's a very rapidly evolving technology, that means that the chemistries that are being produced in 10 years' time won't match the ones that are coming out of end of life. And of course, we need to look at the toxic compounds, which makes recycling very much harder because you have to deal with all the safety issues. We did some work on direct scrap recycling. So this was with a master's student from RWTH Aachen. And he worked last summer on developing a model trying to see how you marry up all the different types of scrap that come out of production with certain direct recycling processes and what you actually recover. So he did this model based on the literature, but also based on interviews with industry, which is similar to what you did, Andreas. And so we should talk. And that's going to be published soon. Battery design today, battery packs are designed to be high performing and safe, and that's really important. Sometimes they're also designed to last for a long time, so that's an important element of sustainability. But we think that sustainability should be one of the design optimization criteria for design, and that's not really happening at the moment. Sustainability is kind of being ignored, and that kind of means circularity. So we did a study on how you disassemble packs a couple of years ago, where we were trying to understand what are the steps that hinder disassembly, what makes it low cost, high cost and difficult. And we had access to this amazing database called A2MAC1. Oh, and we're going to be doing some follow-on studies on this, and I have a PhD student looking at this as well. ATMAC1 is this amazing database where they buy a bunch of commercial electric vehicles and they take them apart and they record every single item that comes out of those packs. So every nut and bolt and exactly where it is and how many and what material it's made of, etc. And so with this database, we were then able to look at what makes a pack and how you might take it apart. So we took a range of pack designs to sort of compare the different features of those packs. And there are many different designs. Pretty much every OEM has its own design. In fact, every EV model has a new design very unique to that particular EV model. So you find cells that are put inside modules. There are different types of cells. There can be pouch cells, prismatic, cylindrical. They could be glued together. There's this new design feature where you can make a blade cell. So that's the cells directly in the pack with no modules, which was actually quite beneficial, but only works for certain chemistries. But there are many different ways in which these cells are put together into a pack. So this just shows you the cost model. I don't expect you to take all of this in, but I will be showing the slides. So we had to make some assumptions about every step that you take to disassemble the pack manually, how much time each of those would take, how many times you have to change tools, and how much that would take. And then we built all that together into one model, which sort of assessed for a particular pack design, how much time would it cost to disassemble? And then you can link that to cost based on labor costs. So this is the results of that study. So we started with six pack designs, but we had to drop one of them because they were completely glued together. So there was no way to get from pack right down to cell. You could sort of get to the module point and then you couldn't get any further. But from the remaining 5, there's quite a big difference in the cost to disassemble these, up to 60% variation in cost of disassembly. And one of the big things that stands out is the cell to pack design is much easier to disassemble because you don't have to break down the modules and then take the cells out of those modules. And so that was a big step forward. The cost hotspots in taking apart different designs, it's also about the number of screws and bolts. So obviously the more you have, the more time it takes to take those all apart. As I said, it's a number of modules. So if you can avoid modules altogether, that's ideal. That doesn't work for every chemistry though. Some chemistries need to be modularized. Then there's the welded parts were quite time consuming, and there's certain parts that need to be hand removed. So taking a module out of a pack. So what do we need to do to make packs more disassemblable? First of all, we need to simplify pack design. And that would be to try and make it so that you can reduce the number of things that you have to separate. So the number of fasteners, the number of modules, as I said, but also the number of diversity of tools that you need to use to take it apart. So if you could maybe use one type of fastener across the entire pack instead of lots of different types, that would be good. There's some really nice ideas coming out. So for example, this concertina design of packs where you only need to make one cut and then all the cells separate out nicely. And these are clever designs which don't affect the performance of the cells in use. The number of fasteners, so we really need to address what fasteners we're going to use industry-wise. We need to try and reduce the number as much as possible. We found that in our comparison that the earlier the model was, the more over-engineered it was. So the very early models tend to have loads and loads of screws and nuts, but they obviously don't need that many. So that sort of drops off as the models get older. But it would be nice to sort of explore what that safe optimum is. You know, obviously you can't have no nuts and bolts, but maybe 300 is too many. So where is that nice balance? It would be some of the work we want to do. Try to avoid welding as much as possible, and particularly avoid structural glues such as epoxy resins, which are very, very difficult to dismantle because you need to use very, very harsh solvents, which take a long time. So development of reversible fasteners such as straps and clips would be really good. Debondable adhesive, which I'll talk about in a moment. And then there's this nice little sort of design of a cylindrical cell which has sort of a pop fastener. So nice ideas are coming out all the time on how we can make these more reversible. On debondable adhesives, The idea is that you can design adhesives in such a way that they have a certain structure when they're being used, but then you can apply a certain stimulus to them when you want to recycle them. And that sort of breaks up the bonds and they just basically fall apart. So the example here is that you could put certain additives inside the glue, which then would swell if you heat them up. And then that swelling makes those glues crack and separates them nicely. Now, obviously, to try and make that as safe as possible during use, you wouldn't want just a single stimulus. You'd try and design it so that it needs 2 stimulus at the same time. And then that would make sure that it's as safe as possible and the pack doesn't fall apart in an accident. And of course, so you can have a number of different stimuli that you use. You could use things like UV light, magnetic and ultrasound stimuli, but those tend to be difficult to use on battery packs. So the ones that we tend to focus on are the electrical, thermal, and chemical stimuli. And so you would definitely have to design multiple stimuli because all of those things occur naturally in the battery during use. There's a lot of work being done on making completely aqueous batteries, so with processing that's entirely water-based. So, for example, GRST is a company that won the Earthshot Prize a couple of years ago, and their cells are completely made with water-based chemistries, and you can basically drop the cells in a bath and they just separate out nicely. So that's and those chemistries are obviously a lot less toxic. They also don't have any PVDF at all, so there's no PFAS coming out of those batteries. And they're a lot less volatile, so much less likely to explode. And there's a lot of other researchers which are producing similar concepts. I want to talk a little bit about fluorine because it's a particularly problematic element. So fluorine is actually more abundant than carbon in the Earth's crust, but life has basically avoided fluorine in its biochemistry. And this is because fluorine is highly reactive and generally very, very toxic and disruptive to biochemical pathways. So we need to try and avoid fluorines as much as we can. Many of the compounds that we make using fluorine today are entirely anthropogenic. They don't occur in nature. And so we don't know what impact they will have on ecosystems. Now, a typical battery holds something like 5% fluorine compounds by weight. And that's in the PVDF binder, which is polyvinylidene fluoride, and the lithium hexafluorophosphate electrolyte. And so those fluorines, while they're contained in the batteries, are effectively safe, but they could be released from those batteries during recycling processes. Our recycling processes don't capture the fluorines. They tend to volatilize them, and so they're released into the atmosphere or into the wastewater. And they could also be released during battery fires. And because of all the chemical interactions, we don't really know what kind of compounds will come out of those battery fires. And they tend to be incredibly toxic and dangerous to work with. So trying to avoid fluorines is a really key design criteria. So just to say, I'm funded by the Faraday Institution, which is the UK's sort of funding body for battery research in the UK. And we have a huge community of battery researchers throughout the UK, many different universities working together on many different aspects across the entire battery value chain. One of the projects that I'm working with is the ReLib project, which is recycling of lithium-ion batteries. And we are trying to develop direct recycling processes. So we have this concept of recycling 1.0 to 4.0, 1.0 being what we do today, which is pyrometallurgy, 2.0 being the emerging hydrometallurgy, and 3.0 is where we start to go to direct recycling. But 4.0 is where we actually incorporate design principles into developing the recycling processes. So we're working towards doing that, and that's led by Paul Anderson at University of Birmingham. So basically, to conclude, we need to unlock direct recycling because that is the only way to sustainably recover materials from batteries. We need to try and make sure we design the battery packs being made today so that they are as disassemblable as possible, because it can save us an awful lot of money in the future. And some of our work has shown that. Some of the simple design tips we can use is try and develop simpler pack designs, but obviously not to the point where they become unsafe. They still need to be structurally as sound as possible. Try to incorporate reversible fasteners and debondable adhesives. If we can switch to water-based chemistries, that would be ideal, and certainly avoid fluorines as much as possible. Some of the work we're going to be continuing on this is trying to quantify all these effects of making these changes. So, yep, that's my talk. Thank you for listening, and I can take questions.
We have any questions? One over here.
Very fast presentation. Thanks. Informative. How does this sort of work happening in China as well, being the largest by volume now, or how this knowledge getting transferred there? Because I see very little focus on the recyclability there.
Yeah, I mean, that is the problem, is that OEMs don't really consider sustainability or recyclability in their pack design, and that's true across the entire world. In the EU, you're trying to regulate it so that people are incorporating those design principles, but the same regulations aren't happening in China. So the OEMs in the EU and in the UK are sort of struggling to compete with the Chinese producers because they don't need to follow those sustainability principles. So that is a big issue. But having said that, I know that there are a lot of companies in China who are trying to improve things, like GRST, who want to move to water-based chemistries. So it's difficult to say. We don't really have sight of what's happening in China design. Pack design in general is not really shared around. So unless you have an amazing thing like this database, which tells you exactly what's in the pack, and they don't really have a lot of Chinese models. They have only a couple in there. So yeah, it's very difficult to get sight of what's happening in the Chinese market. But I think they do have a system where they basically plug and play the battery for some certain modules, where they just you drive into a service station and they take the battery out and swap it out with a new one. So they are starting to think about reuse at least, and repairability. Yeah. But one thing I do know about the Chinese market is that they've structured in such a way that the recyclers work very closely with the actual pack designers. And so they may be a step ahead in that sense. They may be incorporating those principles, behind the scenes, which we could certainly benefit from.
I've got a question over here.
Yes.
Hi, Jacqueline. I don't want to put you on the spot, but yesterday the Faraday announced a process to recover the lithium using cooking oil. Can you share any?
I did see that headline, but I haven't read it. No, it's part of the project that I work with, but I haven't seen that thing yet. Yeah.
And in terms of the different methods to remove and separate the batteries, did you try freezing those that had glue? I know because I'm the CEO of the European Electronics Recycling Association as well, and I know that removal of those types of pouches is the same in iPhones and laptops and so on. And our recycling members have found that if you freeze it at -15 for 24 hours.
Yeah. So yeah, you can cryogenically. So that would be a sort of a thermal stimulus to try and crack it, but that's quite difficult to scale, quite expensive to do at a large scale. But that would be one technique that they do use. Yeah.
Got time for a couple more questions. One over here.
Thanks for the presentation. This is Jared from Shanghai Metals Market. So you touch a lot about direct recycling, which is a very interesting topic. And here in China, actually, a couple of companies are doing that, like SDM. And my question is that it seems, in your opinion, that you think direct recycling seems to be the only ways or few ways to make profit, especially in EU, especially to recycle LFP batteries, considering only like valuable metals, only lithium in it. But do you see, like, if we consider, always assume that the lithium recovery rate is increasing? For example, I understand that the very reason that doesn't make money because we in EU that the recovery rate is not very high. Do we assume, like, take the lessons from what we see from China, like the lithium recovery ratio is just like 50%, but nowadays increased to 80%. So based on this assumption, do you still see that the direct recycling is the more preferable or the few ways to making money when we're talking about the LFP recycling? So
I'd be happy to see other methods that can recover the lithium, because that's obviously the main thing. But we also need to consider other chemistries like sodium ion, where it's not so obvious where you'd get the value from that, because we need to diffuse the battery as a device. Yeah. But yeah, I'm pleased to hear that lithium is being focused on more, because it's basically ignored in traditional recycling. It basically burns away in the pyrometallurgy. So that's good to know. I have been looking recently at how we recover the lithium from recycled solutions. So most of our processes end up with a solution that contains a certain amount of lithium. And I've been working with someone in Argentina to try and use direct lithium extraction to then take that back out. But so what methods do they use? Is it with pyrometallurgy where they remove the lithium?
Actually, dominantly in China is hydrometallurgy, and
Right.
to extract the lithium. And
Yep.
but they are in a headache, because in China you have to buy the scrap, so the feedstock cost, and currently the lithium price is not very high.
Yeah.
So it's also hard for them to make a profit. And also they are talking about iron phosphate recycling, which is
We're
also
gonna have
key.
to
Yep.
stop here.
Let's chat on the break.
Continue doing the networking break again. So our next guest is virtual. So next we have Mr. Kim. He's going to join us virtually. Where he is he's the CEO of ABR. He's an expert in electric vehicles, ESS, battery R&D, and has since then, worked on international standards in a variety of other organizations. And today he's going to talk to us more about direct recycling. So Mr. Kim, the floor is yours.
Yeah. Hello, everyone. My name is Yuta, CEO of the ABR. Today, I am so sorry about to virtual attending. I have some apology about that. And today I tell you about the direct recycling. So we heard about a lot of the direct recycle technology. Yeah, we are doing that. This is a next generation clean recycle technology for battery and pilot plant. My name is Yuta, CEO of the ABR. Yeah, we are doing to direct recycling pilot plant in Korea, but we are mainly focusing on to the plastic scrap only, not others. So our technology is very initial stage, can be possible to direct recycling using the scrap, slurries, and some other things. I'll tell you about a little bit about ABR, and then tell you about the direct recycling, and then our challenges. Yeah, we are the smaller startup company in Korea. We already collaboration in small battery company in Korea, like JL Energy Solution and Green Energy and its technology and others. I'm also the professor in the Dongsin University for battery lectures. Yeah, we know how is the battery life from the mining, refining, and then precursors and cathode material, and then battery module and packs using for EV and energy storage system, various kinds of the application you can use. After that, the battery pack goes through to the pre-recycling process to make the black powder and black mass, and then transport to the Asian countries to do some hydrometallurgy and pyrometallurgy process, and then you can get the lithium, cobalt, nickel, manganese. We just get the metals. So we are trying to challenge it, how we can use the hydrometallurgy process production, a middle-sized production like the nickel sulfuric acid to use directly precursors as you know that the most of the metals to solute in the sulfuric acid and then make the precursor and then go through the cathode material again. So we are trying to challenge the reduction the cost to make the precursors using the recycled materials. During that technology, we can reduction the cost to make the NCM 811 and others. But there are some problem in environmental issue in sulfuric acid. So we are stop to this process. We following to the more frontier side. So this is the same as before, but there are a lot of the production ways go through to the recycling process. I mean to the cell go through the precursor pre-recycling facility, and then we make the black powder and black mass transport to the hydrometallurgy, pyrometallurgy process. But I believe it can be possible to reduction the cost around 50% from our previous technology. And before the precursor, before the black powder and black mass production, we can reduction the 50% of the cathode material manufacturing cost. However, we are directly recycling using for the production scrap in battery manufacturer facility. It could be cost reduction around 80%. That's why we are trying to challenge the direct recycling. Yeah, in last year, we have 100 kilograms per day pilot plant. Yeah, this is not the pilot plant. This is our test lab. And this year, we are expect 200 or 500 megawatt hour metric ton, around 10 metric ton, 1,000 metric ton for this year. This is our facility. So before we saw a lot of the direct recycling approach, but the most important thing is to like this one. Pyrometallurgy extraction to nickel, cobalt, mangan, most of them are kind of the metals. Who use the batteries? It needs a more high purity metal composition. So we are using the little bit about the hydrometallurgy process after pyrometallurgy. However, the direct recycling, we just can't get the cathode material, and also we can get the anode material without any PCAMS process. I believe that will be much more cost benefit compared with other recycling process. One of the most important things is like this one. We are considering to the future business for UL batteries and life battery can be used for recycling. However, in current stage, most of the recycled material came from the gigafactory, around 70%. This 70% of the recycled material is never used with other application. Just to factory from the cell manufacturing. That means it doesn't have any crystal deformation or some fracture by the process. So that's we are concentrating the production scraps. Also, we believe the production yield around 90%. That means to 10% of the production scrap we can get every waste. This is another approval data for the production year in new gigafactory in the world. I saw one of the most important battery recycling supply chain and a kind of the logistics cost in USA. They bring to the most of the your battery and production scrap goes through the port, and then transport to Asian country. We are doing to the some hydrometallurgy process, and then and then make the cathode material again to the return to the USA. Before I heard that direct recycle can be cost benefit compared with others. I believe because the process cost is cheap. And how do you think about the current recycling business? I believe it doesn't have make the money because the material cost is down, but our current classic recycle process is much more higher cost process, like to hydrometallurgy. Basically, they buy from the black powder and black mass around like this price, and then go through the hydrometallurgy process, and then make the pecans, and then make the cathode material. After that, we can sell around the 70 or 30 or 70 kilogram per US dollar for NCM 622 and NCM 801. How about the direct recycling? This is our recommendation about our process. We just get the scrap like this price, US dollar, $3 per kilograms, and then we have to process costs around the $7 per kilograms, and then you can sell. That's gonna be possible to business. Also, another big issue into we can reduction the transportation cost. We just installed our facility beside the gigafactories. After process, we can just supply the manufacturing cathode. I mean, the direct recycling is much more cost benefit process. Also, it basically economic, environmental friendly process. So it can be workable in European and USA. This is our initial test, and we got the 100 ampere battery pouch cells, and then we can disassemble the pouch case, and we use our own technology like the water-based particle separation, and then we can extraction around the 94 and 96% of the cathode material from the failure battery cell. From now, we already have to extended our materials like the production scrap, like electrode, before the electrode and cells, and then you can make our own process, like this process can extraction to the our cathode materials, but it can be possible to easily extraction to the anode materials. Yeah, this we just mentioned about our technology, like this water-based particle separation using the ultrasonic, and then we have to do some powder process. It can be separation to the active material and conducting carbons, and then we can sell the cathode material. So we don't need any PCAM process and need any cathode material manufacturing process. So it can be possible to the much more benefit. Yeah, this is our bio plant process design. We are trying to challenge the slurry and electrode and cells. Most of the products came from the gigafactories. We have in Korea, we have several smaller gigafactory manufacturers. We can buy this one and then we can produce like this bio plant. Yeah, this is bioplant design for production scrap and inspection and drying. We do the hydration After then, shipping and further process, we can sell the direct recycle process. This is our smaller pilot plant. After we get some cathode material, and then we have testing. But this is just coil cell testing. So we find it's almost a similar performance in pristine cathode materials. So we are planning to selling our remanufacturing cathode and other materials in the market. Another business model is like this one. So yeah, we know that a lot of the cathode material will be need to manufacturing batteries. So this is our business approach to how we can use the remanufacturing cathode material to mixture with the pristine. Can be adoption to use the battery manufacturing. We can out to around over the 20%, but cost reduction around over 30%. One of the challenges to like this one, European Union, they made a battery directive. So after 2031, the cathode material should use to recycling materials. How about to use the remanufacturing cathode material? It could be possible in near future to environmental problem solving to our battery industry. So we believe this remanufacturing cathode combined or mixture with the pristine cathode can be most cost effective and economic friendly approach. We know that a lot of the lead-acid battery making use the pristine lead mixture with the recycled lead. So I believe this is another our business model for the battery cell manufacturer. They can be reduction the cost, and they have to eco-friendly process. This is our current recycling resource. So we cannot have to directly recycle or e-waste cells, only focusing on the process waste and because really this material is just initial stage. It doesn't have any formation structures. And some of the lithium is not happens. So we can be possible to easily directly recycling the manufacturing cathode. This is our target to in Korea. The our first generation using for the water with the physical separation. The second generation will be need more high capacity production process. After that, we can manufacturing a lot of the remanufactured cathode and all the material. After that, we can believe the can be possibly since our earlier. Is there any question?
You can hear it?
Oh, yeah, I can hear.
We have one question over in the corner.
Hi, this is Alberto with N-Cycle. Thanks for your presentation. You had a slide before where you were talking about the payables for black mass and how that flows into the PCAM, the sulfates, all of these areas. I was wondering, do you have any view on the Korean market and the payables over LME for things such as metal sulfates and the PCAM, and what value you're seeing in the Korean market? Thank you.
Yeah. Yeah, thank you. Thank you for question. Yeah, this price based on the Korean research information. So before I mentioned about the black mass price is depend on the LME price about 50 or 60%. So after that, we can bring to this black mass and black powder into Korea around 5 or 7 US dollar per kilowatt hour is the general PCAM process cost. After that, we calculating to cathode manufacturing process cost around 7 or 10. So yeah, this is based on the Korean situation. Yeah.
Do we have any other questions? Got one more.
Hi, Julianne Adams. I'm the Secretary General of the European Battery Recycling Association. Do you have any comments on the European Commission's plan shortly to make lithium black mass hazardous? And so therefore it can't be exported without pre-notification and can't go to non-OECD countries?
Yes, it is a very hard question. So I believe the black mass, people, we cannot understand black mass is just waste. But right now, we believe black mass is a resource, a precious resource for the battery industry. But the problem is how we can extraction to the metal, use the precious resource. In current technology, everybody know to the hydrometallurgy process is much more appropriate to use the black powder and black mass. But the environmental regulation, the process located in the Asian countries popular because of the regulation about to the sulfuric acid and water, industrial water capacity that causes problems. So I believe people you heard in before, I believe a lot of the European institution and company and USA, they are developing like direct recycling technology without any environmental problems. So technology will be change the economic problem or some economic issues. So the eco-friendly direct recycle technology can be operation in the European, that it doesn't make the spread out to the other countries. So technology can be helped to solve the problems. Yeah.
Thank you, Mr. Kim.
Thank you.
Up next, we have Dr. Remu Kornebert with Strength Participation, where he is the founder. He has over 30 years experience in general strategy and operations consulting. Mainly his focus is around sustainable mobility, energy transitions, all around circularity, with even more focus over the past 20 years or so around upstream supply chain. So, Remu, is he here? There we go. This one. That one. This one. This one.
Okay.
Yeah. Just stay on stage. Don't walk around. They're recording everything.
Okay, super. Thank you. Good morning, everyone. Thank you very much for welcoming me today. and I'm going to make a presentation on how to make a sustainable and competitive battery recycling industry in Europe. So I'm going to share the current situation first, and highlight the main challenges this industry, which is emerging, is facing today. And then I will share with you some recommendation to develop it further. So when you look at the last during the last 5 years, you had many announcements of recycling projects in Europe. You have seen a similar map this morning, and it's many projects across all Europe. And of course, you have a few big clusters like in Germany, in the Nordics, or even in France. So when you look at this map, you feel very optimistic because you would conclude that the battery recycling is on its way in Europe. When you look at the various companies, you have a huge diversity. You have startups, chemical groups, you have cell makers, car manufacturers, traditional waste management companies. And typically, you have two different positioning. You have a first positioning where companies are focusing on pre-treatment, meaning collecting batteries, discharging them, dismantling and producing black mass. And the second positioning is the recycling of black mass. And you see that you have a map with the different business model. That said, during the last month, we have noticed that many projects have been either cancelled or put on pause. And this is questioning why. And because these are significant players, and it's not only startups which were not able to raise a new funding. It's large players with a lot of experience. So when you look at the various reasons, the first one is the players are telling you there is not enough materials to be recycled. And as it was explained this morning, the main source of materials to be recycled today in Europe, it's production scrap. And why this is not enough? Because gigafactories, as you know, they are late in ramping up production. Some projects have been cancelled, by the way, or put in pause, like ACC. The second reason is there is not enough end-of-life batteries in Europe, and it's normal because the batteries, they have a higher lifespan than expected. All experienced OEMs, they increase the battery duration every year based on their experience. And another important reason is a few players are telling us that when you have scrap, in fact, it's not recycled in Europe. It's exported in Asia to be recycled in Japan, in Korea, and in China. So this is a big issue. Then competition is very intense. And some players told us that non-European players are buying the scrap with a premium. The premium can be quite significant. Because they have to fill their available capacity in Asia. Another important factor, yes, you don't have feedstock to recycle, but there is no demand yet. Why? Because there is a regulation which is coming to reincorporate recycled metals in Europe, for sure. It's starting in 2031, so it seems to be long. But the main focus of a battery producer in Europe is not to reincorporate recycled materials, nor to make battery design which are more circular. They are just focused on trying to ramp up production with cells which have no defect. And it's very challenging, and most non-Asian players are not yet there because ramping up battery capacity is very complex. So another important aspect in the value chain is we are missing in Europe the upstream part, which is the production of PCAM and CAM, because once you have produced recycled materials, they need to be reincorporated upstream. And so if you don't have the players in Europe, you will have to send the recycled materials in Asia, where the market share on PCAM and CAM production is huge. So this is another issue. And last but not least, two additional comments. Europe is shifting away from a dominance of NMC. They want to have a cheaper and safer battery technologies. And LFP is clearly one very good candidate. But we don't have significant LFP production in Europe. And when it will come, you will have battery scrap to recycle, but there is no LFP recycling players in Europe. And last but not least, in China and in Korea, the battery recycling industry is already a mature industry. They have pilot plants, they have a plant at scale, and they are very competitive. And I will show you that we have a significant gap in competitivity when you want to recycle materials in Europe versus China, for example. So very quickly, one aspect is EV demand is much lower than expected. Short term, it has an impact on the market because less EV demand, you need less cell production. When you look at the production in Europe, we have compared our forecast between 2023 and 2024. And the true available capacity is much lower than expected because the non-experienced players are facing a lot of difficulties to ramp up production. Strat Anticipation has developed a model to forecast materials to be recycled since 4 years. And this morning it was mentioned a couple of times, but you see battery scrap is going to be the dominant source of feedstock to be recycled post 2030. And the end-of-life battery will be bigger than production scrap, not before 2033. So clearly, if we want to develop the battery recycling industry in Europe, we need to focus on scrap. So when you look at this, we have made a bottom-up calculation of all the projects which were announced in Europe. So you feel okay, you have like 750 kiloton of announced capacity. So it seems consistent with the quantity of material to be recycled in 2030 and 2035. But there is a lot of uncertainty. Some projects are late, they are at risk. And so it's very unlikely that such a level of capacity will be effective. And so it's an important issue. Another important aspect we have to need in mind is that the Asian players are dominating cell production in Europe. And the picture in 2024 is even more acute compared to 2023. The market share of Asian players is increasing versus European players. And the production scrap from these gigafactories is more likely to be sent in Asia to be recycled than to be recycled in Europe. So this is an issue to consider. I will go quickly to this page because this has been mentioned as well this morning. But the important number that you need to have to keep in mind experts are telling us that at least 50% of the black mass which is produced in Europe is exported to Asia to be recycled. Of course, you have different national regulation. As you have seen, it is changing a lot, not only in Europe, but in China as well. In China, the government decided to restrict import of waste in 2013. And more recently, they are making this regulation more flexible to have feedstock for their own recycling capacity. We have mentioned the presentation before, the issue of payables. We need to be aware that the China market is very mature and Korea as well. And so you have a pricing mechanism for battery waste. And for example, in China, you have a price of waste batteries and production scrap, which is listed. For example, on Shanghai Metal Market, but CBC is doing some quotation as well. And it's very differentiated depending on the type of waste, the battery chemistry, and so on. And so it's a mature market. It's less mature in Europe because it's emerging. And one big issue, as mentioned previously, there is a big gap between the price in Korea or in China for battery waste compared to Europe, because in Europe there is less demand for battery waste. And typically the gap is at least 10%. So it's quite significant. So the people who have black mass, they prefer to sell it to Asian players. So of course there is this battery package regulation which is prepared by the European Commission. At the bottom you have reincorporation targets which have been defined, and it will start in 2031 and it will increase over time. And we have made a simulation to see whether it can be achievable. And we have made different scenarios according to EV penetration in Europe. So yes, it could be achieved, except for cobalt, because the target for cobalt is very ambitious. But we need to have all the conditions met. Otherwise, if the projects are not there, are not developing according to the initial plan, this will be impossible to hit these targets. As I mentioned, we have quite a few CAM and PCAM projects in Europe, but we have less CAM projects than recycling projects. And same issue, some projects have been cancelled already. Some of them are in pause. But when you look at CAM demand in Europe, it will be much higher than the installed capacity. And when you look at, we did a similar bottom-up exercise. So we will, if we are optimistic, we'll have a 300 kiloton capacity in Europe, and it will account for 25% of demand max. What does it mean? But we will have to keep importing CAM from outside Europe. And the recycled materials will be included there and not in Europe. I will go quickly with this map because it's just to explain that depending on the process, pyro, hydro, direct recycling, you will reincorporate your recycled materials at different value chain steps. But as of today, the two mature technologies, which are pyro and hydro, but you need to go more upstream than direct recycling. So this is an issue. You need to build the value chain in Europe to achieve this. So when you look at the forecast of battery demand by technology, NMC will stay dominant until the end of the decade, but the percentage will decrease significantly. and LFP and LMFP will take roughly 40% of market share. And so you need to address LFP recycling as well. And Europe was focusing on NMC recycling so far. So we have forecasted the quantity of material to be recycled by origin and in gigawatt and in kiloton. You have significant volumes ahead, so we need to ramp up capacity. There is another issue for Europe as well, is that China has decided to restrict access to LFP technology because they don't want, they are the leading by far. They are dominating LFP and they don't want to be to lose this position. And so it will be very difficult for European players to position themselves on LFP and NMFP. So it's an issue. Another issue is that when you look at the China capacity, as I said, battery recycling is mature in China. Battery recycling capacity is growing quite significantly. But today, the utilization rate is below 50%. So now all the players in Asia, they are looking for black mass to be imported to fill their plants. So quite simple. And maybe one last page on challenges, which is on cost competitiveness. We have developed a cost model for recycling, Pyro, Hydro, Pyro plus Hydro. And when you look at this map, so this is the example of hydrometallurgy. But you see the gap. I have taken example from China versus France. The cost gap is at least 70%, and it's even higher for pyrometallurgy. The two main gaps are coming from labor cost, of course, and from the environmental aspect, because in Europe you have very strict regulation and permits that you need to get to have an authorization. And this is much more costly than anywhere in the world. So what can be done to develop a competitive and sustainable battery recycling industry in Europe? So first, I think we need to support the development of European gigafactory and to make sure that they have necessary funding. I was very surprised to see that the European Commission let Northvolt file for bankruptcy. I think we have a big problem in Europe. We have decided the Green Deal, which is good, but we need to be consistent. And we need to have European players, not only for recycling, but for battery production. We need to develop an efficient collection process, and we need to develop as well automated dismantling, because it is a key success factor, as is what explained this morning. We need to keep the feedstock in Europe, because if a feedstock is exported, there is no chance that we will develop a recycling industry in Europe. So the question is, shall we have local content rules like in North America for recycled content in the regulation? But we need to have a clear view on this. We need to assess the impact of regulation as well. Is it driving the battery recycling industry, or is it putting another layer of constraint to the OEMs? We need to be prepared to recycle LFP, and maybe there the nice way to do it is to partner with Asian players because they master the technology. We need to reduce the cost of recycling as well. You have seen there is a big gap, and maybe automation is a nice opportunity to reduce the first gap, the biggest gap, which is labor cost. And we need also to innovate. Yes, direct recycling is very promising, and we need to keep pushing this. But I think there are opportunities to innovate in Pyro and Hydro to make it less costly and more environmental friendly. I'm done.
Thank you. Do we have any questions from the audience? Got two up here.
Hello, this is Umit Patmas from Automobile Dacia. So I noticed, in fact, several points in your presentation. Thank you for highlighting. And I consider that you made the predictions according to the actual scrap rate of gigafactories. And one point I would like to highlight is that in automotive industry, in fact, we cannot continue to live with these high scrap rates. You know, in automotive, we have 5% maximum of scrap. And when we go to battery plants, it's to be frank, 15 something, which is completely unacceptable. And we are working on that. All the engineering forces that we have. So you already mentioned that unavailability of the feedstock for the battery, scrap battery in the market. We have longer lifespan for EV batteries. Plus, we reduced the scrap rate in the gigafactory. So I consider, did you take this into account in order to make your predictions for 2036?
Yeah, thank you very much. It's a very good point. We have made a bottom-up modeling for scrap rate. We have by gigafactory a scrap rate decrease over 6 years, and we take a different percentage for scrap year 1, year 2, and so on. And we have two different curves, depending whether it's a new entrant or legacy players like Korean and Chinese player. Of course, the experienced player, they have much more experience. So they start a production with a lower scrap level, but it's not 5%. Huh? They take roughly 4 years to reach 5%. And for me, battery is not automotive. Battery is a chemistry. It's a continuous process, highly complex, as complex as semiconductor. So when OEMs were thinking of having a 5 ppm as scrap rate leaving the plant, it's a dream.
We will see.
Yeah, and for end-of-life batteries, we have made a similar bottom-up forecast. We have a model for a car in operation in Europe by model, and we know for each model the description of the battery pack, the size, the technology, the format, and so on. And we have taken laws for lifetime duration. We have taken as well a percentage for EVs leaving the park after an accident. And the percentage is similar to thermal engines, but it's like 2%. So this is hitting the market. So it's a very detailed forecast. You had a question.
So I have a general question. So China is dominant in this battery production for 30 years. They have experience. If even Europe get the factory, they cannot be as efficient as China because they have 30 years of experience. But sending the black mass is economical to China, but it is very CO2. It releases too much CO2. I didn't see a model about CO2. Is there a way of CO2 reduction and localization, localization of recycling?
Yeah.
Does it mean that we need to send the black mass to cheapest place?
Yeah.
Or can we democratize the cycling? Or is there no model on that?
Yes, you are fully right. On the page I have shown, it was without taking into account transportation cost. So it was just comparing two recycling plants, one in France, one in China, and to see the various gap. But of course, you need to include transportation. You need to know where the black mass will be delivered. The second element, I think, is you have seen in the battery recycling projects, you have a few Asian players which have positioned themselves in Europe. I think it will grow. And if there will be a balance between European and US player in Europe with a Chinese and Korean player, because they are advanced not only in battery production but in battery recycling, of course, as well.
Thanks.
Right. Thank you, Remy. We're going to have to cut it off there.
Yeah.
And up next, I'm probably going to butcher this last name, Alberto Pascual. All right, that's bad. He's the commercial manager at Encycle, working on the non-US based business development and go-to-market strategies. And prior to Encycle, he has a background in venture capital around climate tech, energy, sustainability. So with that, Alberto, please join us on stage. This one to change slides, not that one. What was this one? Yeah.
Let me do some quick testing here. All right, cool. So good morning, everyone. Thank you for welcoming me to present today. Actually, thank you to Elite Event Group. Thank you to Cameron, Maria, and the team. I think I'm the second to last speaker before lunch, so hopefully I'm gonna try to make this brief so everyone can get their lunch break. Yeah, today I'm here to talk about critical minerals onshoring. And the reason I'm actually going to bring up this topic is because there's been a lot of discussion in the last few weeks, especially with all the Ukraine and US deal around critical minerals onshoring, and you know the presence of the United States and sort of the fight for critical minerals in Europe. And essentially, we have a very particular view on why this is happening. And one of the main reasons why we believe that Europe needs to do a better job in critical minerals is because essentially there's a lack of refining across the whole supply chain, right? So I think Remy, I don't know where Remy is, but Remy did a great job on presenting before some of the challenges that we're facing across Europe, specifically with the lack of PCAM and CAM. I think for my presentation, I want to focus a little bit more on midstream refining and what's going on with midstream refining. What are some of the challenges there? At the end of the day, you know, we see that you know things are moving slow with refining in Europe, and a lot of projects are getting canceled left and right. So yeah, I'm trying to cover that space today. So the European Union or Europe has a gap in critical minerals refining. This works. Okay. So the chart that you're looking at is essentially a chart by Fast Markets, which covers essentially the scrap market that is available, essentially to be pre-processed or refined. What we can see in this slide is specifically is that there's a clear. Actually, I'm gonna take the mic. Okay, perfect. Essentially, what we see in this slide is that there's a clear gap in refining capacity, right? So what happened in Europe is a slower than expected EV growth has caused the whole pre-processing capacity to be over-dimensioned. And there's essentially a lack of effective scrap or battery scrap supply that could feed enough of the existing pre-processing demand. This is essentially because many of the pre-processing capacity requires specific volumes to operate. And at the end of the day, the takeaway here is that we need a lot more flexibility to be able to match essentially pre-processing demand with scrap supply. The other big elephant in the room, which I was covering before, is that there's not enough refining here in Europe, right? And there's several reasons for that, which I'm going to cover during my presentation. But essentially, the main problem that we're seeing here is that there's these refineries take huge capex investments, require minimum volumes, and they require essentially a large availability of scrap supply to be operating. I think the other reason, before I jump into my next slide, why black mass payables are low here in Europe, which hasn't been mentioned, is that black mass is considered a waste product, and not a lot of companies can process it in Europe. So there's not a lot of refining that could take it here in Europe. Meanwhile, the companies that could take it outside of Europe have a problem because unless you have a TFS permit or a permit to process it as a waste facility, you cannot really deal or take the black mass, right? So we have two problems. One, that not a lot of people can take it here, and that not a lot of people can take it outside. So hence the low payables. Black mass, as many of you know, is considered a waste product in many regions of Europe. Specifically, there's some other folks and other jurisdictions around specific regions in Europe where it's classified as a product and this unlocks its value. But obviously, the clear takeaway here is that we need more local refining, both in Europe, that the nature of these feedstocks and of this black mass is decentralized. Hence, we need localized refining. And at the end of the day, we need to start working on this now and not in 2, 3, 5 years, because the Critical Raw Materials Act, although it's non-binding, is already setting certain targets. We are already at the EU Commission level, we are already working to harmonize all this hazardous material classification. So we need to take care of refining today and not in like 2 or 3, 5 years. I think Remy already had a slide, but this is a non-exhaustive list that we put together with some of the refining cancellations and PCAM and CAM refinery cancellations and gigafactory cancellations. The reason in our view, the reason why refining projects are getting canceled is mainly for 2 reasons mainly. So one, I'm going to relate that to the market and what's going on from a market standpoint, and on the other side from a deployment standpoint. So from a market standpoint, really what we're seeing in the market is that there's been an oversupply in metals, right, in battery raw materials, specifically coming from Asia. So critical minerals like nickel, cobalt, lithium have been oversupplied by countries like Indonesia, and this has caused the price to tank essentially. So the price tanking has affected obviously the margins of many people that are trying to refine, and this has an effect upstream, right? So that this is one cause. The other one is that I was alluding to earlier is that the slower than expected EV growth has a domino effect in the end of the day, and that means that there's less PCAM and CAM, that there's less material requirements, and hence there's less refining and less projects required, right? So that's one of the reasons on the market side. On the deployment side, setting up refineries is not an easy task. I've seen some people talking about what are some of the challenges, from the different technological standpoint. But I think from a regulation standpoint, we also need to cover that. And the main takeaway from this slide really is that a lot of the projects that are being canceled or delayed in Europe are mainly because of permitting reasons, right? So both for pyrometallurgy and hydrometallurgy, it takes anywhere, I would say, on average, 2 to 5 years to get permitted in Europe or several regions. But mainly for hydrometallurgy is because of all the chemical waste associated. So with sodium sulfate, and with pyrometallurgy, it's mostly because of the high GHG emissions associated with the process. As you can see here, many of the projects are getting canceled, and there's really no clear path on when this is going to be solved. But I think the whole industry in Europe needs to align in order to create a localized supply chain. And through my presentation, I'm going to highlight specifically how we could cover that through EU regulation and through policy, right? So at the national level, there have been some critical materials investments mainly through 2 strategies, right? So on one side, some countries are creating localized funds to invest in critical raw materials. So we're seeing that countries like Germany, France, or Germany, Italy, or France are investing in their own sovereign, or let's call them domestic critical materials funds, whereas others like Hungary or Spain or even Portugal are taking a different approach. So what they're doing instead they're investing in specific projects, and they're pouring funding into specific companies rather than opening a pool for funding. As I was alluding to before, the Critical Raw Materials Act, although it has a non-binding status, has set up specific targets for critical minerals recovery. But in the end of the day, it's a non-binding kind of policy piece. So we need to make sure that this policy turns into a binding piece of policy in order to rush both industry and policymakers at the country and EU state level to take action. In the end of the day, and as I'll be covering in these next slides, in our view, some of the funding that is in the EU is really scattered, and this is the view of a US company that is also looking at funding, and it's also hard to navigate, right? So there's many different mechanisms. There's the European Investment Bank, there's the EU Commission, there's the important common projects of European interest, and essentially it's just a hard to navigate ecosystem. Not to say that there is some funding going on, right? And we were investigating on our team what projects are getting funded in refining in Europe from the European Investment Bank, right? And we went through a non-exhaustive list again of around 30 plus signed projects by the European Investment Bank since 2020 across the battery raw material supply chain, which includes energy storage, EV batteries, etc. And we only found 5 projects in refining. This is a big issue, and essentially the reason we're saying this is because the investment in the EU or the investment of the EU policy or the EU regulation needs to cover the whole supply chain. We cannot just cover gigafactories. We cannot just cover PCAM or CAM. We cannot just cover shredding, because in the end of the day, what's happening or what will happen is what we saw before. Black mass is going to be exported. We're going to lose the value of the critical minerals, and we're going to have a lot more issues there. There are, however, some important pieces of policy going on and some important sort of progress going on at the funding level. So in our view, we view vertical public funding as a key to building a robust supply chain in Europe. So for instance, one good piece of work that we found is the important projects that come on European interest. So these 2 funding announcements were announced by this kind of funding mechanism is led by the European Commission, and essentially it announced on funding in 2019 and 2021 across different pieces of the value chain. All this slide to say that in the end, what we need to do is we need to fund all pieces of the supply chain, right? We cannot just fund cells and modules. We cannot just fund battery systems. We have to also take care of raw materials and mining sources, and we have to take care of repurposing, recycling, and refining, right? Us coming from the US, I think we wanted to highlight some good work that at least the Department of Energy we feel is doing, at least in streamlining different funding mechanisms. So right in the end, in the Department of Energy, we have different funding mechanisms depending on the stage of the company. So the Loans Program Office, this is the manufacturing energy supply chains, SBIR grants, essentially making it easier for companies that are looking to access funding to advance their businesses to be able to access to one streamlined mechanism. On the flip side, Europe has already started this. So we recently saw that the Innovation Fund, led by the European Investment Bank, launched a call for 3.4 billion, of which 1 billion will be focused on electric vehicle battery cell manufacturing. So essentially what we're saying here is just launching these specific calls does help for everyone who's looking for funding to say, okay, I have to look here, I have to look there, but there's only one place where I'm looking at, like not several thousand places, right? So essentially the key unlockers for public funding and the critical minerals for the EU, we view as 3 key areas. So on one side, the Critical Raw Materials Act, as I was saying before, needs to get legal binding status. So we need to push this across policy. We need to make it binding. We need to force folks to refine here, not elsewhere. We need to keep the materials here. We need to also avoid them getting exported to other places. So we need to create localized refining. On the flip side, we also need to streamline this funding, right? We have all these different funding mechanisms that I mentioned earlier, but in the end of the day, we need to make sure that all the funding gets streamlined. Lastly, and for the last part of my presentation, I'm gonna talk a little bit about the state of the art. I think again, Remy did a good job highlighting a little bit of what's going on. In my previous slide, in one of my original slides, I was talking a little bit about the lack of refining, right? But if we double click into that, what does that specifically look on a critical mineral basis, right? So and how does it look metal by metal when it comes to at least the NMC or nickel, cobalt, manganese, and lithium metals? What you're looking at in this slide, what you're looking at in this slide essentially is that lithium, the net mined, refined, and recycling supply
domestic lithium in the EU by 2030 will be enough to meet demand. In fact, there will be some net exports of lithium, of refined lithium supply to other countries. But when it comes to nickel, cobalt, and manganese, what you see here is there's a net import of both mine and refined supply, right? So there is not enough nickel, there's not enough cobalt, and there's not enough manganese to meet the needs for both PCAM, CAM, and EV and energy storage systems. So that's one of the takeaways, right? But the other big takeaway is that the current options are pretty limited, right? So we've seen that many of these projects have been paused, halted mainly by large capex costs, significant volume requirements. So many of these hydrometallurgical, pyrometallurgical facilities take several kilotons of volumes in order to make profitable sense. So we need more modular solutions that make more sense and are adapted to the nature of the feedstocks, right? Like the market in the EU is not gonna grow as fast as many hydro and pyro projects expect them to grow. So we need to create a flexible and modularized system that is able to adapt to this adaptable, like essentially supply of critical minerals. On the flip side, I think the other big reason why some of these projects are getting delayed is because of the high energy and labor costs associated with refining in Europe. So that's another big reason. This is a non-exhaustive list also of some battery recycling companies in Europe, staged by the TRL and also by the technology they use. So essentially, in the interest of time, I'm gonna skip and talk a little bit about Encycle's metal refining approach, which we feel is different to what is being offered in the market, and hopefully one that works for the EU as well as for the United States, where we're already operating. So Encycle is a critical minerals technology company, or critical minerals technology refining company. We developed a new refining solution called electroextraction, which at the core really is a new technology that as a novel kind of feed here, we're using renewable electricity, we're recycling some of our consumables, and we're developing a new sustainable model for refining. Connecting some of the points that I made throughout this presentation, our model is co-located, so we're able to co-locate next to to where these feedstocks are being refined and where they're being essentially pre-processed or converted into black mass. And we work essentially with three types of customers, which are like scrap recyclers, manufacturers of battery and auto OEMs, and also mining companies. This is because we do not only focus on battery materials, but we also focus on rare earths and copper. As a company, we have a clear growth plan. So we already have an operational facility in Ohio in the United States, which I'm going to talk about shortly. And we have a clear plan to grow to deploy around 6 sites by 2027, or 30,000 tons per year of recycling input for our refining system. In addition to this, we develop a modular solution, which not only helps with CapEx deployments and reducing the cost, but also lowers the GHG emission footprint. So our environmentally friendly solution has up to 92% lower emissions than mining routes, and up to almost 44% lower emissions than hydro and pyro. I think that I would like to essentially double click on the modularity and the localized approach, because I think it fits very well with the growth of the battery recycling ecosystem here in Europe. But essentially, this is at a very high level what we're up to. Lastly, and very briefly, I'll cover what our plans. So unlike many other companies that you saw in the other slides, we are already commercially operational. So we've already deployed our first commercial facility in Fairfield, Ohio, in the United States, where we're ramping up to process 3,000 tons per year of black mass and other nickel and cobalt scrap into 3 products, mainly a high purity NMC hydroxide, a lithium carbonate, and industrial grade graphite. I think what we view as some of the environmental friendliness of the technology have translated into us being able to get our permits in less than 6 months. So that's something that is unheard of compared to the 2 to 5 years that I was highlighting across my presentation. And in addition to that, due to the modularity in our capacity to go into brownfields, we actually deployed the project in around 12 months. We went into a fairly small building, so it was around 2,000 square meters.
And the purpose of the facility is really to highlight that we can be operational fast, that we can refine, and we can create a refining technology that could essentially is fit for purpose and can be co-located next to our partners to refine their critical minerals. I think that's the end of my presentation, and I'll welcome any questions. Thank you very much.
Thank you, Alberto. Any questions from the audience? Either is really good or really bad.
Yeah, lunchtime then, or I think there's another one.
Yeah, Remy?
One.
Yeah, thank you very much. It was a very nice presentation as well. I have a question which is more on the geopolitical side. Do you expect funding on a battery project across the value chain to slow down significantly with a new US administration? Or do you think they will find a way to keep this project? Because I was very impressed since IRA was created to see how many projects were launched and the level of funding they were getting easily. So maybe.
Yeah. Thank you. It's a tough question. I'm not gonna lie. I mean, we are also watching the evolution of the new administration. I think for us, one thing is clear, and that is the new administration at least cares about critical minerals, and it cares about onshoring critical minerals and keeping them on site. Whether that is gonna be specifically used for EVs and for batteries, that's something to be debated. We see, a lot of insistence and push on defense, aerospace, and other sectors which also need these critical minerals. I think in our view, there's also the argument on whether the IRA will be removed completely or whether it's gonna stay. I think for some of these areas it will stay, and for others it will be removed. We've seen already the EV tax credit being waived, but at the end of the day, it's for us it's clear that both the Europe and the United States want to keep the critical minerals onshore, and because they feel that there's a clear competition against Asia. And because, many people say that critical minerals are the new oil, and we think that's true. So in the end, we need to take care of keeping them onshore. So.
Got time for one or two more questions? Well, I have one. The greenhouse gas emissions number you put up there.
Yep.
In electrochemical, it all comes down to the electricity source.
Yep.
Are you assuming that there's renewable, not really counting energy, or what if the energy source comes from natural gas, coal, et cetera?
Yeah, it's a good question. So that the up to 50% lower emissions versus pyrometallurgy and hydrometallurgy, which wasn't in the slides, but which I mentioned, is assuming 100% renewable energy in our system. Obviously, we in Ohio, for instance, we have a contract with certain suppliers for 100% renewable energy. The area which is proving very hard to tackle and to cover for GHG emissions is scope 3 emissions for chemicals, right? So all the hydrometallurgical facilities need to really watch out for that one.
Challenge across the industry, and it's kind of just no one knows, right? How to calculate it, no one knows. It's some secret sauce that you just hope.
Yeah. Yep.
You said you're a US located company, but you mentioned that there's public funding in the EU. And we have heard that some of the European projects are on hold or cancelled. So are there plans that you expand to Europe, taking some of the money?
Yeah. Yeah, I mean, we have plans in Europe. We have plans to expand this year. That's one of the reasons why we're here and why we're in Europe. We have been looking into funding, and we think that we have a unique approach to metals refining. So, TBD on next steps. But yeah, we're very excited to be looking at projects with several companies here in the in Europe to deploy projects. So let's see what happens. Cannot answer much on but thank you. Look forward to chatting later also.
All right, thank you, Alberto. Up next, we have Dr. Tom Vosges. He's the Director of Public Policy at GRS Services. He's also a EU representative in Brussels for GRS. He's spent over 20 years working in the sustainability and circular economy with quite the pedigree working in the UN, the OECD, ICC. So it should be really, really good information coming around the regulatory impacts of how it's going to impact the free market type operations. So with that, Dr. Vosges, invite you up on stage, please.
Thank you very much. Thank you very much also for the invitation. Okay. It's not just about recycling batteries, it's about future-proofing industries, securing resources, and about redefining sustainability in the EV revolution. We heard a lot about different battery chemistries, a lot about recycling, and I want to talk a little bit about the perspective of a producer responsibility organization. So getting the batteries from those users once they are approaching end of life and getting them onto recycling. So really enabling the recycling. So first, a little bit about GRS, which stands for Gemeinsames Rücknahmesystem, which for English speakers doesn't roll off the tongue very nicely, I'm afraid. It's the joint take-back scheme. We are the legacy producer responsibility organization in Germany, meaning we were the first. It was at some point opened up to competition, so we are one of 4 or 5 now. So we've been around since the late 90s when the first battery take-back system Germany-wide for back then just portable household batteries was established. So these small bins you will see in supermarkets and other retail outlets where you can drop off your waste household batteries. Since then, we have grown to also cover most other battery categories. So we still, of course, operate the portable battery take-back. Actually, GRS split into a for-profit and non-for-profit. The for-profit, for legal reasons, is the one looking after the household batteries, and the for-profit operates the other voluntary schemes. So we have these voluntary take-back schemes in the for-profit side of operations I am with. And we're looking after e-mobility, which really sounds like electric vehicle batteries, but it is mainly e-scooters, e-bicycles. We look after power tools, devices from the health sector, and a lot more. And we have individual schemes our clients can sign up for, and we are in charge of building up the back office structure for it, basically making sure that there are partners there where batteries can be dropped off, that we know once they're full that we have processes in place for them to be picked up, batteries to be sorted, and then arriving safely, particularly with lithium batteries, at the appropriate recyclers. Last slide about us. I promise I will talk about something else as well. We are very proud of the safety standards we have built up over the years, particularly with lithium batteries. A number of the previous speakers alluded to the bad habit of those things of burning and exploding. So the more you have those kind of batteries and the bigger they get, the more careful you need to be with transporting them and storing them, of course. So just to set the scene, we heard a lot about the EU battery regulations. I'll be talking about that as well. Obviously, there are many other policy packages in place. And at the very last slide, I will be giving a bit of an outlook what might or might not happen over the next couple of years in the von der Leyen Commission Part 2. Obviously, we all know we are living in interesting times at the moment. Economic growth, competitiveness, one of the 3 points of this triangle, getting ever more important, and particularly with what is happening across the pond with the Trump presidency. It is sustainability. That's very much the starting point, the EU Green Deal, and now big discussions. Is it being dismantled? Is it being renamed? What is happening with that? And then geopolitics. We just heard a lot about geopolitics. So supply chain stability, getting hold of the battery minerals we need. And from our point of view, enabling recycling, of course, it's extremely important to make sure that as much as possible, we can use recycled content and build up a supply chain here in Europe. So as I alluded to, of course, the elephant in the room very much is the EU battery regulation in force since last year, but with a lot of secondary legislation fleshing it out, coming in over the next couple of years, and also new targets only coming in bit by bit over the next couple of years. But there's a lot of other stuff as well, and very much relating to circular economy, recycling and collection, and global trade and raw materials. So just to mention a few, the Waste Framework Directive, right to repair, so that recycling is only sort of the worst case. We don't want any waste at all, so it should never go to landfill or anything like that. But even recycling shouldn't be the first sort of reflex. It should be the last resort. We should be able to reuse, repurpose. We heard a lot about that as well. And repair, so right to repair. There are different rules. There are rules for extended producer responsibility, EPR, within the battery regulation, of course, but they are also being developed elsewhere. So we need to look at streamlining of those kind of things. The Eco Design Directive, again, we heard about that in the morning already, and this is the EU trying to do something about it. So manufacturers not always necessarily want to think about what happens after the end of life when designing it. Making money probably at that point is a little bit more important, but the Eco Design Directive looks at designing products in such a way that recycling is already thought in. The WEEE Directive, so waste electronic devices, which often have batteries in there. That means that batteries then end up in the wrong waste channels. And also the way EPR for WEEE is governed is different to how it's done for batteries. So again, we need streamlining there. And then global trade, raw materials, so the Critical Raw Materials Act, waste shipment, we heard about that. So black mass only going to OECD countries and all of that. I'm not going into all the details here, but just an overview of the different targets for collection, recycling, recycling efficiency, and recycled content. So a lot of stuff there for recyclers to wrap their head around. The EU battery regulation, coming back to that, also introduced new types of battery categories. And as I said, much of this is being phased in over the next couple of years. Some of it will still be affected by secondary legislation, so implementing acts, delegated acts, meaning in the battery regulation, we pretty much only have headings or sort of short wishes what the Commission wants to achieve with this, and the secondary legislation fleshing it out, figuring out how to actually do this. So the implications for take-back schemes and EPR, so very much what we are looking after. yes, they're very ambitious collection targets, but it is our role to say to policymakers, yes, we want to help with that. I mean, we come from a background of running the first household battery take-back schemes, so really from an environmental point of view. So yes, absolutely, we want to help with reaching ambitious targets, but one point we've been making, talking to policymakers for a very long time now, is at the same time they have to be realistic. And this is very much the available for collection, which I think is something pretty much our sector has invented a while ago when the new EU battery regulation was slowly being developed. There was the plan to have certain ambitious targets, and again, ambitious is good, but making them apply on, I think, the last 2 or the last 3 years of sales of put on market divided by 2 or 3, which given the length of the life of a battery would be a big problem for us. And in this room, I don't need to explain that. We've talked a lot about already, or heard a lot about lifespans of batteries. Our industry has carried out a lot of life cycle study, really bit by bit looking at batteries arriving in our collection baskets and trying to figure out how old they are, looking at the numbers on them and all of that. So obviously across the range of battery categories, and the not very surprising result to a room like this is we're looking at 8 years, 12 years. We heard about new battery chemistries for EV batteries being developed, which will be even far in excess of that. So then it gets even more interesting. But let's talk about 8 to 12 years, and that is not always just the lifetime of a battery, but it's also hoarding, people just having them lying around at home, thinking, yes, we need to drop them off at some point, but that really taking a while, or them being hidden in products. My example is always, I have a fairly old camera at home from those days when smartphones couldn't really do pictures that well. There are batteries in there, I suppose. I haven't taken them out, they're still there. I guess I should return them. So the point is, it takes a very long time in many cases for them to come back to us, which is why those quotas cannot be based on what happened in the last 2 or 3 years. It has to be what we call available for collection. And JRC, the European Commission's Joint Research Center, just a few weeks ago published their recommendations how to put together such an equation. So that a very important point for us, implication of batteries in waste electronics. I've spoken about that already. We might need more innovative take-back schemes. So we need to figure out how to get the batteries back, how to reach those targets. And these days, batteries are in a lot of other stuff. And I know this is a conference about EV batteries, so I won't dwell on it, but they're obviously tiny lithium, still dangerous batteries in vapes and all of that. There, we don't really need to talk about available for collection. They don't take 12 years to come back. They would, if people would put them in the right waste channels, come back quite quickly. So a lot for us to wrap our head around. So looking at the challenges faced by the recycling industry, and you will all be very aware, or I suppose painfully aware of this. So ambitious targets, to reiterate it, around recovery, content and efficiency. So technological hurdles, we heard about Asia being far more advanced there. So geopolitically and in terms of competitiveness of Europe, we should build those up. Then cost, content, value, business case, looking at different chemistries. Obviously, some batteries are, or the contents or the stuff that can come out of recycling processes can be worth a lot more money with some batteries than with others. red tape, reporting obligations, although some of that might go back, although the question is with EU plans on cutting red tape, how much that will affect things like the battery regulation. But overall, the European Commission seems reasonably committed to cutting red tape and reporting obligations, but certainly the threat of those are still very much there for this industry. Regulatory uncertainty. We are being asked a lot of questions by our customers where we honestly have to say, good question. We don't really know at this point. Our customers really don't like this answer very much, but it is the answer. So uncertainty really being a big word about the EU battery regulations and other policy pieces. And then access to information for SMEs, of course. So the larger a corporation you are, the more you will have people on board who can monitor political developments and do lobbying and all of that for you. Much smaller will not be able to do that. Phasing in of targets, I've alluded to that a couple of times. Again, I'm not going through this in much detail, but just to give you an idea, it became a law in 2023. It started applying in 2024. We are now in 2025, obviously, and for another 6 years, stuff will happen. And this regulatory uncertainty will bit by bit go away, but there's a lot more to come. So that's really just the point I wanted to make with this slide. Then I want to say a little bit about digitalization and the battery pass. This has been mentioned a couple of times as well. And again, just from our perspective, and regulatory uncertainty is another one about this. So there is Battery Pass, there's the Global Battery Alliance. There are a number of clubs in different regions that try to develop sort of a blueprint for this. And it always sounds like it's very, very straightforward, and parts of it, I suppose, are. But from our point of view, again, open questions still certainly are. So there will be different levels of access to data. Some of the data in there will be, particularly on battery chemistries, will be patented stuff. Companies don't want that to be in the public domain. So we need access to information in there granular enough that it allows us to figure out what is dangerous and, much more importantly, what is the right recycler. So if this is done right and we have the right kind of access privileges, it could help us considerably with sorting, maybe even getting rid of sorting, but immediately the information in the battery pass will tell us where this needs to go. And the second bit is the checkout. We are in between a consumer, a user, industry having a battery that reaches end of life and a recycler who turns it into waste. So at some point it will cease to be a battery, it will just be waste. So at that point, somebody needs to press a button. The question is that us? Is that the recycler? And this pressing of the button, how exactly will that work? And will it be an easy task, or will it be something that causes us money, where we need to build up some IT infrastructure, where per battery we need to do something that cannot be automated, in which case there will be, again, additional costs that industry will probably pass on to the consumers. And finishing off now, obviously the new European Commission under von der Leyen only really just started. During the transition really from VDL1 to VDL2 end of last year, there were already the first signs that competitiveness really is something we need to worry about. So it was the Antwerp Declaration coming from industry, then it was the Letta report, the Draghi report, all of them saying it's an existential threat the EU is under, and clean tech, batteries, recycling of batteries, critical raw materials, all of that, a huge part of it. Responses to that were already that in the work program of the Commission, circular economy is quite prominent. For the first time, there is a commissioner with the words circular economy in the title. And really the last bit that came out, the competitive compass, where there will be a lot of different policy packages. The Circular Economy Act, very important for us. There is a hope that it will look at EPR a bit more across the board rather than being rather fragmented now. And funding, what we heard about before. And it's exactly that different member states sort of doing their own thing, and the EU still not being really able to do it on an EU level enough. And all of that happened before Trump took office and all hell break loose. So now, of course, it's getting even more interesting. My time here is already on minus in bright red. So the key takeaways, there is certainly a push on EU level for circular economy and all that goes along with it. There will be stricter collection and recycling targets. That's in the law. Not much can happen about it and probably shouldn't. EPR expands across the board, and we need more harmonization there. Regulatory challenges for industry, I spoke about that at length. Digitalization, battery pass, hopefully when implemented in the right way, helping us with that. And further upcoming EU legislation. And with that, thank you very much for your attention.
Thank you, Tom. We have time for 1 or 2 questions.
One.
Thank you, Tom. Julianne from EBRA, as you know. One of the things in the EU battery regulations concerning take-back systems is the fact that producers themselves can't really do a closed-loop system. And how are you going to handle that? For example, BMW recently announced that they would be taking back all of their batteries, but what will they do when they get batteries that aren't ones that they've put in? So have you considered that, and how a take-back system can get producers to sign up so that they are all part of this collective system?
Thank you for the question, and good to see you again. Yes, absolutely. I mean, we are part of a club called Reneos that does take back of damaged EV batteries more on a sort of case-by-case basis at the moment. So it's a club of a number of producer responsibility organizations such as ours across Europe. And basically, at the moment, it's production scrap, and it's, we heard about that, it's EVs that have been in an accident that impact the battery. So we are part of an organization that has processes in place to deal with that. On a wider scale, yes, absolutely. I think it's sort of the instinct of car manufacturers to say, thank you, we'll take care of it. But it's exactly that point. If you take back, if you have to then take back a battery that is not yours, that's how battery take-back schemes such as ours 25, 26 years ago were born. You need a scheme in place, and you need a pot of money that fills up via putting on market. So yes, it would absolutely be our recommendation that there needs to be a scheme like that. We would be happy to help. Obviously, the EU battery regulation partly tries to make these processes possible across borders. So at the moment, companies like ours operate in specific member countries, but not really across borders. Reneos is the first attempt here, really, and it's on a very ad hoc basis compared to that. So yes, we need something like that, but I would file that under regulatory uncertainty at the moment.
G'day, Sean Joseph from Altilium. The question I've got, and this is probably not for you to answer, is that the problem requires you to commit long-term capital today, and yet we're probably not going to come to the end of the regulatory outcome until probably closer to 2031, when the regulations come in Europe for minimum recycled content. Do you see there's going to be any sort of what's the word I'm looking for? Some clues, I guess, from a capital perspective, because you were getting asked to commit 5 or 6 years ahead without any regulatory certainty.
Yeah, as you said, I'm not really the one to answer that perhaps. Yes, again, regulatory uncertainty in terms of an EPR scheme. Obviously, if we put one in place, other people put one in place, companies sign up to it, then that is setting up that kind of pot of money. But as you rightly said, if you don't really know what happens at the end, then it gets really tricky. So this pot of money, which was set up 25 years ago for household batteries, that was probably enough of a headache back then. I wasn't involved in this industry at that point. But yes, if we talk about EV batteries and the size of those things and the amount of money needed to safely transport that stuff, yes, tricky.
And when you're competing against China, for example, that's very full steam ahead, creates an extra level of complexity, I guess.
Yeah, I mean, that is across the board, across industries, across clean tech, across everything. China does great at the moment, and the US not badly either, and the EU is stumbling along. Yes, we need solutions to that.
All right, we're gonna have to cut it off there. Thank you for the good discussions. I'm gonna break for lunch, which is across the hallway, correct, Maria?
Yes, it's behind the glass door when
Behind the-
you go through the elevator hall.
Yes. And we're gonna reconvene here at 2:10, so 14:10 for the next sessions.
And don't forget the evaluation forms.
Yes, yes, it's fine.
Great.
Alors moi,
And also, a quick note I got from Mila. She asked, she said that we have sound on during the break.
parce que j'ai pas d'historique avec lui.
Like we would have like standard picture and we will have sound off.
Yes.
Because then someone is checking here and microphone next to and audience online. Yeah.
Isolation of the sound, like here in the room, but maybe not on the street. Okay, thank you. I will do it. Okay.
Thank you.
Je peux à la limite essayer d'avoir ces coordonnées, je te les passe.
And now upload it.
Et alors pour le questionnaire, comment vous répondez? Je travaille de mon côté, première version capitalisant sur ce que vous m'aviez envoyé. On va faire la semaine prochaine pour discuter. Avant, si vous regardez avant, je dirais ça. Ça vite. Je vais me reconnecter, mais ouais. 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 Exactement. Ouais, je vais l'envoyer, je pense, au milieu de la semaine prochaine, je crois, mardi ou mercredi. on essaye de faire un point après-midi ou vendredi.
But we haven't, and this was uploaded this morning. So if you did not make
It's similar. So, panelists that do this and all the Q&A. Oui, excusez-moi parce que j'ai dû me reconnecter en fait, j'étais un peu après. Moi, jeudi et vendredi, je suis assez ouvert. Sauf de 14 à 15 le vendredi. J'ai une réunion. Donc, ça va facilement à vos disponibilités. À partir de quelle heure? Ouais, alors il faut peut-être prendre une marge parce que les gens sont ça dépasse, mais à partir de 15 à peu près 15h30. Et ce que je dis, c'est que je vous envoie le questionnaire mercredi soir et ça vous je vous l'enverrai à vous deux. Ouais. Et si vous avez peut-être un
Remind me the issues that you have that you have
I tried to put in my name. And it doesn't show the keyboard, or the keyboard disappears immediately.
It works every time, and
Yes.
in the computer you also
It could
we go. Got your attention. Everybody awake now? Good. All right, so we're going to start off the next session with Johan van Pepperziel, where he is an advisor at the Pepperziel Group, where it's a family company, second generation, and your kids are now working with the third generation of this family-owned business, with really an expertise on transportation and logistics. And today we're going to be hearing around the storage and safety of these potentially hazardous and dangerous batteries. Johan, floor is yours. So you freeze that, we're here. This one advances the slides.
Yeah. Hello. Good afternoon. Welcome in this session. I hope you all really have charged your battery again during lunch. And I will try to take you in the next 20-25 minutes into our challenges we see as a collector, a sorter, and a transporter of all kinds of batteries, and especially lithium batteries. And on top of that, since beginning of this year, we have in law a new storage building and compartments regulation called PGS 37.2, and that's storage of lithium batteries. And it's very, very challenging, I can tell you. But I will tell very little about Van Pepperziel. I will show a lot of pictures, what we are doing and what the rules are we have to oblige to, and etc. And I will also have some videos. I hope I will find some time to show the videos. Otherwise, I will skip them in the handout. If you or send an email to me, I can send you the PowerPoint, and then you can see the movies if you want by yourself, how we have done the testing and etc. etc. We are a company, or I say, Van Pepperziel company has, it's in 2023, 20 employees. Today we have 25, founded in 78, family owned. Our background is non-ferrometals trading, but we are today very active in batteries and battery-related material. We are working for compliance schemes like STIBAT, which today's foundation open. We work for ARN, the End of Life Car Association, where we do a lot of work for, and we work for compliance schemes outside the Netherlands, and we work also for big OEMs European-wide from time to time. If you want to do this kind of work, you need all kind of permits and also certificates like ISO 9000 quality, 14,000 environment, 45,000. MRF Keurmerk is our brand certificate that belongs to the scrap dealing part. We are also EKN Duurzaam is something like MVO, and we are since recently R2 version 3 certified. This is for electronic brokering of electronic scrap. This is a movie which is not automatically starting. Now it is. It's a movie, a very short movie about our company. I have put down the sound because it's my daughter is speaking in Dutch and almost nobody will understand it. You can get an impression about our warehousing and our compartments and what we are doing. Here you see a truck which is fully equipped compared to ADR with all kind of packaging related to the status of the battery, how we collect hybrid batteries, full EV car batteries, and all stages they can have. We are collecting on behalf of ARN in whole of the Netherlands, and we do exchange box by box. So if there is a recall because batteries are not coming back like status this morning, batteries are today, it's production scrap for recycling or for end of life is not much available, but we have a lot of recalls, unfortunately. And for these recalls, we use all kinds of containers like the orange one you see, or original packaging in which we exchange and we collect the batteries from all the companies or importers which are, let's say, member of ARN, the End of Life Car Association in the Netherlands, or we do it on behalf of the company itself. There are some international operating companies that are not have joined ARN for the collection of the batteries, and we do it directly with them. Here you see, I will explain later, these containers are for critical batteries, very expensive. There's also this, and this is our storage until, let's say, the end of last year, the orange containers you saw. I will explain later why we had to upgrade it due to Dutch regulations. So today, we have all the batteries should be packed according UN approved packaging instructions. It's coming from the ADR, of course. And all the batteries which are lithium should be in compartments. And at the end of the day, all the batteries should be out of our production site, and everything should be stored in containers or in compartments which are directly connected to the fire alarm system and with extinguishing, etc., etc. We have a permit for 160 tons of lithium battery storage. That looks a lot, but unfortunately, I disagree a little bit on the topics of this morning, the speakers, that there is a lot of capacity for recycling. Unfortunately, we are facing too little volume of recycling because our warehouse is overfull, and we are every time waiting and waiting for new notifications to be approved so we can continue the shipments. So this is not our experience, and also not the experience of the EBRA, European Battery Recycling Association. We have a lack of capacity in Europe for lithium, especially for LFP. What's new? We have a new permit since 2024, May. In this permit is written we should follow completely the guidance PGS 37.2. That's a guidance saying how you should store lithium batteries, how you should pack them, and how you should control it and check it, and ventilation, and etc., etc. I will explain it later. But it depends on the importance of the issue, if it must be realized in the next 3 months, or that you get 5 to 10 years, because it is a very high investment what you have to do. But you have to do it, otherwise you will become out of business, in the Netherlands at least. What is a PDS guidance? A PGS guidance, I will only read the 4 above, is a document about safe storage and associated activities with hazardous substances. The PGS guideline lists the most important risk of those activities for the safety of the employees, the safety of the environment, and fire safety. Now, the rest you can read in the handout, but then you get an idea about what we have to follow. The batteries of today, as you can see, nice Audi e-tron, already since 2019 on the market. And I have a bullet, yes. And of course the Model S. I have to say, and I have to admit, that also for us, the quality of the batteries are better than expected. Of course, there are warranty issues that modules should be replaced and exchanged and so on, also for the e-tron. But the life cycle of these batteries and the state of health and the state of charge is much longer than everybody was assuming. But if you look at what we have done, what we had to do for this guideline, I will now show some slides what we have to do. And here you see that is the storage until the end of 2024. As you saw in the short movie, all the containers are outside. They are all connected to the fire alarm, and they all have an aerosol extinguishing system. That's not enough. Maybe you think, wow, that is super, nice, very safe. But today that's not enough. We had to change and upgrade it. What we have done, first we thought about, okay, we put concrete material, this we call it Lego stones, concrete material around the containers to ensure 60 or 90 minute fire resistance. You can do it by distance, but then you have to do 15 meters or 10 meters, or you can do it by concrete material, and then you can place the containers close to each other. What we have done, if we did not choose for this, of course, we have chosen for this one where we have enough space, nice space here to put other material. And here you see all the containers next to each other. I will later show. Next slide, I see. This is how it looks. Concrete material. Each container has its own installation panel. We have 10 times air refreshment in the containers. Is all related to that each container has more than 2.5 tons of batteries in it. You can see some packaging material. You can also have standalone fire alarm system extinguishers, and you need overpressure valve. When you have a fire with lithium and the extinguisher is activated, then you have an overpressure that goes above 1.5 bar, and therefore you need to have at least an overpressure valve. Otherwise, the roof could open or break. Now, we had to do a lot of testing to get this approved. We did this in 2018, 2019, but last year we also did some tests in Dresden, in Germany, to get the approval to build bunkers inside our own warehouse facility. This is a compartment built with concrete material and stones and everything, and here you see outside containers. But the principle is similar. If there is an alarm, the aerosol will be activated and the fire will be stopped. Here you see a test that we have done. I will not show this because then we will have out of time. But it is fully with the Kiwa certification, with the insurance companies and everybody that has something to say about this, how we should do this. Based on the results, you can see that we have built compartments with walls and extinguishers, overpressure valve, and this is for e-bike storage, new battery material, and we have for ourselves this kind of containers outside for waste batteries or batteries for damaged batteries for recycling. Of course, when you are dealing every day with batteries, you also have problems with batteries, and from time to time. And can you please start this short movie? Because it's not starting. You see here Thomas, our employee, forklift driver. He heard something, and then the system is activated. You see all kinds of smoke coming out. This is aerosol combined with smoke, of course. Within you see the flashlight. So the over there. So the fire brigade is alarmed and is coming. And you wait 50 minutes, and then there is a new balance in the container. The temperature went down, the smoke temperature went down, and then the fire brigade is there. And together, you can see them there, together with the fire brigade, you're going to open the doors, you're going to remove the containers, and the one that has caused the problem, the container, you put aside. And if this battery, you can put in dry sand, you can dump it in water if it reignite or whatever. But in this way, you can have safe storage of batteries without, let's say, your whole warehouse burning down. Now, I will not show this movie, but we also have thermal cameras in the building. And with these thermal cameras, you get a message that something is going on. And here, when you look at home in this movie, you can see that the temperature went up here. Suddenly, the lid moves, and the people will transport the container outside. They will take the battery out and put it in the water because it was reigniting again. So they dumped it in the water, and we drowned the battery. Problem solved. Oh. Okay, PGS. Some words. about the PDS. You can read this, the legal framework, the risk approach and scenarios, the goals and measures to meet the goals. This is how it is built up. And if you go to the next slide, then you can see that we have the typicals, they have numbers, and the higher the number, the bigger the volume of the square meters of the warehouse or the showroom or whatsoever. So the bigger the risk, and the more rules you have to apply. For recycling, I will skip very quickly because I only have 6 minutes, I see. When you are in the recycling active, and this is for all lithium. This is for consumer batteries, for portable, e-bike, e-scooter, e-motor, hybrid, full car. If you have batteries discards for product reuse or for material reuse, you are allowed only to have a storage facility which is 300 square meters. You are not allowed to go above it. Secondly, the PGS guideline is following the ADR. So the packaging, which is you have to do, is of the material, is following the ADR. So if you have a product, it can be original packaging. If it is a waste battery, it can be in the normal packaging group, level 2 or level 1. But if it is critical, then you have to follow all these different steps of packaging. This is really an issue, and it is really a lot of work. And then a lot of investment as well. Now, what kind of ADR codes do we have? Now, I've put some here on the screen. You can see from lithium metal batteries and up to battery-powered vehicles or an EV car. Now, these are the UN numbers, and with these UN numbers, which belong to these products, you have packaging instructions. And if you forget the green and the blue, then and you look at the red ones, for the recycling, it's always difficult. We always have to face the red ones. And for example, here's 376, special provision is saying something about critical batteries. And then here you have the large packaging 906 or the P911 is saying what you have to do and what you have to follow. And it means that it's not only for transport, because ADR is transport by road, but also your packaging and your storage should be in this way. And of course, we have a lot of chemistries in the lithium ion, and the newest one is sodium ion, and it is coming on to the market already. And sodium ion is also in line with UN group number 9. So lithium batteries, sodium ion batteries are following the guidelines of and the rules of class 9 as well. So what do? We do in this 160 tons, we have 18 containers. We do less than 10 ton, because if you go above 10 ton per container, we are in the next level of safety rules, which mean polluted water collection, etc., 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 if there is a fire. It must be an approved packaging material. Like I said, you have 4 stages: product, end of life, damage, ineffective, and critical. And from left to right to critical, the packaging becomes more and more expensive. If it is not packed nicely, then you can put only 2 pallets above each other. And if the distance between the containers is not enough, you have to do with concrete material like Lego stones. Now, if you have more than 2.5 tons per container, you have 10 times volume of the container compartment ventilation per hour. 10 times. You have smoke detectors. In our case, we have direct connection to the fire department. And we have lightning conduction placed and grounding of the containers, all 18. And we have aerosol extinguishers in combination with dry splinter tubes. This is done. Here you can see one container. This is the side doors, because from the back you cannot put the EV car batteries in. And here you can see all the containers in line, and we have concrete material where you can see here the dry tube to connect water. And we have this because if the aerosol extinguishing is not working, so the fire brigade is not approved of okay that it's working, then you should have they want to have the possibility to put water on. So we have dry sprinklers in this container. Here you can see the ventilation unit, and this has to be rebuilt for the 14 containers, and only for these 40 containers, the investment was $250,000. We already had the containers, but we still have to do all the concrete material and the lighting, etc., etc., etc. Now we have 3 compartments inside, 75 square meters, so less than 300. We are allowed to store 150 tons of mixed material with lithium in it. This is especially for the consumer battery market. We are of course working a lot on, and we have control panels, and we need to have 90 minutes fire protection walls, doors, and screens. Now this is how it was until October 2024, and this is today. You can see here, this is the new warehouse. Here is the first warehouse, the gray is the first warehouse. This is the second warehouse, and here you can see the bunkers we have built for the storage of batteries. And only to build this, to stay in the business, was €550,000 additionally to continue working in this field. Some more pictures. Non-critical battery packaging material, critical battery material storage. These containers, stainless steel containers, they cost €30,000 a piece, and only one Tesla or one e-tron battery can be put in. Or in this one, we have several different products. This is for hybrid or e-bike, and this is even for one e-bike. But these containers are very, very expensive. We have an estimation of how many cars there will be on the market. Let's say that each car has a battery of 500 kilos. Everybody can calculate how many recycling we need in the near future. Now, I will skip this one. This is Richard Hammond, who damaged the Rimac 1 car in St. Gallen. But more important, after 5 times stopping the fire, the burned car must be transported back to Rimac to investigation. And we have developed this special container where damaged cars can be put in. And if the car during transportation starts burning, then also here there is an aerosol in the container which can be activated. So you have 45 minutes to an hour to move the car from the center of the city or from the mountain.
I can wrap it up.
Hey, look. Oh, sorry. Last one. I already said this. Last one. Thank you.
Time for maybe one question.
One.
Hello, this is Bjorn van Ven, Cleantron. I was wondering, you defined 5 categories for the batteries, 5 different statuses for how critical they are. How do you diagnose in which category a battery falls when you collect it?
Good question. The point is we can't. We have to trust the expert of the garage or the regional manager of a group of garages who's done the testing. For us, it's very simple. The practical rule: if the BMS cannot be read, it's critical. Dot. That's how we work. And if somebody doesn't want to work like that, then we do not do the transport for them. If the BMS cannot be read, even if the battery looks brand new, we will not transport. We will transport it only as critical. And I'm very proud that also ARN, the End of Life Car Association in the Netherlands, is following this rule as one very important one. But for us, we are a sorter, a transporter, and we dismantle, we can discharge to 0 volt also, but we do not have the equipment to see state of health. No, sorry.
Okay, thanks for your answer.
Let's thank our speaker.
I have one thing to add before Julianne, she is my Secretary General, starts talking. As EBRA and all kind of other associations, we have a industry guidance for collecting, handling, and treating waste lithium batteries. So this can be downloaded from the website, I assume. Yeah. So please take notice of it.
Thank you. So next we have Julian Adams, with Secretary General of EBRA, also the CEO of the European Electronics Recycling Association. Over what, 2 decades experience in e-waste, 2.5 decades of e-waste handling, and really most of the time was in auditing, 15 years of auditing. So I essentially left the dark side, now focusing on the really hard stuff. So we're going to hear a lot around all the challenges, technical, regulatory, logistical, safety. We hear it all. The floor is yours, Julie.
Thank you. Yes, thank you. So yes, 25 years this year, working in e-waste and battery recycling right across the continent of Europe. So there's really nothing much I've seen that would surprise me anymore, but it's quite interesting. But now my role is now concurrent, the two associations together, that hopefully will actually evolve as the way shipments regulation, critical materials and so on. So the challenges for both associations are very same. As it says there, the challenges and opportunities to battery recycling. So I'm not going to give you any answers. The idea today is to really raise the points, because people in the room can actually look for the answers and the opportunities. And I've spoken to quite a few people today that might have answers to a number of the things I'm going to be putting forward. So I'm assuming it's this button. Maybe not. Is there? The grey one, the other one of the two. Hey, here we go. So these are all the members of EBRA, and I say we cover the continent of Europe. We also have companies outside of the continent of Europe as well, Canada and so on. So quite a large range. We are the largest professional association for battery recyclers only. So we don't represent manufacturers, we don't represent collection schemes or PROs. So our voice is actually very important on the European platform. Challenges. So these are all the challenges. And I'm not going to read out the slides because death by PowerPoint is the worst, especially after lunch. But we have 8 challenges. So it's very interesting because it's not an easy industry. It's been an industry that's been around a long while, and actually people say, oh, there's no recycling, people don't know what to do. But actually that's nonsense, because some companies, as you've heard today, Johan, his company started in 1978. So we would hope that Johan's company knows what they're doing in terms of collections, which of course they do. So regulatory and compliance challenges. So we heard this morning a lot about the issues that recyclers and operators and manufacturers have. And not all of that is very true, that we don't know the answers yet, and that's part of the problem. So we have fragmented regulations that actually sometimes conflict with each other, which doesn't help. Stringent requirements. So the EU is generally ahead of the world in terms of environmental compliance and environmental regulations, and a lot of them are echoed or duplicated, sometimes with the square corners rounded a little bit, but the EU has been at the forefront of many environmental legislation across the world. Evolving legislation, so there are ambitious targets, but we don't quite know what those targets are yet because the Commission are late in getting them forward. Out of all of that, today, the European Commission are going to be releasing an omnibus package. So we haven't seen it. Raphael and I have been monitoring to see if they've come out yet. So the omnibus package was announced by the European Commission President a couple of weeks ago, and it's supposed to streamline sustainability reporting, We don't know what that means yet. We don't know if they're going to reduce their stringent obligations or if they're going to extend them or how they're going to streamline them. It's also looking at due diligence and taxonomy. Taxonomy is one of those pieces of regulation that if you fall in the rabbit hole, you'll never get out of. I think the last document I looked at was nearly 600 pages. But this omnibus out today will actually hopefully drive forward a lot of the things that we're waiting for. I was at another battery conference yesterday in Brussels about the battery passport, and there was somebody from the Commission, and they're saying a lot of the things to do with the Critical Raw Materials Act, the Circular Economy Act, the Battery Passport delegated acts, they're waiting for what's going to happen today to see where they're going to go. So you need to be watching that as well. Environmental and sustainability challenges. All of these things, as again we've heard today this morning, energy intensive. Some solutions today we've heard of might be less energy intensive. These things need to evolve as well. Waste management. You know, waste management has happened for many, many years. So when my grandparents were alive, you know, we used to call it being thrifty. You know, you used everything and you had special boxes and things that you saved everything. And then it became recycling. So, you know, it's the same thing, but, you know, it just becomes a little bit more clearer. But waste management is an overarching term. Economic challenges. Again, this morning we heard about environmental funds, European funds, bank funds. Most of the funding that was announced under the Critical Raw Materials Act are actually aimed at mining companies. And I've been to many conferences on critical raw materials, and in my opinion, it's miners voting for more mining. And why wouldn't they? You know, but we need to be looking at mining the secondary raw materials first. They should be the primary resource. And then when there isn't enough, because there won't be enough for a long, long while, then we should look to virgin material recycling or refining. Competition with primary materials is actually often cheaper to mine something than it is to recover it from a secondary source. So that needs to be thought about. How does Europe, for example, compete on a global market? You know, you can legislate to have targets and remove all of the different elements, critical raw materials, but if at the end it's cost you so much money that you can't sell it, you know, you're not going to be in business very long. Technical challenges. So LFP, as we've been talking about this morning, you know, there's not necessarily the solutions. There are other battery types coming forward, and the battery producers are not actually talking to the recycling sector saying, we've come up with a really good idea for a new battery. You know, can you recycle it? Is the technology available today, or shall we work with you to try and find how we do it? So we heard from the Faraday Association or Institute this morning about foldable batteries, pouch batteries, you know, and how they can be removed. That's a step in the right direction. But we need to be thinking about these today, because it could take 10 years to innovate, invest, find the right site, get the permits. So, you know, you need to be thinking of these things. Efficiency of material recovery, you know, going back to the money. You know, you might spend all of this time and money and effort, but if it's not efficient, then again, you're not going to have a market. Safety, as Johan was talking about, especially with lithium batteries, has to be a high priority, if not the highest priority. Every day you see on LinkedIn new reports about lithium battery fires, and that's really where that guidance that Johan very quickly showed you came about. It took 18 months with 9 associations, including Insurance Europe, who are an association of insurance companies, because they're impacted as well. So safety is particularly important. Logistical challenges. So collection and transportation. You have to also consider the carbon footprint. So you might have a country as big as Germany, as we heard this morning, that might be able to pick up one battery, but is that efficient in terms of its carbon footprint? Because all of that has to be reported up the line, has to be reported down the line. And so, you know, that's another topic that really people need to think about, not just I need a truck and I need ADR drivers and I need the right legislation. Talking of legislation for logistics, the Waste Framework Directive that I think Tom briefly mentioned at lunchtime. The Waste Framework Directive is about to publish an amended list of wastes. So that's the codes that batteries are applied. So the URAL code or the European Waste Catalogue code. They decided at European Commission level that they would change the classification of every battery from non-hazardous to hazardous. So lead acid batteries were always hazardous, and we don't, as EBRA, deal with lead acid batteries. But all batteries will then become hazardous, including black mass, because there is, you know, as many companies who might be sending it overseas to a refiner that has the environmental permitting, has the health and safety, has the human resources protections. There are the same number who don't have those protections in place. And that's very high on the European Commission's list of things to do. They don't want to be exporting a hazardous waste. So they're classifying black mass as a waste product because it needs further refining. That's why we know that there are many Chinese companies who are having partnerships now with European companies to develop and refine the black mass in Europe, because obviously most of the batteries are going to be made in China. So you get to that stage where it then becomes end of waste. So that's another step, another hoop that you have to fall through. Supply chain bottlenecks. So some countries are great, you know, there's a really good infrastructure in the Netherlands and in Germany and France and Belgium, but not necessarily the same in Lithuania or the Czech Republic. So chains and bottlenecks are bound to hit. And this is part of the problem today because European member states don't all have the same legislation, don't all have the same description, the definition of what a battery is. Is it hazardous or not hazardous? So, you know, as an operator, if you're taking in batteries from all different countries, 5 or 6 different countries, you have to understand the legislation in each of those. You have to report in each of those. So again, very, very challenging. Supply uncertainty. So we've talked about that a lot today, in that there may not be enough batteries today for all the potential recyclers. You know, if I had €1, or let's say 10 euros, that sounds much better. If I had 10 euros for every company who said, I've got a lithium battery recycling business, it's working, you know, I would say 1 is right and the other 9 are thinking about it. And possibly 7 of those haven't actually got a site or a premises, let alone a permit. So, you know, reality is not necessarily the same as actually what you see on all that lovely map that Batteries News produce. So you have to be very careful who you invest your time and effort and partnership with. Competition for feedstock. Traditionally, metals, any waste with a metal in has a competition level because people are bidding for it because they want the money, they want to be able to recycle it and so on. In the 15 years I was auditing, so I did with my team about 800 audits right across Europe up until 2021. You know, I never met a recycler who was only in it for the green benefits of the planet. At the end of the day, they want to make money. You know, that's why they're there. And we have to be realistic. You know, there has to be a CapEx return. And so, you know, the Commission don't seem to get this a lot of the time when I talk to them. And they think that, you know, recyclers can do it for the good of the planet. And yes, they will. But they have to know that they've got some money back on the return and the effort that they put in. So competition is actually quite high. Innovation and technological barriers. And again, you know, this morning, without repeating everything, we've heard quite a lot of different problems, different technologies that are potentially coming forward, and they need to be talking to recyclers and saying, what do you need? You know, what are you doing now? I mean, I sometimes have conversations with the Commission who you think from that there is no recycling. There's no battery recycling in Europe. And I'm saying, you know, I said a minute ago, they've been doing it for years. And so therefore, talk to them, see what they do, what do they need? You know, what protection do they need? Illegal exports is a big one. You know, if you can put an electric car on a car transporter, drive it onto a ferry, and then drive it across to the African continent, no waste, so there's no documentation, no proof of where it's going. So that needs the control. Scaling up. We've talked about all the numbers and how big the numbers of EV batteries are going to go. This is probably one of the most interesting, where there is a big gap, is a skill workforce and the know-how. Chemicals and the chemical makeup and the chemical processing is a very new industry. And again, there needs to be much more work with universities saying, what skills do you need? How can we help you? How can we train these people? What gaps do they need? Research and development is also very key, but we rarely get asked by R&D companies, to talk to recyclers, to come and visit recyclers, to actually see what they're doing and what they actually are looking forward to the future. And so that's very important in terms of being able to offer a cost-effective recycling service. Batteries are a very global product. And so if Europe makes it so difficult and so hard and so legislatively restricts the operations, how is anyone going to compete? Why would someone invest 15 million euros in a plant if all of it can be just shipped overseas under a different name? So a lot of work needs to be done to understand how we can improve things. And even this last couple of weeks, like yesterday or this morning, I mentioned when we had the Faraday presentation. Yesterday, a different branch of the Faraday announced that they have discovered a way to recover lithium using cooking oil. I haven't looked at the details, but that's an innovation, and we've heard about water batteries as well. So, in the future, will we need a lithium battery plant? And that hesitation and that unknown factor is another reason, in my opinion, why people don't want to invest today. If you build a 15 million euro plant and then next year or 5 years, there's a completely different type of battery that doesn't need any recycling at all, then your money is not necessarily well spent. So in conclusion, it's critical that we all talk to each other. It's very important that we all talk to each other, that we all work together, but respecting intellectual property and respecting the fact that people are investing their money. Even if it's a PLC, that's still shareholder money. So we have to respect that. So the battery passport, so I was at the meeting yesterday, is one method, but it doesn't mean we have to be transparent right the way to where a recycler sells their materials and what they get for it, which is what I know some consultants have said. There is a standard for the battery passport being developed. It's called DN99100. I learned that yesterday. And Senelec, and part of those committees, Senelec are developing 8 other standards to do with the marking of batteries, the recyclability of batteries, the recycled content, 8 of those standards, and they will all be finished by the end of this year because that's the mandate that they've got under the European Commission. So there are standards, but we all need to be looking at this on a global basis. Because again, if European battery manufacturers have to meet these standards and somebody overseas doesn't, that's going to make them uncompetitive. And so therefore, we're left with the same situation. So be part of the solution. So let's start the conversation off. So I'm here. If anybody wants to talk to me, I can give them the card, but that's it. Thank you.
Thank you, Julie.
Julianne.
Julia.
Julianne.
Julianne.
Julianne, never Julie.
I use both. All right. Any questions?
No, I've confused everybody so much.
One up here in front.
Thank you. Thank you for the listing of the difficulties that we face. In fact, one of the key, as you mentioned, problem is to have the skilled labor force. So as we are working in Romania on this item, I would like to know if on behalf of the European Commission, is there any commitment or it's a black screen?
No. So at the moment, there's no working group that the Commission are organising, but it's certainly on our agenda and we are talking to other people within our membership. But it is a gap. And that's why we call out to universities and research centres to be able to work together because, they might be working on their own separate projects, very likely are, but we're not talking to each other. And that's, I think, the biggest problem, communication.
How do you think we can solve that communication or information gap without infringing on Secret Sauce's IP trademarks?
Yes, and I think that's very important because, you know, thinking of the money it takes to invest and the time and the effort, you're not then going to share it with everybody. And we heard this morning somebody was saying that China are now not sharing their LFP recycling technology. And that's understandable because they've had 30 years of experience in it. So, you know, we do need to be mindful of that. So, I mean, I'm asked, you know, probably at least 2 or 3 times a month, you know, please, can you have 1 hour interview? We want to understand the technology that your members are using. I go, no, you know, I'm not going to tell you that because that's private to them. If you have an NDA in place with one particular recycler, that's up to you two to discover that, you know, the barriers and the boundaries of what you can ask. But it's not something that should be on an open platform. And that, unfortunately, is what the DPP, Digital Product Platform, and Product Passport rather, and the battery passport, a lot of the consultants saying, yes, transparency for everything. But manufacturers, in my experience, want to know what's in everything and where it goes and how much they get, because they want to know how much less they have to pay a recycler for the effort. But, you know, that's great. You know, let them go out and build their own recycling plant is my quick answer to that one.
Hello, this is Jared from Shanghai Metals Market. So I'm going to ask you about your opinion, because currently many Chinese companies, they want to invest or to do recycling business in Europe. But as you have said, the situation varies a lot between even within the EU, like you mentioned the legislation. So in your opinion, could you recommend which kind of countries do you recommend if Chinese ones want to build up a plant in EU? Yeah.
So you can probably hear from my accent that I'm from England, but I have an Irish passport, so I'm Brexit proof.
Yeah. So you maintain a very
So I'm
maintain a very objective.
If I take the stance of Switzerland today, so, you know, very neutral, I would say don't open one in France, because they have a lot of legislation. It's very good legislation, but if you are a brand new startup, France would not be the first place I would recommend. I would look probably towards more Eastern Europe, so Lithuania, the Czech Republic, Romania, because they're very willing and open, and they do have investment funds available, and green parks, industrial parks. Environmental permit legislation can be very difficult. And, you know, aside from the battery regulations, you've got the waste shipment regulation. So to move products, electronic products that you've removed from e-waste recycling from Lithuania, you basically have to drive through Poland to get to Germany, where most of the market is. So you have to have a trans-frontier shipment permit. So if you were to go from Lithuania to Poland only, the Polish government would charge you 3,000 euros. If you go from Lithuania to Germany, you have to drive through Poland. So they become a transit country, and they also charge 3,000 euros just to process it. So I work on a UN group, and we're rewriting the guidance for prior informed consent. And we're trying to say transit countries should only impact it if it comes off a truck or off a ship, because they were originally, the PIC legislation was originally written in the 1980s to prevent hazardous waste being dumped in Africa and other countries. And shipping and transport has changed dramatically. So you used to have a small ship that would go from, say, you know, Germany to Kenya, and it would dock at Rotterdam, different country. And so that was a transit country, and it was taken off that ship and put on another ship, a bigger ship, in order to transit on to Kenya. Nowadays, it's one ship, and you've got shipping containers, and those containers do not get off the ship until the final point. So there's no environmental risk to those countries in between. So that's something that we're working on at the UN level. And I can see why it took 12 years to get to the climate accord change, because it's a very slow process. But, you know, we're working there. But I might have retired by then, so, but we'll see.
I know from the US side, a number of the companies are looking at Germany and Poland as their European expansions.
Yeah, yeah. In Germany, it's hard though, because it's federal. So you have potentially different obligations and pieces of compliance that you have to meet in different regions in Germany. So again, that's something to think about. There was a lady over there.
Time for one more question.
Thanks. Hi, Jacqueline here. I was just curious about this omnibus package. Will that include life cycle assessment or the product environmental footprint rules, anything like that?
Yes, no, who knows? But that's the problem. So there was a leak, which Raphael might talk about in a moment, a quick brief leak. But it didn't really give a lot of details. It gave some positive points. But because of the way the European Commission is moving and their plans for the future, we don't actually know. And it might be about reducing environmental obligations completely, or certainly in terms of licensing. So we don't actually know yet. But watch this space today.
Thank you.
If I hear of where it's listed, I'll tell someone.
Let's thank our speaker again.
Sorry?
So let's thank our speaker again. Julianne.
Julianne.
Thank you. All right, so up next we have Raphael Basciano. Good. With recently joined the FEAD. FIAD. Just this month, right? Last year, okay. So a whole year, we're focused on WEE, battery, hazard stuff, all the dangerous, nasty stuff, right? Right. And before that, really started his career in the consulting industry with Deloitte, working on sustainability, etc. And today, we're going to see really how can we use the EU framework to build better operations. So, over to you, Raphael.
This one, not that one.
Okay. Like this. Yeah. Good afternoon, everyone. Thank you very much for. I'm very happy to be here today. I will try not to repeat all the things that have been said already, and with a maybe a little bit more academic presentation on what is the EU framework for the batteries. So, but first, who is FEAD? So, FEAD is the European Waste Management Association. We represent like 20 national associations across Europe. And yeah, so we represent like a private waste management companies dealing with waste, like all kind of waste, all typology of waste, and along the whole value chain from like collection, separation, all kind of recycling and treatment, and also final treatment, so incineration and landfill. Basically, we cover around 60% of the market for the household hazardous waste, and around 75% for the industrial waste. So yeah, our objective, like as a European association, is to share the good practices and like to defend the interests of our members and shape like a better policy for the private waste sector. And towards, shifts toward the circular economy. So yeah, just like when you, we heard a lot about it this morning, but this is about like the electric vehicle battery production in Europe. This is like figures from the International Energy Agency. As we can see, the supply chain is like very concentrated in a few countries, if not to say like very concentrated in China for a big part of the value chain. Mining is quite around the world, but when you look at material processing, cell components, and battery cells, Europe is basically not really there. A little bit for the battery cells manufacturing, but it's not much. So yeah, more in the figures, like it's only 5% for the manufacturing capacity, and there is a really lack of capacity when you are talking about the cathode and anode materials. And the goal, like of course, and by developing recycling, is also to avoid that Europe is just like an assembly hub, so just having the last step of the value chain, and not really like working on the previous part of the value chain. I'm not sure I have to present you how works the EV battery production, but just I wanted to zoom in on some parts of the value chain. These parts on the battery manufacturing, as you can see, this is like the capacities from 2023 to 2035 with like the expected capacities, and like we can see that barely like the capacity of battery production should meet the demand for Europe at least. There is a lot of announced gigafactories that should cover this demand, but it needs a quick acceleration of production. I mean of construction. Sorry, of this capacity. When you look at the production of active materials like anode and cathode, that's where there is the biggest issue in the value chain. Because like the capacity are today not enough, and the announced capacity is not enough, especially for the anode materials, and it won't meet the demand. But so yeah, like it's a bit the question of the chicken and the egg that we have since this morning. Nonetheless, the recycling capacity in Europe is getting organized. But as you can see, it's like not an easy value chain again. Like inside only the recycling, we have a lot of different steps. That's basically like needs to be scaled up today to reach the needed capacity for the EU. So yeah, when we look at the challenges of the sector, is like first there is like a market instability. This is mainly due because like the batteries, as we said since this morning, like are evolving very fast. There are like new technologies arriving in Europe. It's a constant change, so it's really hard to invest like in recycling plants when you don't know like what will be the market in few years. There are like some eco design issues also. It has been also shared this morning, but like there is like a question of like how these new technologies will be dealt with. Can they really be recycled? Is there an economic value for these technologies that are arriving on the market, and that are of course like questioning like the stability of that is needed for the investment. There is an increased competition from the countries outside of EU that are playing in the more favorable environments. Lower like a cost for the labor and for the energy, and plus they have like some important subsidies that maybe we don't have yet here in Europe. And there is also like insufficient like public support for recycling. There is for the gigafactories, but we don't see it yet for the recycling plants, and that's why also like 44% of the recycling capacity is currently on hold, or maybe like uncertainly to go ahead. And then, like as we could see on the previous schemes, like there are missing segments in the electrical vehicle battery recycling value chain. All the refining parts that we heard about this morning, but also like what happens right after the black mass. We have like many recyclers that are able to do black mass, but we don't have a lot that are here for the next steps. And it brings us to the last issue, which is like the leakage of raw materials. So we produce black mass in Europe, but a lot of them are going out of EU, and we need to keep them inside EU to be able to build the value chain. So there is like a huge patchwork of legislation, acts, communication that have been released for the batteries. It started in 2018 with, I mean, even before, but like the notable ones with the Juncker Commission, with Europe on the Move. There was actually an annex for the like entitled the strategic action plan for batteries. In 2023, the Green Deal with like the batteries that are targeted by the Green Deal. 2024, the Net Zero Industrial Act, which aims at streamlining the process for some green technologies. Then the Critical Raw Material Act still in 2024. End of 2024, the Draghi report on EU competitiveness. That is like underlining that we need like single markets for the circular economy, and that has like a lot of points on the batteries itself. And it continues on and on with also like the LETA report that is also about the single market. And we have like so many legislations, communication acts about the battery recycling. But of course, like the most like important one and on which I will emphasize today is like the new battery regulation that is from 2023. So it's the first time actually in the new battery regulation that we see appearing a separate definition for electric vehicle batteries, because like it was like a growing part of the market of batteries, and that's why like they put up this definition, but they put also there like a set of like market pools, and also but like the ambitions like for the battery recycling, but at the same time also like rules like to like reach this ambition. Among the market pools, I think like the most interesting ones for the EV recyclers is the mandatory recycled content. We heard about this this morning, but again, we are talking about a complicated value chain, very complex, and today they are still setting the rules on how do we compute actually this recycled content. They are like setting some rules about the traceability and the chain of custody to understand like how do you follow the recycled content along the value chain. The calculation rules itself are getting set, and also of course the verification rules, like how the third party will assess what is in the battery, I mean in terms of recycled content. So these targets are like, as I said, like we are waiting for the delegated act that is expected in August 2026. There is currently a JRC study that's like the report is expected in actually in 3 or 4 months in Q2 2025, and it will set the rules like for these targets, which are like, and it's important to note that for cobalt, lithium, and nickel, it's battery manufacturing waste and post-consumer waste that can be used to meet the recycled contents. For the lead, it's only like a post-consumer waste. So that's actually a very important detail. Also still a market pool and an important one, and I think it has been mentioned just earlier, but like the carbon footprints of the batteries. Again, like it's a complicated topic. You have here like a few equations, but it represents like maybe like not even a tenth of the proposal of the Commission on how to compute the carbon footprints for the batteries. This carbon footprint of batteries like will be put in place in 3 steps. The first time is like mandatory carbon footprint declaration that was supposed to be by February 2025. It will be more likely by February 2026 because like the delegated act is not even there yet to know how to compute this carbon footprint. After that, they will implement some class of carbon footprints, class of performance, that will be used then in the third part, and this should be like in August 2026 to have like a maximum like a carbon footprint for battery to be put on the market. So this is like actually an important part because like on top of the recycled content, this will put in the balance the question of like where the battery are recycled and like so like produced locally basically, and also like push even more like the question of the recycled contents. So this like again should be like a market pool for the EV recyclers, at least like to be able like to market, I mean like to have them recycled materials like uptaked in new batteries. The other part is about like the due diligence, but this is more like for the producers that will have to like check that the value chain is clean basically, and the environmental and human risks point of view. And to prioritize in the end high standards production. So this again, like, but less than the carbon footprint, but like should help also to prioritize batteries that are produced in Europe in like let's say clean with high standards. And the last market pool, I mean, like that is quite important. On the left, what you can see is actually the public procurement percentage in Europe. We can see it's around like 16% of the GDP. So the public procurement is like quite a big share of like the potential buyers of batteries, but of everything. And they are like starting using it really as a lever to push for green, I mean, to push for the European products that are like more green by essence most of the time. So the green public procurement, same, it will come like most probably by 2028, but it will have like some criteria based on the carbon footprint, the recycled content, and the durability for the like the public entities to do their procurement. So this will help again like to find a market for the batteries that are produced more locally, or at least like that are like more compliant in terms of sustainability. So this is like an important like also chunk, let's say, of the battery regulation. I won't go much in detail on the digital product passport. I know that someone will talk about it later, and it has been addressed in a little bit. But like what we can expect, so from the digital product passport that should apply by February 2027 for the EV batteries. Two things, like what we can expect maybe is like, of course, like higher transparency and traceability, and like we could maybe hope. That's not sure, but that maybe the buyers like would pay attention to what is in this battery passport, and like pay like a green premium, like pay a bit more to have like batteries that are more like locally made or like more sustainable, even though it's not really the trend that we see today in the consumer consumption. And the other point is like it can help in the recycling of batteries. Because like on EV batteries, we're talking about like big batteries, like not in other products that will have like the product passports, where it will be like very much more complicated to use the passport in the recycling facilities. There we're talking about big batteries, so like maybe it can help also in like identifying like the chemistry of the battery, easier dismantling, and then like maybe be more efficient in the recycling. This quite quickly, but just like the battery passports, I mean, sorry, the battery regulation also introduced like Indian, like what we call the definition of battery recycling, because like battery recycling, if we don't set like some efficiency and material like recovery targets, you can say I send my battery to the recyclers, this is recycling. No, like you need to make sure that like the recycling operation is efficient, and that's what like these targets are trying to set. So granted efficiency, also like of course avoid like the cherry picking, just get like the materials that are interesting and throw the rest, even though like of course it's adding like more like requirements to the recyclers. It's important to have in mind that these targets are also playing for the batteries that are recycled like through the, I mean, when the value chain is going outside of Europe, the recyclers will have to prove still that they comply with these the recycling targets. The EPR system has been presented quickly, and same, I won't go too much in details, but like it's based on the Waste Framework Directive, Article 8A, which is above and down, like you have actually like the how it's written in the battery regulation is like pretty much the same, but like yeah, the EPR is there like to cover like for the cost of separate collection, transport and treatments, and this is mandatory for the batteries. And also what will be mandatory is the eco-modulation, and this is actually could be an important part again of the EPR, because like through eco-modulation you can also encourage eco-design, which is extremely important like to ensure like the circularity of the batteries, but also like you can encourage the recycled contents. So it's again a way to push for batteries that are more circular. Important point that Julian mentioned earlier, but like how we keep the materials inside the EU, and we are talking about the black mass here. This was not really in the battery regulation, it was foreseen in the recital that the list of waste for battery waste should be updated. So they like introduced a lot of new list of codes for the battery waste, and including actually the codes for the intermediate materials, so basically the black mass. Before there was no really codes for that, and they're all hazardous now. And this is important to note because like according to the waste shipment regulation, you cannot ship waste that are hazardous outside of to non-OECD countries. So it will reduce much more in the end like the possibility to export black mass to other countries. This is like not out yet. Like, so this was the draft that I'm presenting you, but it's supposed to be out today or next week, the new list of codes. And so like what was foreseen in the initial drafts was 18-month transition period. So like these new codes will apply within 18 months after the publication of the new draft. This is more about like what's next. As Julian said today, like they were presenting, I think they should be presenting right now, maybe the Clean Industrial Act, which sets like the priorities for the new mandates in the next 5 years. And there are actually a lot of interesting things in this Clean Industrial Act. This is like again like from the leak that was shared. It was last week, I think. But like in this Clean Industrial Act, they aim for Europe to be like the leader on a circular economy by 2030, and they are looking at an interesting KPI that is the circular material use rate, which they aim to double from 12% to 24% by 2030. So there is really a willing to move to circular economy and to encourage also the use of recycled material in new products. And that's what will be also dealt with in the Circular Economy Act. So this will be announced in the Clean Industrial Deal, but will be published actually in 2026. And in this Circular Economy Act, they might actually look at limit the exports of critical raw materials, and maybe put in place like export fees. So this is like again like it depends what they will say today, and use these export fees to allocate them to finance recycling capacity. So they are really thinking about like new ways to finance the like circular economy, and at the same time like boost like let's say like uptake the circular economy. I mean, ramp up the circular economy, and for this also like there will be like some circular hubs like to like look for some like economy of scales for recycling. Very quickly, like it's my last slide, but yeah, so what do we need? And like that's what you see is like we need like the rollout of the legislation. The pieces of the puzzle are in place, are getting in place, but they are not like completely like implemented. So like we need the certainty that the secondary legislation of the new battery regulation will bring. We need also to facilitate the investments, and that's what the CRM Act and the Net Zero Industry Act are trying to do. The public support that we can expect maybe with the Clean Industrial Act, and again like some basics about like encourage eco designs, and the last one would be like a level playing field for like European companies versus like other players outside of EU.
All right, thank you, Raphael. Have any questions? One over here.
Thank you. It's a very good presentation. I have a questions about the new waste list that is like gonna enter into force very soon. Because like basically now it said that it's hazardous waste and cannot be like shipped to OECD country. But what's happening at the moment is like still is possible because you can transfer in OECD country and then ship it back to non-OECD, for example, like China. And what's your opinion on like this with this, and then is there any sort of further consideration on to setting more requirements on the shipment?
So actually the waste shipment regulation, so the new waste shipment regulation that was like published last year is especially looking at this like okay, you ship outside and like to OECD countries, and it's just like a transfer place. This is not allowed. Like now you need like to like audit until like the last facility. So like therefore it won't be possible to ship like to a non-OECD country because of this new regulation where you have to like look until the last facility where it's actually treated, and if it's not in OECD, I mean it's not allowed.
Thank you.
We have time for one more question. A couple over there.
we have spoken quite often about hazardous classification of black mass. Is it for all kind of batteries? Because I
Yes.
know that, for example, LFP currently, as we have a certificate by DEKRA, that it's not classified hazardous.
Yeah, so like they started by reviewing like the hazardousness of all batteries, and they came to the conclusion that all batteries are hazardous of any kind, and therefore like the black mass, since it's coming from like these batteries, is also classified as hazardous. So like all battery waste basically are considered as hazardous, like based on this draft. And I mean, we don't expect any change. There were already like two, there was like a GRC study and then like two sets of consultation. And these two consultations, like they didn't change anything regarding the hazardousness. So LFP batteries, I mean, black mass will be considered as hazardous. And so there will be 18 months to conform your facility with the permits needed to treat hazardous waste. I mean, 18 months based on the draft, but like we're asking for 24.
I'm squeezing one last question.
Yeah, Brent Musket from Circonomics. I would like to know your opinion about the battery regulations regarding the elements that are included within the recover material rate. Specifically, that iron phosphate is not included. So what is your opinion about it? Should it be included in the future or?
Yeah, so actually they are like setting the rules about it. There was like a consultation last year in November where like they were presenting like what will be the rules for the computation, and for the phosphate, for example, they were like letting it to the recyclers to choose if it should be or not considered in the recycling efficiency. To us, it should. I mean, it should be in the like stated in the regulation, like clearly, like is it or not. Like it shouldn't be left to the recycler. Like I decide if like I include the phosphate, for example, in the recycling efficiency. So they are like setting the rules. There are like different like point of views around the table. The point of views we had like in our members were like more like it's better to have a clear regulation that gives the same calculation rules to everyone, and to include actually the phosphate in it, like to make sure that we are developing the capacities later on, like to recycle these batteries.
All right, let's thank our speaker again. We're now going to move on to our first panel around all things LFP.
Sorry.
Yeah, we're good. So our first panel is going to be around all things LFP, with Arn going to be moderating, and he will take charge of introducing the panelists once we have all of our seating available. So we got one mic here. We should be getting, I think, two more. Yeah. Correct. Yeah, she has the microphones there. And
will you reset the timer, or do we only have? Okay, 7 minutes would be quite short for panel with 4 panelists. Well, welcome to you. So now we will try to do a little bit different setup to the case studies with a panel and discussing some topics. And focus is LFP recycling and the involving LFP cell chemistry in Europe. And to start with, because we have heard quite a lot this morning, I would ask every one of you to have one statement what the audience should take with them when they leave this forum tomorrow morning. Jesse, you were not on stage so far, but you will have your spot tomorrow, so I won't introduce you. All the others are already well known. Would you like to start with With one statement, please.
Hi, everyone. I'm Jessie from Romotion. Yeah, so today we've heard a lot of fantastic presentations yet, and my presentation is going to be tomorrow. But today, for the LP from Romotion's doing, because we are tracking the global recycling market, and I would like to just highlight one point from the supply and demand side. Talking about LFP, when we talk about the LFP battery from the battery demand, so far we can see the market share of LFP is keeping increasing at global wise, and also in Europe as well. We expect that's at 25% is going to be LFP available, and by 2030. But looking at supply, we haven't seen much. While few recyclers claim they have this capability, currently mostly still concentrating in China, and definitely there's a market, there's a demand here in Europe for LFP recycling. That's a really sharp conclusion.
Okay, thank you. Tom, from a regulatory perspective, one statement or 1.5?
I can start off with one. With any kind of new battery chemistry, so I understand that LFP could dramatically increase the life of a battery, but this is all going to happen sort of into the future, that electric vehicles might or might not be taken up, and that there might be big breakthroughs in the development of battery technology, battery chemistry. So from an EPR point of view, it is very important that legislation has the appropriate flexibility to deal with that, and also with the pots of money that might be in place for it. So if suddenly there is a breakthrough in battery technology and recycling becomes much easier, or they last longer, then the EPR system that built up to it, obviously, suddenly is in a very different situation. So statement or hope number one is regulatory flexibility, and those are not really two words that go together very well, but I think a lot will happen that will have a huge effect on regulations, and we're trying to regulate something that is extremely dynamic. So that means regulation needs to also have a level of dynamic.
Okay, thank you. Remy, if I would call you as a consultant, what advice is your advice to your clients if they ask for one?
Okay, if we want to succeed the Green Deal and this energy transition, of course, batteries are a critical element, but one battery technology is not enough. Europe has focused so far on NMC, almost 100%, because it's a technology with high performance, with a lot of energy density, but it's more expensive, and it has some safety issues. And now to accelerate, we need to have cheaper technologies and safer ones, and LFP is a very good candidate. So you need to think about the market being led not by one battery technology anymore. You will have a portfolio of battery technologies to cover all the various needs. And it's true for automotive, but it's true for energy storage system and for truck as well. And LFP has also a very important advantage. It's higher cyclability, so longer lifetime duration.
Okay, thank you. To close the first round, Johan, you presented your company as a Dutch company. If you look a little bit beyond the borders, what would be your perspective as a recycler or collector in Europe? Is one statement.
Yes. Of course, I had some time to think about it, and of course, I mean, we knew already, of course, that the questions that would come on table. But first of all, I want to make a statement, and the statement is that there is no level playing field in Europe. We are talking about level playing field, Europe to other part of the world, but within the EU there is no level playing field, because the discussion by the previous speaker about black mass and the questions from the audience, if black mass could be transported hazardous or no hazardous waste. If it is no hazardous waste or even a product like some parts in Germany or France or other part of Europe are doing, then it can be transported or exported to China because it's a product. And this is the biggest problem. First of all, there is no level playing field in the recycling market. And secondly, LFP is becoming bigger and bigger. And we as a collector, on behalf of the Dutch schemes, already see that the bigger volumes of LFP are coming back. And there is no solution in Europe whatsoever for the moment, or nobody wants it. And the problem is that in China, they pay for it. And in Europe, we have to pay for the recycling a lot. And in China, you get paid for LFP. So there is a big issue. And I think in Brussels, they should do their work.
Okay. Thanks for your statement in the first round. You just mentioned we aligned a little bit about the questions before. So why is LFP cell chemistry becoming more and more relevant for Europe, especially for the recycling? And in which industries do you see the best scalability? So automotive, is this storage systems? Is it consumers, for example? And I think this time we start with Remy.
So if we look at the different markets and we have forecasted the market share of technology in Europe, LFP and LMFP should take 40% of market share by the end of this decade. Why? Because if we want to offer to the consumer affordable EVs, we need to use LFP for the segment A, B, and C, so small and mid-size car. Otherwise, they will still have a big gap between EVs and ICE vehicles. For energy storage system, which is the fastest growing market today and becoming the second market, not only in China, but elsewhere in the world, the current market share of LFP is almost 100%. And we think it will decrease because sodium ion will take a share as well, maybe 1/3 of the market. So we'll have 2/3, 1/3. And for the truck industry, now they have to electrify as well because they have to meet the new emission regulation. Initially, players went to NMC, and now they are more and more shifting, some of them 100% to LFP because it's safer and you have a much longer lifetime.
Okay, thank you. And how does the recycling industry currently handle LFP? So do they proceed it just LFP or do they mix it? Do you have any experience on that, Johan?
Yes. First of all, I agree with my colleague about the market and the energy storage systems. And we see also telecom is almost uniquely LFP coming into the market. So yes. Recycling-wise, we in the Netherlands, we are capable that we can sort in the chemistries already. So we ship dedicated NMC and NCA, LFP and other chemistries, also critical for non-critical and pouch from non-pouch. We ship to recyclers, and because there are contracts with the recyclers in Europe where there are, let's say, gate fees based on the material you're shipping. So yes, we sort LFP, and it is in our case, or it must be since 2025 differently because I left last December. But we do not mix lithium batteries.
And could you just state why? Because we talked about recycling capacities at all. So if we have to have dedicated recycling capacities per cell chemistry, that's not favorable, I think, for business.
The point is that I'm not going to mention any names. We all know the names from the lithium recyclers, but they work mostly batch-wise, and we ship to one recycler different types of batteries. So there are different types of gate fees for the EPR systems.
Okay.
So there's a contract for Foundation Open or ARN with recyclers somewhere in Europe for this kind of type and this kind of type and this kind of type. And we can sort. And of course, it's manually, it's visually. And if we can't read labels, then we have to trust on the production of the producer what kind of battery it is.
Okay.
One other important aspect for recycler, if you want to maximize efficiency, you need to have a dedicated process to one chemistry, because the process looks similar, pyro, hydro, but you tune them to the specific chemistry to maximize the recycled metals you will collect at the end of the process. And in Europe, people were reluctant to choose LFP because they said we will have to recycle it and we will get less value than NMC because there is no nickel, no cobalt.
Thank you. We spoke about regulation flexibility before, Tom. Do you think that the existing regulation is enough, or do we need more regulation, local content, or other criteria just to secure Europe's business, or will we be dependent on China, especially on LFP for the next years?
In terms of regulation, so one point I wanted to make first, what Remy said in his first point, longer lifetime of it. So it's very important for, again, from an EPR point of view, I spoke in my presentation earlier about the new JRC proposal about an equation for available for collection. I think we, over the years or decades, familiarized the Commission with the concept that those things last 8 to 12 years. If they suddenly last 20 years, it needs to be very important that it is reflected in any equation for this available for collection. Otherwise, again, we would end up being in a situation where we have to collect more than is physically possible. It's not just getting our hands on it. They're just not ready to come back yet. So that is one important point. Other than that, yes, of course. I mean, most of the efforts now are very much about securing some kind of role in the battery value chain for Europe compared to China. Yes, it's going to be extremely tricky. If there's any specific regulation needed for that, I'm not entirely sure, but yes, big issue.
Okay, thank you. Jesse, do you see, or which kind of developments do you see, for example, in literature or in scientific work, especially outside Europe? Because we have heard about some insights before from London, other things.
For every outside Europe, it's like currently, because from legislation side, we haven't seen much specifically focused on LFP. It's more general under the battery recycling generally. And for funding, we can see like in Europe, we haven't seen much on LFP either. But in the US, we can see some subsidy for LFP recycling, for example, lithium industry, and they just got the funding from the DOE. And in terms of technology, even though in China now it's dominated by hydro methodology, but still in outside China, we see like in Europe or in other areas, for example, North America, we see some direct recycling, for example, some innovative technology try to solve like compare with the traditional hydro methodology, but mainly up from the startup. And then from the market side, obviously, as I just mentioned, the feedstock is limited outside China at the moment. But in the long term, when we think about that, it's going to be a huge jump as more EV get more adopted with the LFP and ESS, for example. As we can see now, mostly over 95% ES batteries are like newly installed LFP. And this will be a great demand there to for recyclers to think about, and then also for legislation compliance when we're targeting at the full circular economy.
Okay, thank you. And do you think that will help the European business, or will that increase the gap from Europe to China or to the other areas?
Well, it depends. Like, for example, because like from the risk and then from the self-supply in Europe, definitely in Europe, and then definitely needs to be more players get involved in this industry to help like to have these, let's say, materials self-supply, and then but it's more support need to be given from all parties, sectors in the supply chain. For example, from the government side, from the funding side, and also from like labor, education, and then everything. So it's that everyone need to be get involved in to help.
Okay, thank you. Before we go in specific questions or questions by the audience, just a short ramp up. Did you hear this morning or now in the statement anything new? Do you want to confirm anything? Do you want to emphasize anything? Let's start on my right side, Tom.
Yes, the point about price for recycling, so that for LFP, we heard a few times that China is quite happy to do it. There's no business case in Europe. So that certainly means that there's even more need for investment in Europe in building up capacities for recycling and making sure it's competitive in some way here too. So what I think Europe is slowly waking up to, thanks to the Draghi report and all of that, and what's happening in the US, that we really have to invest, or Europe as one, not member states here and there in a fragmented way, but Europe as in the EU has to invest on a much, much larger scale than ever thought possible. We will see if it is possible, but that to me, I think just reinforced again.
Thank you. Would you pass the micro over to Remy, please?
Yeah, maybe one additional challenge in Europe and maybe elsewhere. I think it will be more and more difficult for players to play in this market, because not only the regulation is becoming more and more strict, and Europe is a very good example, but commercial restrictions are getting tighter. And we see commercial war between US and China. We have started with China in Europe as well. And we see that China is answering, for example, to a European new tariff on EVs by restricting export of raw materials. And China is by far dominating the battery industry for more than a decade. They master the full value chain, and they have the ability to stop the battery industry in Europe and in US. They just have to have to stop exporting graphite, for example. They control 98% or something like that. And so this will be a challenge. And so, as it was said this morning, we need to be open to collaborate between players to find smart solution, because we won't be able to do it alone, I think.
Jesse?
Yeah, I completely agree. Because like for LFP, still now it's just from the whole supply chain and from the technology, the funding. It's like I think it's like still at a pretty early stage here in Europe, but everything's open, like collaboration and funding legislation side. And then it's really important, I think, to think about the collaboration and to like kind of get together, and then like from every single sector of the supply chain. When you talk about recycling, it's not just recycling itself. Like for a recycler, when they produce the product and what the product they're going to sell to, they need to think about this. So it's not just one part of it, it's the whole supply chain that we need to talk about, we need to pay attention to.
Thank you. Johan?
Yes, I have a nice statement from a colleague, recycler located in Rotterdam, which made a statement in his presentation last year in The Hague. And he said that if you look at Europe, not especially the Netherlands, but if you look at Europe, then we are PhD in regulations and permits and everything. But if you look at where we stand, we are still in kindergarten. And this is the big gap we have, and we have to face this. And if we look at how far China is ahead, it's not because China is bright and much more clever than the European Commission. No, it's that they have made a decision for a decade. We go that way, and they go full speed that way. In Brussels, we have 7 countries that all should do the PP on it and then say, yes, we go for it, but it will never come. So I agree with the previous speakers and colleagues here that we should move very quickly. Otherwise, we should ship LFP to China.
Taking your picture and just one fast answer, yes or no, please. So you said we are currently in the kindergarten and going for the PhD. So assuming or imagine in 20 years, will there be a profitable recycling business for LFP in Europe done by European companies? Yes or no?
No.
Hopefully, yes.
Yeah.
I hope also yes, but realistic? No.
If we are optimistic, yes, thanks to new technologies.
Not really in a position to say, but hope always dies last.
Okay. First of all, thanks. Time for the audience to ask questions. Otherwise, I will continue asking questions. Could you please activate the one micro over there?
Take one of these.
You have to answer, not me.
Hello, Dorosian Harak from MakeAware. When it comes to recycling LFP, we all know that there is no much value as the NMC. So are you hearing in the European market about gate fees on the LFP? So to encourage the recyclers to start making progress on these LFP recycling technologies?
Is that a question specific to one of the panelists or to the group?
To the group, especially to the market analysts.
Jesse or Amy, would you like to answer?
No, clearly, recycling LFP is not profitable today. The main reason is that lithium prices are depressed. By the way, nickel and cobalt has decreased a lot recently as well. China, it's at break-even at best, and a share of players are not profitable either. But some players are hoping, thanks to process improvement of new technologies such as direct recycling, to be able to be more efficient and to have a profitable business. But it's not a given for sure.
Yeah, so it's like we rarely hear about the LFP, like for example, the gate fee, because as I mentioned, the market is not yet here. Like currently, when we talk about like scrap feedstock, LFP here mainly will be like randomly from ESS or from like EVs. Let's say like those record EV, but it's like a really small volume at the moment. So we haven't heard much about like, because in China it's like large volume here there, and then it's already more mature there with these recyclers together with like feedstock suppliers. Yeah.
Yeah, for LFP recycling to reach break even, we have made an estimate, and we need to have a lithium price back to $20,000 per ton. Lower than that.
Yes. To add to my statement and to nuance a little bit, I agree with the first speaker of this morning. It's already a long day, but the first speaker, he said you should have circles of, he was talking about 250 kilometers. I would say today it's 400, and we will come to 200 if the electric mobility is increasing as well. So you have the collection, you have the discharging, you have the shredding, and everything in your region, and then the transport cost will drop, and the transport to recyclers would be much cheaper than what we are facing. And I'll come to my point, back to my point. What we are facing is that still possible within the EU that the black mass produced, if it is LFP or NMC or whatsoever, there are several regions in certain countries that still are not, classify this as product, and it can go to China. So, up to my opinion, I have no data. So, up to my opinion, there is a certain amount of black mass of LFP already going to China anyway.
Okay, thank you. Any more questions? If not, then I would take the chance to have a statement as well. You spoke about the business being profitable, potentially from a recycler perspective. I'm from a truck OEM, and as recycling is mandatory because landfilling is forbidden, for us it will be profitable because either we pay a fee for the recycler that he recycles, or we won't have anyone doing the business for us. So there will be a market and we have to pay for it. So that just as an additional statement, potentially for discussion or networking later. It's the same with household waste. In Germany, you don't have to pay for paper, you don't have to pay for glass because it's profitable. But for the daily waste, we have to pay a fee to make it profitable for the recycler. So at the end, the recycler will always be profitable. The question is who takes the business? Yeah.
Yes, you're completely right. We have to collect, we have to fulfill the European legislation, we have to do recycled content, we have to do everything, and it will be done. And we have a business model, but I think the discussion, and nobody wants to put it on the table, but I would say, if you look at lithium-ion battery recycling in general, and maybe LFP specific, then we should not look global, not European-wise, but we should look global-wise. Maybe Europe is not the right place for the hydrometallurgical processes, but we should do it already in the countries where this is developed, and we should more cooperate in this way instead of trying to close the borders for let's say our own production of batteries. But I know this is tricky what I'm saying, but if you look at the market today, we are talking to a lot of Asian people, and they do not understand why they can't buy the black mass from the Netherlands, for example.
We have been talking about traditional market participants today, recyclers, truck OEM, battery cell manufacturers, or whatever. Do you see in the future any new players entering the market? Because 20 years ago, no one has seen a mobile or no one has seen a digital camera. The existing players, Nokia, are not there anymore, Kodak, same. So what is your opinion on that? Does it continue as we know, or is there anything in the scene at the horizon?
In Europe and in North America, the recycler were most of the time traditional players coming from mining and metallurgy, because the pyro technology was dominant. Now, of course, hydro is developing very strongly as well. And if you look at the maps we have shared this morning quite a few times, you see that you have big companies, but you have also a lot of startups. In Europe, it's same story in North America. By the way, you have some new companies entering Europe as well, Redwood, Li-Cycle, and so on. The big question is whether they will be able to pass the Death Valley, to have enough funding to wait for enough market demand and to have enough feedstock to recycle. That's the big issue. So the big players like Eramet, Orano, who have made their project on pause mode, they can wait for a few years because they are big companies. The startup, it's another story. And it's another story for the funding as well, because when you are going to look for 100 million, 200 million to fund your future capex, the investor will look at the market and will question the viability of the business. So it will be very challenging.
The one new thing I think we will see, and we're starting to see it already, is that, and that could be either a standalone new branch developing or different types of recyclers. All recyclers we've seen so far are recycling. And when that started, that was already a huge step. We're not putting it in landfill, we are recycling it. But now we're getting to the point, and I alluded to that earlier, where recycling is still something we should avoid. I mean, it's a lot better than landfill, but before we come to recycling, we should think about repairing, refurbishing, repurposing, second life, and all of that, which is a huge part of the EU battery regulation as well. So not focused on LFP, but generally batteries. I think an industry that does that, the second life, or a recycler that recycles as a last resort, and before that has loads of different business models for whatever kind of second life, that I would say is the new one.
Probably one point from me is like, for a new technology, we kind of see more, it's like from startups, for example, generated from university labs. And they are looking for to commercialize their technology from the lab to the commercial side. But it's also will take long process as it's like from pilot. It's easy from lab to pilot, but it will be much more difficult from pilot to commercialize. And also we started to see OEMs getting involved in recycling, for example, like Mercedes, BMW, because they are trying to build a closed internal supply chain for the batteries value chain. And then I think it will be more OEMs in China, where they see more, and in Europe started to see, in America probably. Yeah, but there's also some new players in the market, I think.
Yeah, what should I say?
If you don't want to say anything, I would have one more question. So-
I can now very quickly then. We have limited storage. We have 160 tons of capacity. We have 450 tons of mixed batteries with some lithium in it. But at a certain moment, you're full. And our experience is, unfortunately, that we already had big players, not mentioning any names, but European, American, big players that had their warehouses full of stock, overloaded, got a check from the competent authorities, and they had to empty their storage because they're way over their permit limit of weight allowed to store. So yes, people are storing and waiting and hoping that it can be used for energy storage systems, but the demand is not that high, and therefore there is a lot of pressure already on the recycling market. And I will come back to the discussion that as long as LFP in Europe is not profitable, we are in the chicken and the egg situation. Unfortunately, if we look at from the perspective of collection and storage, waiting for shipment to the final recycling.
Okay. Thank you. To end it up, only 6 minutes left. Let's do some kind of second forecast and outlook. You were positive or you were optimistic about the time horizon of 20 years. So if we would have this event in 5 years, which topics we would discuss or which would be shared would be different, which would be still the same, or won't we have that event anymore because there's no business? You were optimistic. Johan, do you want to start? And then we end up here.
Yeah, there are a lot of conferences in Europe. I am in one attending now for the 30th time in September in Valencia. So we are talking about battery recycling since 1994. And yes, in the beginning, in the founding years, we spoke about alkaline, and then the evaluation came, and now we're talking only about lithium and the things around lithium. I think the market is still positive for companies like Van Papersale and others, because and now we're coming to the positive point. We have to go into e-mobility. We cannot dig into the ground for the next 50 years. So we have to move forward. We have to increase recycling. We have to increase processes. The only thing I'm saying is be a little bit liberal on where are the borders. What can you cross and what you can't cross? But I see a good future. Finally, I will see a good future for this market. Absolutely.
Thank you.
Yeah, as like if just talk about generally battery recycling, it's been decades. So definitely FP, the hurdles is the challenges we're talking about at the moment. I believe it will be like, for example, in 5 years, it will be solved at some point. For example, from the legislation, like people are talking about, and then the government body are making decision how to guide the industry going forward. And in 5 years, I believe that definitely from the legislation side, it will be much more step moving forward. And as a pivotal driven motivation to push the industry moving, definitely, and companies, recyclers companies, or like every players in the industry chain, they will move and they will move forward from each funding or from the technology or from the company business scope. And yeah, but I'm quite optimistic.
Thanks, Jesse.
Maybe a nice story. I started to work in the battery industry in '98, so quite a few years ago. And my first project was a due diligence on a key European player. I will not mention the name. And they had just decided in '98 to exit the automotive business, saying there is no future for battery in the automotive industry. So,
okay.
And maybe to answer your initial question, in 5 years from now, I think a nice topic to address in such a conference, because we will be in 2030, 1 year before the target to reincorporate recycled metals. And I would invite cell makers to tell us how successful they are to reincorporate recycled metals to meet the European targets.
Thanks, Jamie.
I would say the other way around. I would say one topic we're not going to talk about in 5 years. So being incredibly positive here now. So within these 5 years, there will have happened this large-scale investment in building up a lot of stuff around the, not just recycling, around the whole battery value chain in Europe, which means that in 5 years' time, we are quite pleased with what we've achieved, and we are able to do much more in Europe. And the topic we're not going to talk about anymore, shipping, recycling halfway around the world, just because there they can do it more cheaply, or because we don't have the capacities. But we will do all of that here in Europe, not just in terms of competitiveness, but also because it's crazy. The starting point for recycling and all of that is the environment, sustainability. So shipping stuff halfway around the world is insane. And in 5 years, we realize it's insane, and we're not doing it anymore, and we're not talking about it.
Okay, thanks a lot. As far as I know the agenda, I think there will be a networking break. So hopefully we, or the panelists, could give you some more insights, some more statements, some more thoughts for networking, for collaboration, for discussions. That was the intention for the panel. Thanks for listening.
Thank you, everyone. We will reconvene back here at 4:45. Okay, everyone, we're gonna get started with the next session. And we do have one cancellation for this next session. The 5 o'clock presentation is not going to occur. So we're just going to skip it ahead, and Dr. Gerald will be one taking that place at 5 o'clock. Next up, we have Uwe Gall with Siemens, where he is the GM and worker management of the chemical industry. He's an experienced chemical engineer, mainly focused in the chemicals industry. Decade plus working on those kind of projects with EPC firms, and then eventually decided to join Siemens, also in that chemicals industry now focused on automation and logistics. So Uwe, please come up to the stage.
So check. Okay. So welcome from my side. I would like to introduce myself shortly. I'm Uwe Gall from the vertical management chemical industry. Okay, I will take that. Maybe that's better. And you might be assuming Siemens, what's they're doing here on the recycling event. So it's quite simple. Siemens is one, or will become now, one tech company, and is long time on the ecosystem of the battery involved, working together with all partners and industry players worldwide to transform the whole ecosystem, electrification-wise, automation-wise, and digitalization-wise in a new area. And that's the reason why I'm here and would like to talk a little bit about the digital product passport, the battery passport, and how it comes that we will have in a couple of months that passport available on them, or not available on the market. You have to have it in progress. So we heard here in the last presentation already, the market will grow not so dramatically as it was predicted in the last years, but yeah, the figures are in the same range. Some analysts say 90% in the next years, the others say 24%. So I choose the optimistic way of growth. And all those things has challenges. Those challenges we heard already in the other presentation, like lack of skilled workers and environmental impact in the whole ecosystem when we're thinking about mining things, ethic problems and so on. So the governments, the regulators decided to implement, from their point of view, a solution which satisfy all necessities and get transparency in the whole ecosystem. If you see what kind of regulation and standards and initiatives and indicators are already in place, if you see it worldwide, globally, it's not so much, but coming up, there will be a hell of those things. And if you look a little bit far away, there are more coming up we can see there in development. So all those regulation standards will influence the whole ecosystem dramatically and will maybe also influence it negatively. Today, I will focus on the digital product passport and a little bit on the EU battery directive. When you see here, there are additional regulation also at the moment in place. We heard it from our colleagues this morning. And from this year on, you will have mandatory CO2 footprint available or necessary on, for the battery models. But starting of February 27, everybody who will sell batteries bigger than 2 watt per hour capacity batteries in the EU have to fulfill the regulation of the digital battery passport. So, digital passport, what means that? We have there 93 data points we have to collect in the whole ecosystem. That means we are starting from the mining until the end to the recycler. And those data points coming from different areas. That means also we will have the battery material composition on that battery passport. And focusing on those information, from my point of view, later on the recyclers will have advantages. But besides all those things, I would step a little bit back and see what is coming out. So there are 3 different clusters. That means material production. There will come up certain mandatory changes in the efficiency and also in the recycling rates. Most of the things mentioned here are already mentioned also in the presentation up front. From my perspective, from my view, I see huge challenges to reach those recycling rates in the EU and even the recycling content, because the effort to get there, it seems not to be economically at this stage, at this moment. So if we look to the battery passport in February 27, the EU is hoping to have created regulatory in the market. But with these digital product passports, the battery passport is one of plenty other digital passports which are coming soon. So that's a new market from my point of view. If you see here, the colleagues from BMW has focusing on the product passports and looked a little bit how diverse or which passports will affect on the whole electrical vehicle, which passport will there show up. So 93 data points were collected. So that means it's a challenge for the whole ecosystem. One challenge will be how will be the data transferred from mining until refining, cell production, module and pack production until the recycler receive it. Because we have to get onboarded all suppliers, all OEMs. And I've had today a lot of chats with some colleagues here and around, and everybody is saying, why shall I present my data? Some data are available for sure, but why shall I distribute it in the world? That's a good question. So if we look along the battery value chain, for example, if we look here at the values of the CO2 footprint, those values which already collect in the miner, then we have to update it according to the refinery process, CAM process, and so on. Those values have to be modified all the way until we come to the end, to the recycler. That's the hell of data sources which have to collect it, update it accordingly, and protect it in our world. Because if you grab data, you have to protect them for malfunctioning or not malfunctioning, to use it on the not proper way as they should use. Because from my point of view, we collect here data which are sometimes could be sensitive for the OEM, for the supplier. And if it's distributed to people who should not have access to it, they could use against those companies. Let's look a little bit deeper. So what could be one solution? How could we protect those things? If we collect all data on the private cloud, which is protected with restriction, with guarantees to protect those sensitive data, it could be collected with a QR code, transferred to the cloud, and with the QR code, it could be grabbed from the cloud to the certain regulated handheld where it's scanned and gets the information he is allowed to receive. Those battery passport is, from my point of view, helping the recycler to choose the right way. In that case, at the moment, we have different kind of batteries in different kind of personal cars, electrical vehicles. And if I select one supplier of cars, for example, so we have here Mercedes-Benz trucks, but we select the Mercedes-Benz. I am aware of 6 different kinds of batteries they use at the moment. But those 6 batteries are not identically. And even the chemical history is not the same. For the recycler, it's a challenge to open those things proper, safe, and with the battery passport, he gets the right information in a certain time, and not or to minimize also the risk. And an additional plus is he knows exactly which chemical are used in that battery. At the moment when we shredded end-of-life batteries, for example, Fortum here in Europe is collecting end-of-life batteries, shredded, and transported the black mass to the central station in the Nordics, where they do the chemical recycling process. For them, they are not aware what kind of chemical black mass they have there, which kind of batteries are in the center arrived. They're aware that they collect, for example, from Tesla, from Volkswagen, from BMW, those things, but the chemistry is different. And to optimize those chemical processes, those values are mandatory to save resources from our Earth. So that's an advantage. For sure, the security properties has to be fulfilled. No question about it. So From my point of view, we will increase the speed of assembly with that digital passport. We will increase the traceability of the battery due to the collecting of all information and of short reaction times to get those things. The discharging will be done efficiently. So we will minimize certain risk when we handle today a battery. So the risk of electrical shocks will be minimized because we know a lot of things of the health of the battery. It's stored on that battery passport. We will minimize the chemical hazards because we are aware what is really originated in that battery type. And also we can protect the fire hazard. From that point of view, there is at the moment one solution coming up in conjunction with Siemens. That's the path error system. That's an industrial partnership between certain industrial partners who are dealing with materials and batteries on the European market, but that could be extended also globally. And there will be onboarded additional companies soon. So besides that, I can say only if you would like to have more information about that battery passport from our side, go on our website and you will find those information, what we would like to know. So I'm ahead of my time, but nevertheless, I think I go quick through the slides due to the fact that we have discussed this morning a lot of topics already from my slides so far, from our colleagues. And yeah, maybe I miss or go too quick to some things over there. The first question is showing already.
We got a microphone over here, please.
One.
Thanks, Ivan. It was a really nice presentation. Nice to see Siemens doing so much work in this area. On terms of the state of health, have you looked much into what data needs to be stored about the battery? Like what frequency, exactly what events need to be stored, that kind of thing?
So we have stored the 93 data points according to the new standard. What was mentioned in the morning, the DIN, I've forgotten the figure, and that's covered. And if necessary, wish of customers, additional points could be collected, but the mandatory data will be collected. So we have developed that battery passport for sure, but we are not a producer of battery cells. We are no recycler. So we said, okay, the regulation has defined those standards according to the DIN, and we will cover that. And if anybody is requesting additional data, that's an easy task to add it to that product. Further questions?
Thank you. It was a really interesting presentation, especially the very scary slide that you had, all the different regulations globally. One of the things that strikes me is that if this actually does come into EU law in 2027, we're still waiting for the final bits. You're really looking at a car that might come back into a franchisee or a garage in 2040. By the time it comes back, because of the length of the time that that battery might last, in which case, I mean, I'll be well retired, but by then, 2040, You know, you're looking at perhaps new recyclers who might want this information. But today, recyclers already know the batteries that they get in because they have to for health and safety and training and everything else. And the discharge isn't done at the recycler in general, sometimes, but very small amount. It's done at the garage or the repair shop or the franchisee. But the bit that might be missing in your sort of flow chart is second life. Because whilst it says in the law a second life operator is required to update that passport, no one's going to enforce it. So the reliability and trustability of that passport is perhaps weakened because of that. And I just wondered if you'd factor that in. And the future, I mean, we all had a, you know, crystal ball, we'd all have picked the lottery tickets. But, you know, how are recyclers in the future, in 10, 15 years, going to start, you know, looking at it today if that gap is there?
For sure, that's a good question. We considered that the second life is there, will be there. If a battery is dismantled, for example, and the packs are used as a different battery in a second life, they will have additional battery passport, or it's a second life digital passport then, and all those values which has collected so far will be shared to those DTPs at a package level or cell level. They have to, according to the coming regulation.
I'm sorry. Yes, for the virtual participant.
I agree, they're supposed to. But, you know, you're always going to have players who won't. And if there's no license, because it's not waste, so there's no license and nobody knows they've got them. And I'm not talking about batteries coming back through the brands. I'm talking about a 15-year-old car that goes into a garage in a particular little town. You know, they're not necessarily going to trace those, and they might take those batteries, swap out some cells that they've bought off of Amazon or eBay, for goodness sake. You know, there's the reliability of the data when it comes to the recycler is breached because of that potential, you know, sort of miss, that link.
That potential is there, no question about. According to the regulation, yeah, there's a gap in the regulation, no question about it. And to cover that, I have no clue at the moment, because black sheeps are always on the market. If you want to use it properly, it makes sense. If you use exits to save money or whatever, yeah, and it's the whole system will fall, no question. Further question?
We still have time for a few more questions. Got another one over here. Okay. I think Julian brought up a great point. Is there's going to be bad actors, right? So it's how do you get that certainty?
I was curious, so what technology are you using to do the data assurance? Are you going to use blockchain or something similar?
Not blockchain. We use Catena X for that purpose. But it's still open to use other systems for it. So that's adaptable.
Got time for one more question if there's any? All right, if not, that's
what was there?
One benefit of going through your talk fast. More time for questions.
That's good.
We heard that potentially the recyclers will use the battery passport. Do you have done a survey or analysis who really will use that battery passport? The authorities, users, recyclers? Do we have any data about that?
Personally not. My colleagues who are responsible for that product, they have done a selection or survey, and they have requested the market to develop those products. They have developed according to necessity to their survey plus the regulation. So that was a basis to create those product. Yeah.
Thank you, Eva.
Thanks.
Right up next, we have Sujiva. Not even going to try to pronounce your last name. So he's a principal consultant at the Mobility Alliance Limited. So he's really a pioneer organization focused on EV charging infrastructure in Sri Lanka, working with utilities. I was learned it's not an easy feat. And then today he's going to really talk about how do you track these batteries? How do you track the salvage end of life batteries? So looking forward to it. Thank you.
Thanks for the introduction. It's good that I had to start mine after the batteries passport thing, because we've been hearing it from 2019, if I'm not mistaken, or 2020 rather. And but I'm coming from a small island where the EV population started building since 2010. In our case, there's huge aggression from the community, because ICE is community is so very powerful there. So they were talking about the recyclability and what is happening. And before all this, the electric car thing, we have about 100,000 hybrid cars, which is 99% fitted with NIMH technology, and with our temperature levels, which is about 32 degrees and more at times, the degradation rate is much higher. So although I've been hearing from the morning that the degradation, the life cycle is about 5 years, 10 years, 15 years, likewise, but we are not like that. Not only my country, the tropics are getting degraded, including Thailand, I'm hearing. After 5 years, the degradation rate is much higher. So our problems are much bigger. We couldn't wait for the battery passport, what we are hearing. And the key data, we don't know what share of lithium-ion batteries are getting recycled. Leave my country aside, even in the whole world, nobody will be able to answer this question yet. So this is a critical scenario. We've been living with the electric cars or rather hybrid cars for some time, couple of decades now. But still, we don't have this key data. Leave the recycling aside, at least. Okay, I'm going to, this is what I've been talking today. This is about our company. What we do is actually, we are maintaining the EVs as the forerunner in the country. And also on the right-hand side, what you see is the Lanka Electricity Company, that is the government utility, the charging network we built. Of course, the chargers are imported because it's not cost effective for us to make our own chargers there. So we import a C-certified chargers, but the whole management system, communication, compliance with the CHAdeMO and CCS2 are all being done in Sri Lanka by ourselves. And we do a lot of training programs and also the retrofitting the batteries. And then again, second life, we are very aggressively working on, but there are huge barriers. I'm not talking about this data, but I'd like to highlight one point here. 500,000 batteries from cars from our part of the world are getting needing recycling because of the temperature levels. And this number will continue to grow annually. And now the question remains, where are all these modules being used? Because even if it's second life, we need to know where the second life module are getting used. Second life assembly is being used. And then again, who is responsible for these things? And then again, who ensure that these will be recycled in future? Because it's all data related, and we couldn't wait until the battery passport comes in, which is a very good initiative and a very good project. But what we did, I'm presenting a case study, what we did already, which is operational in Sri Lanka since last year. And the difference is now the battery passport, it's a globalized solution, and ours is a local focus, and but our data or maybe our model can be used. And the second key difference is The battery passport covers the whole ecosystem, the whole value chain of the electric cars. But ours is simply focusing on the reuse and recycling aspect. And the third key difference is the battery passport is basically I've been hearing it's 93 data points, and when these 93 data points come from different manufacturers, different battery manufacturers, auto manufacturers, different companies, it will be multiplied for sure. But ours is basically the local importer to end user, because we are a sea-locked country and a small island, and we need to monitor through customs what is coming into the country for retrofits and all that. It's in tons actually, because already the country has replaced about 2,000, half of its EV population with retrofitted batteries, but not a single new battery, all used batteries from Japan and China mainly, and New Zealand, few from New Zealand as well. So we don't know, there are, when a battery, OEM battery comes from New Zealand or Japan, we know that it's been removed from a salvage car, but when it comes from China, what comes is simply the modules. We don't know what it is, no certification, nothing, all used modules. So we wanted to control this aspect. And now fourth aspect, the battery passport, of course, we know it's complex. It takes time. We don't know. Yes, I'm so happy that it comes into play by 2027, but we don't know. But we can't wait, because my country, the main revenue is on tourism. If we destroy our environment and the landfilling, because we see that behind every garage, we see stockpiles of hybrid batteries and EV batteries. And ours is quick deployment, and we already deployed, but work is going on, because it is a thing which is needing to be aligned with the government as well. And we are experiencing quite fast government changes. And what happens in our our part of the world is, when the government changes, the policy also changes. So we have to start from the beginning. This slide also I'm going to skip, because the data you all know better than me. Okay, this one, what you see in the right is the battery is being removed in China, and these are says the cars which has been removed, which I got from the internet. I really don't know, I haven't taken this picture, but the right hand side picture, the right bottom picture, are the modules imported to the country from China, all used modules. And the post says here in my language, the importer says 2022, produced in 2022. But when we check these batteries, some batteries were manufactured in the labels for 2019 and 2020, likewise, because it's false claims. And they say it's CATL battery modules, but some proved it's not CATL as well. But these labels also can be forged. Still, challenges in recycling, R&D focus on range and cost. So these are our current barriers, because most of these importers are not willing to share this information. So that's why we wanted to bring in a regulation. And recycling, we don't have recycling, and not a single battery has not gone out from the country since the introduction of electric cars. I'm talking not only about the third-party car importers or dealers, even the manufacturers like BMW, the dealerships, they have stockpiles of batteries in the country. Not a single has gone out of the country, unfortunately. And of course, the government lethargy and the policymakers don't want to rock the boat, or they don't want to work extra for the regulations likewise, because it's additional work to them. They just wanted to do something and retire. And this is what we have done. This is the government Ministry of Environment website. You can download this application to import a battery to the country. Because what we did was, I will explain. So this is the license getting issued by the government to import a used battery to the country, because there are no new batteries available, very few, new or used, each by giving the car number, proving the need of replacement, and the government issues this import license. That's a particular import license. But there are barriers the government agency issues, and nobody wants to go through the licensing process, and everybody wants convenience in the sense you can bribe the customs and get your battery cleared without that license. those things issues and technical issues, economic issues, because when you introduce a policy, a system, the cost goes a bit high. And then people are talking about, okay, nowhere in the world this sort of a thing is happening. Why we need these policies? But we just cannot do that. So this is our process, what we are doing. So first, the prior approval need to be taken by showing, by doing a need analysis data, and then the license getting issued, the one I showed you. And the customs need that import license to clear the battery through the customs, use a single module, because, and at that point, we collect the data. Data in the sense, even if you sometimes we get the whole assembly with the serial number, even if the modules comes to the country, each and every module is already having a serial number. So we record this data, but we have, although we mentioned quality assurance, we have no way of quality assurance because none of these batteries come with any certification. There's no regulation as such, and the data management. Now we are working on the web portal, but we didn't want, although we have the capacity to do it by ourselves, we didn't want to do that. We wanted the government to do that to make it official. Because if we do that, nobody's going to follow because we are a private institution. And the government need to work on that. And we are talking to the government with the serial numbers, location changes. Even if the module gets removed from the battery, the web portal need to enter that the relocation of the battery. And deposit initially, if you import a battery, the deposit to be, small deposit to be placed with the government, and the tax credits. All these are suggestions from this point onwards. This is currently in operation. These are, we are hoping to get it active within the year's time, and end of the life, the confirmation of recycling and the tax credit refund and the system update and the data analysis. So in doing this, we had several meetings with we worked with the Basel Convention as well, because they are the people who are responsible globally for cross-border transportation of lithium-ion batteries. Unfortunately, they don't have any regulation on it as yet, but only on lead-acid batteries. And the government agencies, of course, the Ministry of Environment, Import and Export Control Department, the Customs and Inland Revenue Department. So these are the key stakeholders, and the community also supports the initiative. Yeah, the web app with varying input, authorizing and the authorization and public levels, in the sense the app similar to the battery passport, the data need to be collected and data need to be entered with authority. So that has to be done, and the standardization and the battery and serial numbers, it's already there. So we don't need to wait for the battery manufacturer to do any changes to their existing platforms, because it's anyway out of our control. So we don't want to, we wanted to work within the existing data, within the existing framework, to control the inflow of batteries and to ensure that all the batteries are getting recycled, not only the EV, including the hybrid. And the regulations, the compliance, that has to come. If the battery passport comes into play, we can utilize that data from the regulators as well. So this is about Basel Convention. Basel Convention, here you see waste batteries. They talk about the lithium-ion the lead-acid batteries, but there's no prohibition from Basel Convention. They are the regulatory body for cross-border transportation of lithium-ion batteries, but there are no regulations. And technically, although the shipping companies say that the used batteries has to go under DC classification, dangerous cargo, which doubles the cost, there's no guidance to do that. If the battery comes with, if the battery is from a OEM, in the sense by a reputed manufacturer. But unfortunately, we are paying heavy costs for our sort of countries in transportation as well, for not having clear guidance. In fact, Basel Convention doesn't say yes or no to anything. Okay, I have 5 minutes more. So questions and answers on this thing. Basically, you may have questions. This may not I don't know. I was thinking applying a similar model to all the countries to simplify the process, but to ensure that we have all the data we require and to ensure that we recycle the batteries. And also, to add to my presentation, I would like to say the second life usage also not very successful. I've been hearing here also the same thing, because our problem is even worse. The situation being, we use the batteries until it's dead, basically. The car stalls on the road, maybe 20. Sometimes people go for replacement with 20 kilometers, 30 kilometers range batteries like. So about in a whole assembly, it'll ends up with about 3 or 4 kilowatt hours of capacity. So there's nothing much you can do with the second life, even with the EV batteries. Of course, we know hybrid batteries we cannot use for because of its small size and the mechanism, we cannot use it for second life usage. In our country, I think we should be able to, with the due government support, we should be able to fully operate. This is operational actually, but although this is operational, not all the batteries coming to the country with this the licensing system. There are loopholes, but the digitization, that's what we are working now, will resolve that problem also, we believe. Questions?
Thank you, Sujiva. Do we have any questions from the audience? Got one up here.
Thank you. Very interesting situation in your island, not very well known in terms of conditions of operation here. You said that no battery left the country. There is no recycler. So where all the batteries are going today?
Some batteries are in warehouses, as I see here the case as in, but a very limited quantity. But most of the batteries are not getting even transported to the recycler or namesake recyclers warehouses, and it's just getting dumped out in the ground. That's what happens. And if you want me to quantify the amount of batteries got dumped in EVs, over the past 4 years, we replaced about 2,000 electric vehicle batteries. Each battery is weighing about, say, half a ton. So it's about 1,000 tons, which is a big number for a small country. And the hybrid batteries, we have replaced about 30,000 hybrid batteries, small in weight though. That bad.
Thank you.
Any more questions? So you pointed out that the batteries you're getting are not always what they say they are. So on a small scale, that's easy to handle, right? You can go individually one by one and check it, make sure that if the sticker says it's this, it is this. How do you think we could handle that on a large scale? We can't check every battery. How do you ensure you get what you think you're getting, and how do you remove any bad actors?
The numbers, the data is getting recorded at the point of customs when it comes to the country, and then it gets installed to a car. So we have the system, what we are developing. In the system, it will have the car number, the particular car owner's registration number, and the battery serial number. So at some point, this particular battery assembly will get dismantled, end of life. So then again, the serial numbers to be recorded in the same system, and then it gets the track. And if that particular car, because we don't have a car scrap policy, so the cars are running endlessly. So if when that particular car needing another battery, that thing gets tracked what has happened to the previous import, or the previously registered serial numbers. So that's the tracking point.
Got 2 questions over here.
So after listening all, in fact, a question for the battery associations and the guys working on the global battery passport, because we heard this morning that we know all that battery shipping to the non-OECD countries are prohibited. That's good, but we manufacture also cars in Europe, and we are sending cars with batteries all around the world. So, for instance, in the case of Sri Lanka, we can have some cars, electric cars, sent to trucks or whatever, sent to this country. In this case, the use of battery passport should be again regulated on global basis, or how we will manage that. It's a big question, I think, because having only the European regulation applied in the European area will not be rendering the global battery passport useful for everybody in the industry, correct? If you don't have the infrastructure for that in Sri Lanka, for instance, it will not be useful for you.
We are happy to have a battery passport. Of course, there's no denial about it, because it further justifies the quality, the quality of the industry more than the quality of the battery or more than the quality of the environment. So it will help definitely for the battery, the industry to grow. But in Sri Lanka, we couldn't wait for it. So that's why we developed it. We are anxious to have the battery passport. I mean, there's no denial.
Just to add the question, do you have numbers how many batteries under the European restrictions are exported to Sri Lanka, or is it just Asian batteries?
It's just the Asian batteries, mainly from China, used batteries from China. From Europe, the BMW dealer imported some batteries, because they were the only people who had the electric cars, not the Mercedes, not the Renault, not the Peugeot. None of them had. We don't have those cars. We only have the electric i3s and i8 likewise, mostly the i3s. So only BMW importer, the authorized distributor, has imported some modules for under warranty. Other than that, no European cars.
As far as I know, China has a similar regulation to our EU regulation. So doesn't that work? Or doesn't they control it? Or how can it happen that so many batteries?
The batteries which comes to the Sri Lanka from China doesn't come with any certification, or even the documentation to get the tax evaded. It says new, but we inspect the modules. It is all used modules. And doesn't get covered under any regulation whatsoever. It's basically I would say some dumping ground also, because it's very clear that all these modules coming into our country are being used. Even from Japan, what we get is used, but at least we know what we get from Japan are OEM assemblies, because it is the Nissan battery assembly likewise.
Why do you think there's no recyclers on the island?
I think the technology is costly to have a recycling plant within the country, and the export is not possible because it's costly. Nobody's going to pay the price, and also our scale, I think, because still the scale is not sufficient. Yeah, it's a small country.
There's a number of recyclers that build small modular co-locating units like Encycle, Green Lion. I mean,
very, very, very good thing. In fact, we were looking at that thing for small scale the recycling plants, but that also goes, the capital cost goes beyond $200,000 minimum of. So in that scale, and spending that much of money and making a few kilos of black mass is not going to make anything unless the government funds this operation. But my government is poor.
All right, thank you. We have time for one last question if anybody wants to get it in. If not, then let's thank our speaker again. Just to remind the speakers, we do have that cancellation. So after Banyat, we're going to have Dr. Gerald Sommer come up and speak. So next is Banyat Sabat. He's He's the team leader and commercial lead of vehicle electrification at P3 Automotive. He spent almost 2 decades, right, in the industry doing all this. No, 1 decade, long time. And now you're really in charge of a large consortium, kind of managing that project, which is not an easy feat. And today we're going to hear about the ever challenging debate of reuse versus recycle.
I'm still awake. All right. Hello, everyone. Happy to be here. So it was just mentioned, the title of the presentation, Second Life versus Recycling. It's less a comparison of Second Life versus recycling from my point of view, and I think we heard it already a lot of times. Second Life is more like a pre-step before the battery. I hope you can hear me good, else please raise your hand. It's more like a pre-step before the battery can go into recycling. So we have a really sustainable battery life cycle, making use of kind of the end-of-life batteries. What the case study that we worked on is and was focusing on was the actual use of commercial vehicle batteries and how they kind of compare to passenger car second life batteries, but also to first life batteries for the specific applications. Yes, perfect. So what will we look into today? Just a quick introduction and motivation. I think I can jump quick through that. I think we have a lot of experts here, but in general, why is the topic of second life in the commercial vehicle segment so important? Then we will look at the several applications. So in general, we analyzed around about 20 applications that can be interesting for second life batteries. But for here, we just picked or selected some of the more interesting ones, 5 in total, that we would like to dive a little bit deeper into, and specifically one that I don't want to tease now. But we checked on the economical and technical analysis and benefits compared to second life car batteries. Then we will get into the key challenges for second life repurposers or remanufacturers, and where here we can see kind of the performance again versus second life passenger car batteries. And at the end, I will give a quick summary and a short outlook. All right, just quick. So in general, of course, we are seeing an increasing demand. We expect that the battery demand in terawatt hours per year will 5-fold within the next 10 years, up to 10 terawatt hours. And currently, we see a huge momentum in the commercial vehicle segment, specifically looking at trucks, at long-haul trucks, where we see battery capacities of 500, 600, or even 600 plus gigawatt hours in one vehicle. So this in general increases also the importance of, again, the sustainability of battery life cycle. And again, we see that specifically what I mentioned, the larger battery sizes in commercial vehicles can be of advantage. I will go through that in a moment, but usually we have, let's say, the less energy densities in commercial vehicles, sometimes due to LFP, sometimes due to less hard requirements on the space utilization for commercial vehicles or specifically trucks. And this is something that aligns pretty good with a lot of different second life applications. So I will also go quickly through this. I think a lot of, again, experts here, but we see here more or less on the left side, the refurbishing, or how we also called it, the reconditioning of batteries, where kind of used end-of-life batteries, which are around about 70 to 80% of SOH. And these will kind of be dismantled, checked, inspected more or less. We heard also about the battery passport, which could play a huge role also for this topic. But then there will be more or less a classification of the battery and potentially a second life testing if needed. It depends always on the information that we have on the second life and the SOH specifically. But then a sorting takes place for different applications. Then we go over to the remanufacturing, where a conversion mostly from modules to packs, can be also cells, but that's the usual, will happen. Potentially a recertification in most cases, and then a commissioning or end of life testing of the batteries. So in general, second life applications need to be within kind of the window of opportunity in order to be competitive to new batteries, but also to the recycling of batteries. So we see here kind of two limits, the upper limit in gray again, where we have new battery prices in the car industry around about 90 to 120 US dollar per kilowatt hour, or euros roundabout, and a little bit more in the commercial vehicle segment. But this is kind of decreasing what we are expecting due to technological maturity, design to cost optimizations, and also scaling effects, of course. And then we have in orange the lower border, where we have more or less the recycling value. And in between that, the price for the repurposed battery, second life battery, needs to be again competitive and to kind of enable business opportunities. Then, what we kind of did, as mentioned before, we analyzed around about 20 applications. Sorry, thank you. We analyzed around about 20 applications, and just for this presentation, I selected 5 of them. One of them is just fleet refurbishment. So use the second life battery just to replace old batteries in an existing vehicle, where you just try to balance more or less the pack or the system with the second life modules. Then we have lead acid replacements. Usually forklifts is a case that is well known of, but we have also other industrial vehicles, AGVs, automated guided vehicles, golf carts you hear sometimes about, which are usually driven by or powered by lead acid batteries, which have low requirements, technical requirements, and where we see more and more the replacement by either first life lithium-ion batteries, or even, which is getting more popular, especially in China, for example, by second life lithium-ion batteries. Then we have 2 use cases which are usually well known of, stationary storages. So for either backup power in hospitals or other events, for example, or we have the temporary and portable power solution, also again used for construction sites, for, I don't know, music events and so on, concerts. Last application that we checked on or selected for this was our marine propulsion and cold ironing systems. So to charge kind of the ships, we had a specific focus on ferries and river barges, because there we see the more higher maturity currently in the market. So just a rough technical assessment, and again, it's on a high level here. Behind those 5 criteria, different specifications to kind of get to this overall scoring with a technical fit, where we kind of checked voltage level, energy density, size of the and format of the batteries. Then we have starting from the right, the rework and service, where we evaluated the assembly efforts and the service efforts to integrate also the modules again back to the pack, but also to service the application on site to bring actually the battery to the construction site and maintain it and so on. The invest to ramp up, again, I think self-explanatory how much is needed to get to a specific gigawatt hour per year. Then we have the price competitiveness, where we compared the price of second life commercial vehicle batteries to second life car batteries and to first life batteries. And this is a topic I will jump on the next slides a little bit deeper into. And we have the entry barriers, where we check like what do regulations say for the specific applications, and how strong is the competition, how big is the market, how mature is currently the lithium-ion technology already in those segments. So what we see here in general, of course, fleet refurbishment, if you use the modules again for the same applications, we see here the highest potentials, but what you cannot see here is, of course, the business opportunity is relatively small because we're kind of focusing on a specific model or a specific fleet. So business opportunities in general are relatively small. What was a little bit surprising for us was, in general, the lead asset replacement that we didn't even have that big focus on. We saw that there is actually a really high opportunity to place commercial vehicle second life batteries and get even good other business opportunities compared to second life car batteries, for example. Here, just a quick comparison. The right column, just a reference for the material handling, so the lead asset replacement, what we deep dive a little bit deeper into. And compared to that, you see on the left side the electric commercial vehicle second life battery and the electric car second life battery. So again, always on module level and compare just if the specifications are met or not. You see more or less the commercial vehicle battery fits to all the requirements. Where we have kind of the differences are at the gravimetric energy density. So usually material handling vehicles need some weight, some counterweight for operation, and this is where usually NMC 81191 are almost too light. So there we see that actually the lower energy density of commercial vehicles can be beneficial for material handling. Also, what we see is the lifetime topic. So with NMC, the newer modules, we are around about 1,000, maybe 1,500 cycles, which would be really the upper end. Usually with commercial vehicle batteries, we have double or triple the lifetime. And this is where we see actually that commercial vehicle second life batteries can kind of win or exceed against car second life batteries, where we see first of all, the batteries are large, they are easier to manage. You have, even with 70% SOH, you have still a pretty high capacity left. Then again, the energy density needs are not that high for second life applications in this lead asset environment. So this is again beneficial, and as mentioned, you have the longer lifespans, but also the more predictable degradation, because usually the routes are controlled, the usage, the operation of the trucks or buses even, it's defined, it's controlled, so it's easier to understand how much SOH is actually left. Yeah, one other topic, and I will get to the economic view on this, is of course that usually we see often LFP batteries in commercial vehicles. In Europe, still there are a lot of NMC trucks and buses operating, but I think also there we might see a shift in the next years. So the lower recycling value is again beneficial for the repurposing of batteries used in commercial vehicles. This is the cost comparison. Again, as a reference, we have a First Life lithium-ion battery for material handling, which we estimated at around $150 per kilowatt hour. The data are from September, October, so they might change, might be changed by now a little bit. But you see here kind of the comparison when you remanufacture, refurbish a Second Life battery, again, for use into material handling vehicles. We see the comparison of electric commercial vehicles to electric cars, where we kind of are at around 70%, if I don't miscalculate too much, 60 to 70% of the actual cost of First Life, without losing too many specifically technical requirements here on the Second Life side. So what you see here, kind of in this gray hatched part, is the margin, where we did the assumption for electric car batteries that the margin will be at around 10%. So this is the upper limit for commercial vehicles, where we see that the margin or residual value of the commercial vehicle Second Life batteries can be around 20%. So actually higher and more cost competitive than Second Life car batteries. Then just quickly through some challenges, and I will not go in detail on through all of them, but we see definitely some challenges for repurposers, and kind of the challenges can be seen also as opportunities and success factors. Right now there is the price competition, so we see that LIB batteries First Life LIB batteries are getting cheaper in general, and Second Life car batteries in general are cheaper than commercial vehicle batteries. So there is some opportunity to already go into partnerships, maybe with OEMs, for example, with fleet operators, to get access to Second Life batteries, get access to kind of the amount, and develop that into a growing business. For specifically stationary storages, we see the software as a challenge, but definitely also as a differentiator. So here, energy management systems can be kind of a side product additionally to the Second Life. And then we have the currently low volumes. Of course, you need right now deep pockets and patience to stay in the market and be competitive. This will definitely, from our point of view, change within the next 5 to 10 years. So this will be definitely an increasing market. And maybe again, I jump just to the technical compatibility. So right now we have different models, no standards, specifically in Europe. So there is some standards in the best case needed, but also there with partnerships, modularization of platforms, there can be different applications or vehicle models can be covered by that as well. I'm just jumping quick to my last slide and to the summary. So again, we are seeing the rising demand for lithium-ion batteries, especially in the commercial vehicle segment, with the launch of long-haul trucks, 600-700 kilowatt hours of battery. Then we see also regarding the applications, of course, refurbishing the batteries for the same application is definitely something that can be done and is being done already by a lot of OEMs also. But we see here opportunities in different applications, not only stationary storages, but also in industrial vehicles. Yes, the commercial vehicle batteries are, from our perspective, really well suited for second life. Again, the large battery sizes make them more easier manageable. Logistics efforts are reduced by that. Then we see also the higher lifespan and in general lower repurposing costs due to the specific sizes of the modules. Last but not least, yeah, as mentioned already, we see some challenges, but they can be kind of transformed into success factors when the access to low batteries can be achieved, and specific advancements can be made with battery management, optimizing processes, again, making use of battery passports by reducing testings and inspections in that area. Thank you, everyone. And if interested, we have different white papers published. End of last year, we published a white paper on battery aging, which was really popular, where we tested and analyzed the data of 7,000 vehicles to understand better the performance and degradation of batteries.
Thank you.
Thank you very much.
We have time for a couple questions. So it all comes down to economics, right? What do you think is the cost for risk? If it's almost the same price as a virgin battery, why not just use a virgin battery? Because there's risk associated with recycling and safety. So what do you think that threshold is? Is it going to be 50% cheaper, 30% cheaper?
So what we saw there, the price can be up to 30 or 40% cheaper than First Life. Again, the prices are decreasing. We see a lot of low prices from Chinese manufacturers, but in general, the main costs are in remanufacturing kind of the modules back into packs, and this is something that is, let's say, on par with First Life batteries right now. So as long as the price is higher than the recycling price, or I would say the opportunity costs are higher than the recycling costs, and the recycling we see right now at around $15 to $20 per kilowatt hour. So there is definitely some margin for repurposers at the current moment even.
Thank you, Brigitte. Very interesting. I have a few questions. First, in fact, the business model, because you mentioned the economical facts. I consider that 90 USD per kilowatt does not take into account two facts. First, you need some engineering works, to adapt, because if you go to the fleet refurbishment or you go to the lead acid battery replacement in a given fleet, you don't have everywhere Jungheinring or Toyota. So for each type of car, you need some engineering works. So you have to reconsider that. And this is my opinion, and you have to confirm or affirm. And the second point, this is the disadvantage, but there's an advantage in this study, I guess, because in such kind of work, what we put into consideration is also the CO2 emission savings, because here in the right-hand side, we have the price, but we don't have the CO2 emissions. When we do that, I mean the refurbishment or the second life, then we save a lot on the full manufacturing of the new car, not just the battery, because the alternative to that is to replace the car, I don't know, the generator, whatever the tool on which we are working. So there's a lot of carbon emissions coming out from that. On retrofitting works, we also put this into consideration. I think that it's not just the economical in such terms, but also the carbon emission savings. You didn't put this in the studies consciously, or it will be added?
That's correct. This is a topic that we didn't consider yet, I would say, and a good point, maybe as an outlook, that we need to consider that as well. Regarding your first question, we actually looked into kind of development costs, labor costs. The numbers that we assumed, I don't have them right now exactly in my head, but I think it was around 2 gigawatt hours over 5 years, something like this. So it highly depends on what volumes you are talking. If we are talking about, like, let's say for now, maybe smaller fleets or smaller amounts of vehicles, then of course it will have a bigger effect on the cost. That's correct. Yes.
Last question.
In the given context of commercial vehicles in the current fleet, what sort of a volume of batteries available for second life you forecast from this to like 2030? And second question is, when it goes to the level of second life, so what will be the SOH at that point? What is the SOH when it goes out of the first life service?
Regarding your first question, the output, again, I don't have the numbers exactly in my head. It also again depends on which fleet we are talking about. So buses are already, since more than 10 years almost, electrified. So we see there already different partnerships going on. Regarding second life, usually you see like second life bus batteries and storages. The output, from my knowledge, is somewhere around 2 to 5% that are used for second life right now. But again, this is, maybe I can check that, and we did actually include that in the study as well. But yeah, for truck batteries, they are the first, let's say, smaller battery models were introduced a few years ago. So there is no output right now, I would say. There are maybe some that, single modules that are replaced that can be refurbished again. But I think the output is not really high. It's probably like 1 or 2%. But again, the market is really small right now. The second question?
The second question is, at what point you consider now the commercial vehicles get considered for second life usage? Because you mentioned at 70% SOH, you consider using it for, again, on some buses or trucks again, lower range. But when it goes to second life, what is the SOH level?
Again, depends. So we see partially in the bus again area that the batteries are used up to a SOH of 60%, down to 60%. But often like single packs or modules are replaced that have still like 70 or 80% SOH. And they can be used for, let's say, route profiles where only 80 or 100 kilometer, for example, is needed. So if you specifically check which use cases are require less battery capacity or less range, to be simple, then definitely like lower ranges are also available. After second life, so kind of end of second life, we are usually talking about 50% as the lowest limit. 50 to 60% is end of life, end of second life, what we are experiencing now. Also from the car study that I mentioned at the end, we are seeing something similar there. So the batteries are used up to 70% SOH. Then they can maybe use still like 10 to 20% more, but then it's kind of the end.
Great, thank you.
Thank you.
We have two last speakers before the day is over. So up next, we're gonna have Dr. Gerald Sommer. He's the principal business field owner at battery and BEV at AVL List. He's got his background comes from computer science and a PhD in economics. It's over 30 years of professional experience, with most of that being around automotive technologies. And today he's going to talk to us about lifecycle management.
Okay, so thank you very much, and a warm welcome to this late session for today, but not the last one. Yeah, I have been introduced already a little bit, so I can keep this short. You see, my background is computer science, and I work for AVL quite a long time. I spent most of my professional career actually in the automotive domain. And this is also the background of my presentation today. And I'm also active in the automotive standards organization ASAM. AVL, for those of you who don't know this company, we are based in Austria, a global acting, I would say, automotive engineering company, but also supplying products and services for simulation and testing. So we are heavily involved in research and development projects for automotive OEMs. And since some time already, of course, we spend a lot of effort into electrified powertrains, mainly. About 20, 30 years ago, we started with fuel cell technologies. Meanwhile, batteries are dominating our powertrain development activities. Now, let's jump into the topic of today. The title was about life cycle management. I want to dive into this automotive issues of batteries, EV batteries in special. And when it comes to recycling, those questions here, I mean, they are no-brainers, I think, for our group here. So will batteries end up in landfills, or what impact will end-of-life batteries have on the environment, and so on and so forth. But the answers to those questions are mainly not so easy. Let me try to guide you through the life cycle of an xEV battery, starting with the first life, where most of the energy and the, let's say, efforts of development goes into trying to create a good battery. So how to develop an energy and performance-rich, safe, and long-lasting battery. To identify a good SOH prediction. We see this later, this is important, and also to optimize operation strategies. For example, driving styles have a strong impact on later performance, maybe in second life, what is coming next. Here, the question first is, in many cases, recycle or reuse. And we have to identify the status of the battery. And in any case, we heard this today very often already. So, and last but not least, we can also talk about the end of life, what happens there. We have to decide, yeah, can I buy or use another battery, or how much is my battery worth, and when is it really dead? And to dive into this from our perspective, what we can also provide as AVL, as a company, to this community. First of all, in the first life, a life cycle-centric engineering of a battery. For the assessment, a very good, let's say, idea is to use AI in this aspect to analyze fleet data, for example, to better predict SOH of the batteries that can be used for second life applications. And yeah, a topic that appeared several times today already, battery passport. Here, I would like to emphasize that also we have an implementation. I will talk about that a little bit. Now, the first part, life cycle centric engineering. Here, it's driven by, of course, EU regulations also that go into the topic of the content of the battery. So we heard this already today. So this is nothing new, but we see there is a pressure to have certain limits that have to be achieved over the years. For example, when you look at 2031, we heard this today, that a certain amount of cobalt and lithium and nickel have to be part of a reclaimed material. Now, our approach is DFR, so design for recycling. We did several projects, and yeah, when we compare these two aspects of, let's say, standard state-of-the-art technology, we know this, most of the companies are doing shredding. So this is focusing solely on an engine energy density and production cost approach. So OEMs want to sell cars, yeah, and they usually do not consider a recycle approach. That's why currently a cell-to-pack or cell-to-chassis design is emphasized, and also other, let's say, activities on the mechanical side which are not helping in disassembly. On the other side, disassembly would improve the situation strongly, but here we saw that a module-to-pack or module-to-chassis approach is much better suited, and the design has to consider, let's say, an efficient recycling already. And the question is, go we down to the pack, module, or cell level? And we try to balance a cell-driven recycling approach that considers already a cell design adaptation. Comparing this, shredding accepts everything, so that's clear. Yeah, it's accepting end-of-life batteries, damaged batteries, or partially batteries. It's design agnostic, but it needs a highly heterogeneous product and significant refining, and as well, we have to deal with aluminum contamination. On the other side, disassembly has a huge potential to offer cost savings of up to 40% or 50% CO2 reduction, emissions reduction, because of reduced shredder wear or less refinement. It provides more purity in the black mass. So this can reach up to 20% of revenue improvements. But of course, it has an increased disassembly effort assigned to it. Let's look from an engineering perspective, what can we do already to better predict or to assess a battery lifetime or a battery state of health. For this, we know OEMs, especially automotive OEMs, struggle currently very much with product recalls. So we see this heavily in the different press media. And the thing is, the battery is the most important component, most expensive component. So assessing the battery state of health at that time is crucial. We set up an AI-based approach. So we developed over the years model-based approaches to assess the battery health in a fleet in order to predict the status of individual vehicles, which reduces the probability of recalls dramatically. And in this aspect also improves the lifetime of batteries from a fleet point of view, from an operation point of view, in order to lower the risk of, let's say, calling back batteries or removing batteries which are still good. How do we do it? The standard approach, we take vehicle data from the fleet. We take vehicle data that already have issues, and we have data that vehicle data that do not have issues yet. And we train an AI model with this in order to predict the vehicles that likely show issues soon. So with this approach, we can help OEMs to better estimate the probability of product recalls or the battery recalls, because you can assign each vehicle with some risk score, yeah, and the OEM can then decide which vehicle should it call back for preventive maintenance. So this is not a product recall. These are individual recalls, or let's say maintenance work, and this avoids actually a product recall. To give you a little aspect of how big this potential is, we did an analysis with a premium OEM in the UK, and we saw that if you do nothing, you have an 83% chance that a future severe event will happen. Whereas if you repair just 10% of your fleet, the risk is almost zero that something will happen. And this is a big thing because usually, depending on the country, the OEMs have to recall a whole, let's say, type of a model if a certain number of incidents are happening. And maybe only, let's say, 5 cars have an incident, and you have to recall thousands of vehicles. Another thing is predicting something, but also understanding why certain things go wrong. So SOH prediction is one thing. The other thing is understanding why the state of health of a battery is bad. And here, we also work with AI. We analyze data from the vehicle fleet and train a model that is then explaining what are the, how should I say, what are the key KPIs, key influencing parameters that cause a certain failure of the battery. So why, for example, is the battery degrade aging too fast? And this can be explained with this multidimensional response surface model here, where you can then interactively drag and see the different aspects of behavior of different parameters. Then you can find out if it's the ambient temperature, if it's the driving style, whatever has the most impact on a certain aging behavior. Now, third topic, the battery passport, spanning the whole lifetime from first life to end of life. And we heard that based out of the, let's say, Green Deal. And we already, let's say, thought about that. Why is this happening? Clearly, because we saw this today already. There is a jungle of regulations. That's clear because we have many gates to pass, and all those, let's say, participants in the market have to follow those rules in order to support the Green Deal idea. Now, that's why a digital representation, and we heard this, or we saw this today already from Siemens, that a digital passport implementation is key in order to get transparency, in order to get a full, let's say, the easy sharing of data across all those partners that deal with batteries. And also AVL invested here together with partners in order to implement a secure platform. It's derived from the EU battery regulation, and of course, trying to store all the relevant data that all the stakeholders can access that data throughout the lifetime. As we heard it today, it's about identifying the batteries, storing all the critical data, and also providing some statistics. How does it work? In our case, we connect the data sources. So the crucial part here is that you have an open, secure platform where all the market's participants can connect their systems to. Once this is done, the system then validates and notarizes all this data coming in order then, in this next step, to create digital passports for each and every instance of a new battery that arrives. And of course, then the goal is to share this data for all the different market participants. Could be some analytic service or the battery passport, or of course, and in our case, important for second life and recycling purposes. That brings me to my summary. We saw today a little insight from an engineering perspective, and I hope the battery will last. From the engineering perspective, consider recycling requirements already in the battery and cell design. So design for recycling is key for us as well. In the in-use phase, apply AI methods to improve SOX prediction and life cycle predictions, and also life cycle management with the digital battery passport to increase transparency and easy data sharing. That's all from my side. I say thank you, and yeah, I'm open for questions.
We have plenty of time for questions.
Back there.
One. Microphone? Okay, thank you.
Hello, thank you. Really nice talk. And I think I've been working with the AVL recently as well, so let's chat. I'm very interested in understanding the data that you store on, these are the dynamic data on the state of health of the battery. A lot of people have been asking me, well, what data do we need to store to track the state of health? And I see you use events specifically and aggregates, so it'd be really nice to talk more about what that means. And if you're considering it also for grid storage.
Okay, what data do we collect? Or if I understood, you ask what kind of data we need from the fleet?
Yep, on its cycling data. And,
yes, yes.
At what sort of frequency?
Okay, yeah. Okay, in terms of frequency, with any AI model, it's always good to have a lot of data to train the model, but it has to be good data. In terms of what kind of data we collect, it's split up in two parts. One is metadata from the OEM, for example, the statistics that we get from, let's say, static sources. And the second part is time series data directly from the vehicle. Yeah. The frequency depends. I would say it's yeah, not seconds. It's in a minutes range. Yeah, that is collected. And we are not, let's say, our way is not to get the data directly from the vehicle. So this is not our job to do telematics in this case. So we expect that the OEM, for example, provides an infrastructure to upload the data somewhere.
And has anyone considered what the energy footprint of storing that data is and constantly updating it?
Oh, no, this I can't tell you. Sorry.
I think storage is usually pretty efficient and low cost. It's the analytics. What do you do with that data? That tends to be the big cost driver. Yeah, no, that adds up for sure. Yeah.
I mean, the data if I understood how big the data gets, or yeah, it's. I think that's the point. It's not big data in that sense. So the number of parameters is not that huge. It's the number of records that accumulates over time, of course, but it's not hundreds of parameters. No, it's less, much less.
Where would you see the challenges or the differences in the prediction of the SOH compared for EV battery compared to a mobile phone battery? Because Apple, for example, can predict the quality of the battery currently with the charging and intelligent charging and all these things. So where's the innovation for an EV?
Okay, so the difference for sure is the class of battery. So the high performance or high voltage batteries used in vehicles have a different behavior. And also in automotive applications, the requirements to operate are different. And that makes a difference also in let's say, aging behavior. So one could imagine, yeah, the algorithms work well, But one example, for example, is that in the onboard systems that you find in any EV for estimating the state of health is typically not very good because of the limited, let's say, knowledge that is stored on board. That's why also many, let's say, EV companies are trying to connect their cars with the cloud system in order to update the battery management system with better parameters over the lifetime of the car. So that these are some, let's say, tries to get it better, to make it better.
Understood to some concerns, because every car should be online per legal requirements in the EU currently. So we have the challenge to upload this data to a cloud and then to run the parameters in the models in a cloud.
Yeah, fully agree.
Customer at the end.
Yeah, I fully agree. It's just a matter of doing it. So it's let's say the basis is there, but there are not so many, let's say, automotive OEMs that are really doing it right now. But it's on the way. So in for example, research and development, we have certain pilot projects running what we are involved as well to do cloud-based BMS optimization. So this will come.
And please allow me one statement. It may be true for passenger cars. It's not true for trucks and commercial vehicles.
Yeah.
Our customers request the raw data for their operating systems. They have to predict the uptime of the truck. So but we have to be aware that there are differences between the business models.
That's true. Yeah.
Any other questions? All right, if no more, then let's thank our speaker again.
Thank you.
Now we have the last but not least speaker of the session, Hervé Panjic. Is that close? Pretty close. Right. So he's a professor at the University of Zagreb, and he's part of the Faculty of Electrical Engineering and Computing. He's also the head of the Demand Response Lab. And your main research is around sort of developing accurate battery management systems and operations. How do you make them as efficient as possible based on operating? Please take the stage.
Hi, everyone. Good afternoon. Thank you for staying so long to hear this talk and to see me. My name is Hervé Panjic. It's probably one of the most names today. I come from Zagreb. I work at the University of Zagreb. So this talk will probably be a little bit different than all the ones that you have already heard today. First of all, I will not be talking about recycling. That's number one. And second, I don't work at a company. I work at a university, but I'm a professor, and professors like to talk almost as much as the salespeople. So I'll probably talk enough. So I will talk about optimizing battery charging and discharging to maximize its efficiency a little bit. So let me start with a short background. As a brief introduction, as I said, I work at the University of Zagreb, Faculty of Electrical Engineering and Computing. So my background is actually in power systems. I do power. So these plugs that you see, these kind of things. However, my focus is on economics of power systems. And since recently, well, first we had electric vehicles became an important part of the power system, because EV charging can take a lot of power and it consumes a lot of energy, especially if you have huge, massive transition to EVs, such as we have in the Netherlands, for instance. So I came from power systems to work with batteries, standalone batteries that operate within the power system, and electric vehicles as some kind of movable batteries that are sometimes available, sometimes are not available to the power system, depending if they are connected to the chargers or not. So we developed this testing laboratory where we test individual battery cells or battery modules up to a couple of hundreds of kilowatts of capacity. We came up with our own solutions with our own software. So what I do is I'm interested, well, our team became interested in accurate models that we can use in power systems. So obviously there are models that are used by chemists. I guess there are some chemists here, right? So you probably use for batteries very, very, well, difficult to understand models, let's call them like that are probably highly accurate. However, in my world, where it's about economics of the power system, these models are just too cumbersome and too computationally intractable to deal with. So we are looking at simple models that can be integrated in much larger models, where battery is just one part of that. So chemistry is one part. The second part is optimization. What do I mean by optimization? It's that economics part. Basically, us engineers, whenever we do optimization, the objective function is some kind of economical function, which means minimization of the cost, maximization of the profit, or something like that. And the constraints are technical. So we have certain constraints that we cannot put more charge in a battery that it can withstand, and things like that. And of course, coordination with the power system, which is actually where I started from. So the current focus is between chemistry, economics/optimization, so it's mathematics more or less, and power engineering. So why is this important? To charge your electric vehicle at the cheapest price, whatever that means, depending if you charge it at home, where it's relatively simple at this point, because we usually have 2 tariffs during the night and during the day, which is hopefully about to change very soon. Operation of an electric vehicle charging point aggregator. So if you own and or operate a large number of charging stations, you need to buy electricity from someone, and you need to sell this electricity to the EV owners. Provide services to the power system operator. I don't know if you know, but the frequency in our system is 50 hertz. In the US, it's 60, right? And it has to be within very, very tight boundaries around this number. So whenever frequency goes below 50 hertz, it means that we need more generation or less consumption, whatever we are okay with any. So in that sense, the system operator can calls for a service to bring the frequency to 50 hertz. It's usually done by hydropower plants or some other large power plants, but this can be done by EVs that are connected to the charging points or standalone battery systems. And of course, the second life EV battery is a stationary battery storage, where we in power systems are inclined to use something that people are almost ready to throw out as a relatively new asset in the power system, because we don't care about the mass of the batteries. We don't care if we have to install 50% more in volume, because we have a lot of space to put the batteries there. So how does this work? These are the prices of electricity in Netherlands today. Not retail prices, not the prices that this hotel pays or anyone who lives here, but these are the wholesale market prices. So as you can see, these prices change from 1 hour to another. And at the point where you bid how much you want to buy or sell, you don't know the prices upfront. So there's some kind of forecasting involved. So basically, you can see that electricity is, well, we treat it as any other good, right? You can sell it or buy it, but it's a very complex good. And you can see that there is pretty much no other good or service or anything else in the world whose price changes so abruptly. So it can change by 80% within a couple of hours. It doesn't happen with any other good in the world, that's for sure. So this is just to show you what your supplier, if you are a supplier of electricity, you have to buy at certain prices. You can hedge this risk, obviously, with some kind of financial instruments or buying long-term and stuff like that. And you sell this electricity to someone who needs it. We'll get back to this. So why is this important? This is the question, how do we model battery storage? I swear I will not have any other equations, or I will not even explain these, but this is just to show you a glimpse into the world of energy economics, where people say, okay, my charging power has to be between 0 and maximum charging power. My discharging power has to be between 0 and maximum discharging power. My state of energy, I use the term state of energy because I'm used to dealing with kilowatt hours, megawatt hours. I don't use state of charge. Sorry about that. But if you buy or sell electricity, it's in kilowatt hours. That's why I use state of energy. So my state of energy has to be between 0 and the maximum capacity of a battery. And obviously I need to keep track how much energy I have. So whatever I had in the previous hour plus whatever was charged into the battery minus whatever was discharged. So this is the type of model I'm using. So the people who know chemistry can see that I don't deal with surface area of an electrode with coatings or anything like that. I don't really care about that. So these are the high-level models that we use. Obviously, if you want to properly do it, there's a bunch of other approaches that are much more accurate: electrochemical models, electrical circuit models, stochastic models, analytical models, and so on and so on. So some of them require over 50 battery-related input parameters, which is definitely not something that we will use for this specific application. So we are trying to find some kind of balance here. So the only things that I can measure as an electrical engineer is the voltage and the current. I cannot measure anything else. Well, I can measure temperature, and that's it. So I can measure the voltage on the terminals of a battery cell, and I can measure how much current is going in or out, and that's it. And you can see that, if you remember that model that I showed you a couple of slides ago, it's definitely not accurate. Why? Well, first of all, battery fast charging ability is reduced at higher states of energy. You can fast charge your battery when its state of energy is low, but when it's close to being fully charged, you cannot charge it at high speed or high power or high current, whatever you want to call it. And this is relatively obvious when you look at the commercials of EV producers, and they say that specific vehicle can be charged up to 80%, let's say, in 32 minutes. But it doesn't tell you how much it requires to get to 100%. It takes 2 hours, regardless of the speed. That's because of the lithium-ion technology, although it has significantly improved with introduction of LFP cells. Then we have charging and discharging efficiencies, which means if you take 100 kilowatt hours from the grid, my battery will not have 100 kilowatt hours charged. It will have less, obviously. Each battery cycle slightly reduces its capacity, resulting in capacity fade, rate capacity effect, and battery terminal voltage characteristics are highly nonlinear. So there are lots of issues that I, as electrical engineering, can see. I don't want to go too deep into them, but I would like to transfer them to make my models more accurate. So what we did is we took a number of battery cells back in the day, pretty much representatives of all 5, 6. Well, now we have some other sub-technologies, but to represent all of them relatively in a fair way. And we did some tests. Obviously, you're probably aware of this figure. When you charge a lithium-ion battery cell, you charge it at a specific C rate. Have you heard of the term C rate? So a 10 amp hour battery cell, you charge it at 10 amps, which means that in theory, it should be charged within 1 hour. 1 hour times 10 amps equals 10 amp hours. Amp is ampere, right? So we put a cell here to 0.5 C, which means it should be charged within 2 hours. But to get fully charged, even after 3 hours, it wasn't fully charged, as you can see here. Why? Because 0.5 C corresponds to the current of 1.4 amps here, because the capacity is 2.8 amp hours. And what happened with the voltage, the blue curve, it started rising slowly, and then it hit the upper threshold. You shouldn't exceed the upper threshold prescribed by the battery manufacturer, otherwise something bad could happen. I'm not a chemist, I don't know what could happen. So what happens then is you should keep your voltage at this level and not bring it up anymore. How do you do it? You reduce the charging current, just to keep the voltage at this level. And then you reduce the charging current, which means that this charging characteristic is made of 2 parts. The first part is the constant current part, and the second part is the constant voltage part. And if you transfer that to power, this is the green curve, you can see that the power reduces greatly as the current reduces. That's why you cannot charge your lithium-ion battery cell to 100% quickly, because you need to reduce the current, because you entered into the voltage saturation phase or the constant voltage phase. However, the focus of this talk is on battery efficiency. Why is this important? I will show you here. So here you have two curves, two figures. On to the left, you can see the charging and discharging voltage at 0.2 C. And to the right-hand side, you can see the charging and discharging voltage at 1 C at higher speed. These curves are farther apart in the figure to the right. Why is this? This is because we are using higher charging speed, which means that we are less efficient. If these two curves, the blue and the red one, were one on top of the other, then the efficiency will be 100%. The farther apart they are, the efficiency is lower. And obviously, for higher charging speeds, we get lower charging and discharging efficiency, which basically you can see here. Energy efficiency is made of coulombic efficiency and voltage efficiency, which depends on the C rate. The higher the C rate, the farther apart they are. So I come from energy economics team. So my question was, how do I know what is the charging efficiency of my battery? If I charge it at 0.5 C, is this efficiency 98%, 92%, 91%? I don't know. So what we figured out is that there is no way you can measure one-way efficiency. You can measure, what you can do is, you can measure a round-trip efficiency. So you can measure how much energy was taken from the grid to be charged into the battery. And once you discharge the battery, you can measure how much energy you got out. So you know the round-trip efficiency when you compare those two numbers, and it should be below 100%, I guess, right? So you know the round-trip efficiency of a battery, which is okay at a specific C rate. You can also do that, which is okay, but I will show you later why. I'm very interested to know what is only charging efficiency at a specific C rate and only discharging efficiency at a specific C rate. So that was the question. So we decided to do some measurements. We said, okay, let's charge the battery at 0.2 C and discharge it at 0.2 C, and we got a round-trip efficiency, which in this case was 0.974. And we said, okay, let's charge it at 0.2 C rate and discharge at 0.5 C rate. And then the efficiency, the round-trip efficiency was lower. So the lowest efficiency was obviously for charging, both charging and discharging at 1 C. So from this data, we came up with optimization model to figure out from these measurements what are a single way efficiencies. So this is the algorithm, but I will not go through that. It's too complex actually. But what you can see here is the red line shows that, so the dashed gray line is ideal. So the red line shows that the higher the discharge rate, the less energy you get, well, in percentages, right? The less energy you get out from your battery. And you need to put much more energy in the blue curve. You need to put much more energy in to get the same amount of energy within your battery if you use higher C rates. So basically, from the experiments, we determined one-way efficiencies of LFP, NMC, LCO, and LTO. Obviously, LCO has the worst efficiency. The LTO has the highest efficiency, and we managed to get separate charging and discharging efficiency. Please note that they are not the same. One could say, okay, this research is stupid because you get the same charging and discharging efficiency, so you can just take a square root out of the round-trip efficiency and it's straightforward. We were lucky, they're not the same. So we hope that this research makes sense. Why does it make sense? I will show you in a simple model from my world. Here to the right, you can see 24 hourly prices in the day ahead market, one that I show you the curve at the beginning, right? So these are actual prices from some specific day. How do you perform arbitrage? That's how economists say buy when it's cheap, sell when it's high. That's called arbitrage. So basically what you would do is you would go through the hours and say, okay, find me the minimum price, which is at hour 4, and sell it at local maximum price, which is at hour number 5. And then at hour number 6, the price is lower again. So I buy it here and I watch price rises up. And at hour number 9, which is the local maximum, the hour before and the hour later have lower prices, right? And I sell it at hour 9. Then I identify hour number 14 as the local minimum again. So I do 3 times charging and discharging. I want to buy, let's say, 1 megawatt hour at hour number 4 at 90 euros per megawatt hour and sell it at hour number 5 at 125 euros. If my efficiency would be 100%, I would make some 35 euros, a little bit less than that in this one cycle. However, my efficiency is not 100%. It's less. And that's why I wanted to know what is the charging efficiency and what is the discharging efficiency. Because if you use that model that we came up with, the result is that you should charge slightly in hours number 3 and in hour number 4, because the difference in efficiency when you compare 0.5 C and 1 C of the charging efficiency is sufficient to overcome is sufficient to overcome relatively low difference in prices. So 6 euros against 90 euros, it's not much. It's less than 1%. But note that if you want to discharge here at hour number 19, that you do a full discharge in this 1 hour. The price difference in hour 19 is about 1%, a little bit more than 1%. So 10%, sorry about this, 10%. So the discharging efficiency reduction at 1C is not sufficient to justify the price difference. So we were actually looking to come up with good energy economics models to maximize the profits of investors in stationary energy storage. And that's why we came up with this model, how to measure and calculate after that single way efficiencies, which is now patented in Europe, US, and China. We came up with specific use cases. So if someone has some other use cases or is interested in this technology, feel free to let us know. Thank you very much. 8 seconds per board.
Very interesting stuff. And any questions?
Thanks. What have you factored the temperature in this the efficiency measurement?
So we have a chamber, so we did different measurements for different temperature rates. So it depends on the charging or discharging speed and the temperature. This is just for a specific temperature that I showed.
Okay. Any idea about the variance of the efficiency with the temperature increase or decrease?
Yeah, up to some 40 Celsius, it's pretty much the same as the room temperature. It's not much difference, but when it gets cold, the efficiency is much lower. You can see that. I just don't have the numbers here.
That's just.
It takes a lot of time to do all the measurements for all the cells. So.
Have you looked at the heat generation from inefficiencies as another parameter?
Well, that's how some people measure efficiency. So they measure what is the heat generation, and they subtract that.
It's got to go somewhere. It's usually heat.
Yeah.
Any other questions? All right. Okay. Well, let's thank our speaker again.
Thank you.
Today's session. I believe dinner is on your own, correct, Maria? So it's really good to kind of see the wide breadth of topics here. And I'm starting to see a lot of potential ideas of collaboration, right? I thought the safety talk today and how do you store your battery packs, got thermal cameras. Could we pair that with, say, some digital machine learning AI to automate an event if something happens, right? You see a heat flare spike up, automatically go drop in that bath, right? So keep talking to each other, exchange ideas. That's the whole reason why we're here. Learn something. And we'll begin tomorrow at 8:30, same place. Breakfast will be in the same place. So thank you again to all the speakers. Thank you so much for respecting the time. We appreciate that. And you were all dismissed.
Right. I will also tell my word, if you don't mind. So on behalf of Leadvent Group, I would like to thank all the speakers for their commitment and insightful presentation. Also, I want to remind you that your feedback is very important for us. Please fill out the evaluation forms and hand it over to me and my colleagues. And if there's anything that we as organizers can help you with, please don't hesitate to come to us. And also one important note, we have an open bar upstairs on the ground floor. It's working till 1945. So we have around an hour for continuing networking and enjoying this evening. And I hope to see you tomorrow. Have a nice evening.